Ladies and gentlemen, let me welcome you to the 13th EAI International Conference on Mobile Multimedia Communications, EAI MOBIMEDIA 2020. My name is Lukas Kolek, I'm the conference manager of MOBIMEDIA 2020, and unfortunately, due to this virus, I'm not able to meet all of you in person, so I would like to use this opportunity to address the organizing committee, the authors, and the participants on behalf of EAI. This way, I would like to thank Professor Hongyang Wang from the University of Massachusetts and Professor Lin Yun from Harbin Engineering University in particular for their excellent work on this conference. I would like to recognize the importance of academic sponsors of this event, which were Harbin Institute of Technology and Harbin Engineering University. I would like to bring to your attention the availability of the brochures for MOBIMEDIA 2020, which can be downloaded on the conference website. Another important part of our online conferences is the opportunity to ask questions and participate in the Q&A session, which takes place on a website called Slack. You can access our Slack workspace via a link underneath this video, and once you are in this environment, you can enter conversation about each separate paper. Secondly, there is also the EAI Compass, where you can leave feedback to your fellow presenters and vote on their performance. We will shortly show you how to access this platform and how to leave and receive feedback for the presentations in this conference. Ladies and gentlemen, I would also like to invite you to the next year of MOBIMEDIA conference. In 2021, MOBIMEDIA will take place in Guizhou, China. We look forward to this event and we hope many of you will have the opportunity to join us on that meeting as well. Right now, it's time to introduce the following presentation, which will be delivered by my colleague at EAI, Michal. Michal will talk more about EAI tools and also go into more detail about aforementioned voting on each presented paper, which you can already use on this very conference. Thank you for your attention.
Hi everyone, my name is Michal Dudic. I'm the community manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Everyone, my name is Zhang. I'm from the University of New South Wales, Sydney, Australia. I'm very glad to share my recent research results on Cybertwin, a pathway to 6G, with all of you. This is a joint work with Professor Yu Quan and his group in the Puncturing lab, and this result has been published in the Archway Wireless Communication magazine in December 2019.
Next-generation networks will face the demand of billions of people and hundreds of billions of devices to be connected. Accordingly, the future network architecture is expected to accommodate the explosively increasing mobile internet traffic and various services and applications through heterogeneous networks. Internet of Everything, IoE, has been considered as the future of the Internet, and could achieve intelligent connection of humans, processes, data, and things with the help of next-generation mobile communication and artificial intelligence technology to make network connection more relevant and valuable than ever before. In comparison with the traditional end-to-end connection, a revolutionary feature of network architecture in IoE is to support ubiquitous data collection, aggregation, fusion, processing, distribution, and services. Recently, cloud computing-centric network architecture was provided to achieve network resource sharing to handle the big data explosion from ROE devices and to simplify management tasks. However, there are still many challenges in providing scalability, security, mobility, and network security for future network architecture designs. In this work, we propose a Cybertwin-based cloud-centric network architecture for future generation networks. Cybertwin is a digital representation of humans or things in the virtual cyberspace and is located at the edge cloud. It serves in multiple capacities, that is, communication assistant, network data logger, and digital asset owner. It provides a new Cybertwin-based communication model to replace the end-to-end communication model. Cybertwin is a virtual network ID of human and things. As an assistant of human or thing in the physical world, Cybertwin can better achieve various quality of service because it knows well the user's quality of services and will pay the cost to negotiate with the telecommunication operators and the cloud operators for the resource. In the proposed network architecture design, communication should be completed through Cybertwin. It means that the Cybertwin can contain and log all data about the end behavior in a real-time fashion. Cybertwin can also convert this logged behavior data into a digital asset by processing this data as a service and publishing the services to other entities, including the application service providers and cloud operators. One of the benefits of using Cybertwin is to support the locator and identifier splitting. In existing networks, the bottleneck problem to implement locator and identifier split is the lack of an identity authentication mechanism. In the proposed Cybertwin-based cloud-centric network architecture, we use the locator and identifier split scheme to offer benefits on scalability using two independent namespaces for naming and addressing. It uses an object ID with a 128-bit IPv6 format or 48-bit EUI-48 format to identify humans, devices, and services, data, and application in the cyberspace. The network address, such as IPv4 or IPv6, becomes an internal address, which is opaque to the external address. We can build a mapping between object ID and network addresses in cyberspace to link the ends with access point and save the IP addresses. Hence, the address exhaustion problem can be alleviated by the mixed use of object ID and network address. The fundamental shift from the fixed to mobile traffic in Internet usage represents a unique and timely opportunity to take into account the special requirement of mobile devices and applications. Adding mobility to the current Internet architecture is challenging because the current Internet naming system is based on the host address, typically the IP address. We propose to build a mapping between object ID and the network address in cyberspace to support mobility. The mapping can be dynamically managed in the core clouds and edge clouds. The end devices get the mapping from an edge cloud, and the edge cloud further obtain the mapping information from a core cloud. Then we can build a cyber-physical social system, CPSS indexing system, to exhibit the mobility of a human or thing and the location of network services. A massive number of users and large-scale cloud-centric network in future generation networks pose great challenges in the application in allocation of multidimensional resources, that is computing, caching, and communication resources. We advocate a new cloud network operating system which can work in a distributed way via establishing a real-time market-driven trading platform for multi-agents, that is, the end telecommunication operators, application service providers, and cloud operators. On this platform, the multidimensional resources will be priced based on the scarcity of the resources dynamically based on some economic principle. For example, traffic demand, importance and popularity of services, and so on. To support this real-time trading platform, resource virtualization methods like SDN and NFV can be employed in a limited scope and used as the basis for the cloud network operating system that runs in a broader range in a distributed way as shown in this figure. Some other technologies, including mobility management, authentication, statistics, and optimization, are applied for providing the capability of scheduling and orchestration, which use a virtualized resource to perform the contract signed through the real-time trading platform. As shown in this figure, application services and digital assets data service can be performed on top of the cloud network operating system. Further, in this work, we propose a fully decoupled regional area network for the 6G. In the fully decoupled RAN, a control base station works as a micro base station, covering a large area in which there are several data base stations operate as micro base stations. The user equipment connects to the control base station through a dedicated low-frequency FDD control channel by reusing the legacy 2G, 3G infrastructures or spectral resources, which can realize the low-latency control signaling exchange between the user equipment and the network. Through this control channel, user equipment can receive control signaling from the control base station and report their own state and requirements to the control base station. By collecting the feedback information from UE, the control base station can obtain the network state, which can help make control decisions. The control base station also connects to all data base stations within the same area to configure high-level control decision and policy. Guided by these policies, a database station performs fine-grained resource control and delivers the data for UEs connected to it. With the physical separation of control and user plane at the RAN side, the control base station and database station can coordinately manage the spectral resource in different dimension and granularity. We further decouple the database station into downlink base station and uplink base stations, which are responsible for downlink and uplink user data transmission respectively. By this full decoupling, spectral resources will not be utilized in a pair manner as in the FDD, and also will not be wasted by the guard interval in the TDD. In a fully decoupled RAN, any piece of the spectrum can be used for either uplink or downlink transmission, which can enable the control base station to cooperate spectral resources. In RAN, as the UL and DL links are asymmetric, the transmission power consumed by the UEs and base station are also different. The proposed fully decoupled RAN deploys uplink base station in an ultra-dense manner to make them close enough to user equipment, which can experience less path loss and cost less energy. On the other hand, the number of downlink base stations is much smaller than that of the uplink base stations. Even a single downlink base station should transmit with high power to serve a large area. The total power consumption of all base stations is more efficient at reducing the number of their base stations. Therefore, with the proposed fully decoupled RAN architecture, energy costs at both UE side and network side will be cut down. In fully decoupled RAN, coordinated multiple point comp can be implemented more flexibly and efficiently with separated uplink-downlink base station. As shown in the figure, by taking advantage of coordination among different transmission points, advanced distributed and coordinated transmission mechanisms such as intercell coverage, enhancement, interference avoidance, and receiver diversity can be all utilized.
a calculation method of vCPU occupancy rate of virtual machine forwarding process. I'm Lu Hua. The contents have three parts. One, NFV and software forward. Direction of network development is cloudization. Three cloud architecture are central cloud, regional cloud, and edge cloud, according to different equipment user costs and other factors. Communication network element virtualization is deployed in different clouds. For example, delay-sensitive VNF are deployed in the edge cloud. CDN is deployed in the edge cloud, and the user obtain contents from the edge cloud to reduce traffic impact on the mature network and the backbone network. Many of those virtualized VNF network elements are virtualized by the forwarding plane, such as vCPU, vRouter, vBus, vUPF, etc. This is a great challenge to the forwarding capability of the x86 architecture. Here we are being to introduce three typical models of software forwarding on the server. The first is OS DBDK plus DBDK. Host OS deploys OS DBDK and when guest OS deploys DBDK, its features are user mode directly access the NIC receiving memory, keep the kernel mode, improve the forwarding performance. OS DBDK can flexibly exchange packets between them on the server or different servers by matching the flow table. OS DBDK can be controlled by SDN controller. Flexibly forward all kinds of traffic and support service chain. The visual switch implemented will consume some CPU resource, and the forwarding performance is greatly improved compared to the standard OS, but it is still insufficient. The second is SRV plus DBDK. When guest OS deploys DBDK, through SRV technology, The WAM directory fetches packet from the NIC completely bypassing the processing of the kernel mode and the user mode on the host OS. The performance is almost equivalent to the processing of sending and receiving packet on the host OS. SRIOV need to bound the VF on the NIC to each VM, which has insufficient flexibility and is suitable for NFV applications in fixed case. The third is Smart NIC plus DBTK. When guest OS deploys DBTK, sync the OS to the Smart Network Card processing. Release CPU resource when send and receive packet, which the Smart Network Card through SRIOV. Okay, two part. CPU occupancy problem. In order to improve the software forwarding performance, the forwarding process needs to bend the core to exclusive vCPU resource for the while loop packet processing. Since the vCPU bound by the forwarding process runs in an endless loop, the vCPU will not enter the idle process. So, the vCPU utilization is always 100%. Hardware resource. All VMs on the server share the hardware resource of the server. Shared P cache, D cache, Level 3 cache, system bus, memory, etc. If hardware resources are occupied, the process needs to wait. Resource conflict will cause performance degradation. The degree of resource conflict is different at any time, so the impact on performance is also different. The problem 1. What's the current CPU usage? 2. Is the multi-vCPU's load balance of the VM average? 3. The VM cannot be scaled out in time, causing packet loss and delay, affects the user experience. 4. In mixed traffic case, the experience value of a single traffic is not referenced. How to do? 3-part solutions. We have designed a vCPU calculation method. There are two cases of initial state and operating state. Initial state step is obtains the crystal cycle, trigger baseline packet to forwarding process, receive baseline packet, get processing time, calculate the number of baseline packets that can be processed in a cycle, obtains various packet statistics and weight value, calculated vCPU occupancy rate. Operating state. Considering that the virtualized environment use hardware resources such as CPU, memory, and system bus, etc. The baseline packet processing time may be different at any time, so a timer is added to perform period calculation. Other steps are the same as the initial state. Finally, we draw a graph of vCPU occupancy through the test results. The hardware plant using the Intel Golden 5118 process. Software platform using BTKT 8.11 version, and the vRoot version support IPv4 net and IPsec. The tester is Sprint Test Center. The tester throughput is 1 Gbps. We can see that under the same throughput, IPv4 vCPU occupancy is the lowest, IPsec is the highest, and the system tools statistics of vCPU occupancy is always 100%. Because the test environment is limited, we didn't do the test and complete mixed traffic conditions. Otherwise, it can better reflect the timeliness and accuracy of the calculation method. Thank you.
Today, the topic of my speech is a large capacity program packet forwarding device. Welcome to listen. In the 5th generation of beyond 5th generation era, the need of various new switches for network, bandwidth, delay, and cost is far different. To use the network processor to realize the packet forwarding cannot support the large capacity and low delay. To use the fixed pipeline to realize the packet forwarding cannot be programmable. Now the packet forwarding device does not meet the requirement of the 5th generation of beyond 5th generation high capacity and low delay. So we must study a new programmable switching architecture and realize the program packet target, programmable packet processing unit, and the programmable packet editor to solve the above problems. The structure of the programmable switch device is composed of the packet target module, several packet processing units, and the programmable packet editor module. First, the packet enters the program packet target module for analysis. Obtaining the structure of the packet, putting the target result into the metadata of the packet, and send them to the subsequent module CPU for processing. The start of each CPU is the same. Each CPU takes the corresponding key from the metadata of the packet and those configured in the lookup table to match. The content of the corresponding entry in the table are taken out and put them into the metadata of the packet. Sent to the next CPU for processing. After processed by the CPU, the metadata of the packet is sent to the packet editor module for generation new packet. Finally, forward the packet to the destination port. The main function of the programmable packet target is analyze the packet according to the packet target database and move the key field of the packet to the metadata. The target database is composed of matching row table and the match action table. The matching row table is in the target table need to support the mass matching function, may be realized by the secant. The matching row table need to store the keyword to be compared and the current state, while the former need to support mass matching as each length may be less than the y of the matching row table, and this cannot not be considered can be mastered. The action table stores the next state, the address of the key to be extracted from the packet next time, and the operation instructions that need to move the key of the packet header to metadata. The packet target first obtains one initial state and for initial set address according to the input port register, obtaining for corresponding key from the packet according to the later. After supplying this key with the initial state, look at the matching table of the packet target base. Repeating the action of the matching row table, read the action table according to the address or answer, obtaining the next state and for a set address from the action table in the database. Each key or set address can be extracted one byte key from the packet header, while they are set and the day length corresponding to each other one by one are given in the packet target database. Day length is 2 bits, indicate how length can be extracted by the day set. One-time matching theorem can get out 8 valid day set and the day length. That is to say, Up to 8 fields can be extracted from the packet and put to the metadata. According to the key asset obtained from the matching entry of the packet target database, the keyword corresponding to 4 bytes is extracted from the packet. After that, the next step is obtained from the table, with the corresponding search result obtained from the packet target data again. That is the next step and the asset address of 4 match keys. At the same time, the packet target database provides up to 8 asset address and the date length. According to the asset address and the date length, up to 8 dates are extracted from the packet and stored on the metadata. Then the process declared a byte is repeated to match the packet target data again until the next state is 255. Since the packet target database can be configured by server, the packet target can analyze any packet by configuring the packet target database according to the format of the packet. The example of packet target similar to the described above. I will not elaborate anymore. The whole program packet processing unit is composed of the lookup table condition decision module, lookup key generation and hash calculation module, lookup table read and write control module, and the lookup table result process module. The condition decision module of lookup table consists of an lookup table decision maker, each of which is composed of identical comparator able to perform the judgment of greater than, less than, equal, not equal. Each comparator has a control register storing the address of the match key in the packet metadata in terms of whether match the key is immediate or not. It is an immediate number. The value of the compare number is stored in not the match key address of the packet metadata. Simultaneously, the mask of the match key is also included. Before the comparison operation, the match key first needs to do an operation with the mask register by bit, then perform the comparison operation. In the end, the judgment or result of the comparator and keyed file from the method according to the address indicated by the lookup table. Adjudicator are combined to search a depend. The lookup table decision maker can be used independent, each of which corresponding to the lookup table. On the other hand, the multiple lookup table decision maker can use join to search a lookup table as a decision condition, at which time the number of the lookup table supported by the queue becomes smaller, yet the support lookup table decision conditions are more complex than the single lookup table decision maker. The flag of the whether the lookup table inside the PPU or outside PPU and the number of the lookup table to the indicate which lookup table to look at given before it's run. Each lookup table contains configuration registers, which are used to indicate how to generate keyword to search the lookup table. Each register contains a byte of the corresponding key in the partition of the tag metadata, and the bit length of the byte is very big. In terms of the register, each byte of the match key is extracted from the metadata, which extract the byte. They are combined into the temporary lookup keys according to the register order. Finally, being very big inside the temporary lookup table key are write to generate the lookup table key according to the configuration. The corresponding hash function is selected to calculate the hash index. In this paper, the double hash lookup is supported. Thus, for each lookup key, two different hash functions are used to calculate the hash index simultaneously. PPU lookup table read-write control is the flexible. Change the size of the lookup table by configure the radical. This module is divided into read-write control of the lookup table inside PPU and then outside the PPU. But the two of the lookup table read-write control modules are almost the same. When the hash table read-write control logic inside the queue receives the lookup table request, it decodes it into the logical table number of the hash table is according with the request sort. Each run block in the PPU thread is run attributed radical according to the request and the address of the lookup table. Then checking the logic number of the request lookup table and the number of the config in the run block attributed radical. Thus, the address of the lookup table in the run block of the lookup table. In the meantime, the run address is generated according to the lookup table address and the run is read, after which the date is put into the reduced radical according to the logical number column number in the attribute radical of the run block. The lookup table result processing model is mainly based on the processing result of the preset PPU of the packet parser model and the result of this lookup table to merge and generate a new metadata transferring the next PPU of the program packet editor module. The lookup table processing module generates an instruction database, each entry of which contains a URLLC instruction. Each instruction can perform the following action: move the lookup table result date to the metadata, move the metadata on the metadata to the other location of the metadata, perform the logic operation include operation not inclusive of, perform the arithmetic operation add and subtract, but not multiply and divide. Perform shift operation include left shift and right shift. Set the immediate number to the metadata. The program packet editor module uses the result of the PP process to extract the metadata from the packet field and merge them into a new packet header. Then taking out the payload from the packet buffer, splicing the new packet header and the payload to generate new packet. The packet editor module needs to become almost completely protocol header as well as define the location where each the protocol header key field is in the metadata as the packet editor database. During the packet editing, we can take out each byte from the metadata according to the location indicated by the packet editor database and then splice into from a new packet header. The packet editor database stores the partition information of the corresponding file of the packet in the metadata. The first of the DA field of the packet, which has 6 bytes in total, that like the location of the packet in the metadata, with the next one of the SA field in the metadata and the first one of the VLAN field in the metadata, and the last one of the isnet type field in the metadata. During package editing, the corresponding fields are taken out from the metadata according to the stored in the package editing database, spliced into the package. For example, when editing a package, the hybrid file of the DA is taken from the package database at the address of the 45 of the metadata, using which to take the corresponding content of the file from the metadata placed at the position of the first byte of the package, then the position of 44 of the next byte of DA is taken from the package editor database, from which of the metadata take out the content of DA4, spliced after the defined. Similar in the other file until the new package header is assembly finished. Finally, afterward, a new package composed of the original payload is spliced with the new package header forward the output port indicated by the metadata. The paper is popular to solve the problem. Current network processor cannot meet the requirement of the low latency and the large capacity exchange, as well as to avoid the problem that the fixed pipeline forward cannot meet the rapid deployment of the new service. The forwarding behavior can be trained according to the need of the service by the server programming, which can meet the need of the 5 generation or beyond 5 generation new service, rapid deployment, large capacity, low latency, and low energy consumption. Thank you.
Hi, everybody. My name is Zhang Huang. I'm honored to have the chance to present my paper. The topic of my paper is automatic modulation classification using dense memory fusion network. The outline of my talk as follows. The first part, I want to introduce the abstract and the background. The second part suggests a program statement. The third part covers DMFM-based modulation classification. And then we introduce the simulation results. Finally, a simple conclusion is given. Well, let's move on to the first part of this topic. We propose a novel dense memory fusion neural network based automatic modulation classification method and a feature extracted from the received signal with low computational complexity grade constellation matrix. DMFM with dense node designed to extract high representative feature and the following unit of long short-term memory and 4 connected layers are used to make classification decisions. The goal of this paper is to achieve a balance between computational complexity and recognition accuracy. In this paper, we utilize DMFM and DCM to complete AMC task and reach this goal. AMC has various applications, including those areas, and so on. In general, AMC method can be roughly divided into two different types, which are the likelihood-based and feature-based approaches. Likelihood-based method take AMC as a hypothesis testing problem, which can get the optimal solution and Bayesian sense by minimizing the probability of misclassification. However, when the receiving signal appears parameters of an unknown probability distribution, the complexity of this method increases and the robustness decreases. Though feature-based methods are suboptimal methods, it is easier to apply in practical implementations than the former method because of its low computational complexity and less prior knowledge required. So, this paper is going to improve the performance of feature-based methods to get more classification accuracy gain. Let's move on to part 2, program statement. The received baseband signal is as follows, where A and XL represent the unknown amplitude and symbol sequence, respectively. H denotes the channel effects and is invariant during the AMC process. FO is the frequency offset, and theta n represents the phase jitter. T and epsilon t are the symbol spacing and timing error respectively. Let's move on to the system model. I want to use a picture to illustrate it. It can be roughly divided into two modules, feature extraction module and LSTM-based classification module. Firstly, the raw IQ signal should go through the feature extraction module, which can extract GCM feature different from the raw IQ feature and the traditional constellation. Secondly, we utilize the GCM as the input of the classification. Finally, we got the hypothesis HK of this AMC issue, in which K is equal to 5 in this program. In order to facilitate the network to learn effective representations from the signal, the received signal are transformed into GCM. Firstly, we pre-draw the M plus N grid on the regular constellation. Secondly, we calculate the number of sample points that fall in each grid. And finally, after all the sample points are calculated, we normalize the M plus N grid, resulting in a grayscale matrix image that represent lattice density of the constellation map. Some example of GCM for 5 modulation formats under signal-to-noise ratio is equal to 8 dB are given. As is shown in this figure, the DMFM mainly consists of 2 modules, the feature extraction module and the classification module. The feature extraction module extracts the deep representations from the raw GCM images. The classification module utilizes the deep high-dimensional representations to perform the final classification decision. The loss function consists of 2 parts, cross-entropy loss and regular time. Cross-entropy loss function is most widely used in multi-classification tasks, and in order to prevent the network weights from taking extremely large values and overfitting, we add a regularization term to the cross-entropy loss. Let's move on to the simulation part. In this section, extensive simulations are conducted to illustrate the superiority and offset robustness of the proposed DMFN. Signal-to-noise ratio ranges from -6 dB to 14 dB with a step of 2 dB. The candidate modulation set is BPSK, QPSK, 8PSK, 16COM, 64COM. Performance metric is PCC, the probability of correct classification, which is given as this function. This figure shows the classification performance of DMFN versus signal-to-noise ratio with different symbol lengths. It is obvious that better classification performance is achieved by using more signal symbols. The classification accuracy reaches 94.94% when the signal-to-noise ratio is 6 dB and the symbol length is 128. This figure illustrates that the performance of DMFN is better than the other 2 AMC methods. ResNet and AlexNet under the same symbol length and signal-to-noise ratio, as is shown in this picture. Given the same symbol length for ResNet and AlexNet, the performer is better than the latter overall. However, both of them are slightly insufficient compared with DMFN. The performance gain yielded by DMFN deep learning model can be explained by the combination of DenseNet and LSTM structure. This figure compares the robustness of proposed DMFN, ResNet, and AlexNet. It can be observed that the frequency of set severely degrades the classification performance, and DMFN performance best of all, providing its robustness to frequency of set. Well, it's time to give a brief conclusion. In this paper, we proposed a GCM-based AMC method named DMFN. Firstly, GCM are utilized as an initial input of the network. Secondly, a DenseNet construction is conducted to extract distinguishable feature from GCM, and a LSTM-based classifier is designed to make classification decisions. Finally, extensive simulations are designed to verify the superiority and robustness of DMFN compared with other existing methods. That's all. Thank you for your time.
Hello, I am very pleased to be here to join this forum. The topic of my presentation is automatic modulation classification using hybrid convolutional neural network. With the rapid development of the wireless communications, new paradigms of the telecommunications emerge correctly. However, the shortage of the wireless spectrum is becoming an outstanding problem, with the task of ensuring the proper functioning of the radio spectral sensing. Automatic modulation classification is recognized essentially as the link between signal receiving and demodulation to identify the signal profile corrupted by noise. In this work, efforts were made to enhance AMC manners to increase classification performance. Our proposed method, HCNN, involving deep convolutional neural network and attention-based densely convolutional neural network. These two networks are designed to classify more modulations. Informal HDCNN, deeper network structure, and the dropout layers can extract high-dimensional features directly to obtain better performance and avoid off-fitting. In later HDCNN, it combines the densely convolutional neural network and the attention block. It enhances the ability of feature extraction and reduces the network parameters simultaneously. Generally, AMC matters can be divided into two methodologies. For example, likelihood-based matters and feature-based matters. LB matters have a better integrated performance of precision. However, LB matters need prior knowledge of statistics information of the signals, which increase the computational capacity in practice. Comparatively, FV methods deal with simulation classification straightforwardly without prior information, which can achieve low computation complexity and good robustness. Therefore, on this basis, this paper focused on improving classification accuracy of FV methods. Different features are widely utilized in FV methods, including high-order statistics, circle trajectory spectrum, and some others. However, single feature lacks the ability to deal with classification among modulations. Generally, convolutional neural network-based AMC methods have strong respective ability to improve the classification accuracy. With the optimization of the network structure, classification performance increasing as well. In this paper, several contributions are listed as follows. First one, considering the variance of signal features, the signal structural correlation features, SCFs, and regular oscillations image, RCS, are represented as the inputs of the HCN representatively, with SCFs and RCS. Signal high demonstration features are considered. The second, deeper network structure and dropout layers, which can extract high dimensional features directly and avoid overfitting, are exponent to obtain better performance in DCNN. The third one, ADCN combines the densely convolutional neural network and the attention block. It enhances the ability of feature extraction and reduces the network parameters simultaneously. The fourth, DCNN provides the classification ability among 2 FSK, 4 FSK, MSK, and the BPSK. Meanwhile, ADCN is utilized to improve the classification accuracy among QPSK, 16-com, and 64-com. Simulations results show that higher classification accuracy is achieved comparing to existing MC methods with lower computational complexity. We assume that the radio frequency signals are received by the signal antenna receiver. The signal transformed to baseband can be performed as follows, where H denotes the relating channel, F and theta denotes the frequency and the phase offset, omega denotes the AWGN, and N denotes the signal sample length. The signal features in our paper are circle spectrums and signal constellations. Considering various modulation have various signal circle spectrums. Signal circle spectrum can be exploited for MC. By normalization, the 3-dimensional circle spectrum along the Z, the 3D circle spectrum can be normalized to the 2D circle spectrum in the XY plane. Therefore, we extract the SCFs from signal circle spectrum. Some examples of SCFs and different modulations are presented. The figure shows that SCFs among 2 FSK, 4 FSK, MSK, BPSK have distinct patterns, while QPSK, 16-com, 64-com represented in the same form as SCFs. To further classify modulations of QPSK, 60-com, and 64-com, received complex signal symbols are transformed into RCs as the input of the network. We plot the real and imaginary parts of the signals by transforming the signal samples into 2D structure diagrams as RCs. Practically, RCs are widely used to learn effective representations from signals. A generation diagram is conducted as followed to illustrate RCs of the three widely used modulations at different SNRs. For different modulation formats under the same SNR, RCs are used to represent signals. Generally, RCs provide a new approach to extend its representation discriminations. Our proposed HCNN consists of two CNNs, so as to classify 7 modulations of BPSK, QPSK, 2FSK, 4FSK, MSK, 16-com, and 64-com. As shown in the picture, the former SCNN, DCNN, is designed to classify modulation formats except QPSK, 16-com, and 64-com. Since the translation elimination of SCFs, the later CNN, ADCNN, treated with signal RCs, is designed to classify QPSK, 60-com, and 64-com. DCNN includes 3 convolutional blocks, 1 fusion block, and 3 fully connected blocks. Each convolutional block consists of 4 convolutional layers, followed by batch normalization. In first 3 convolutional layers, convolutional kernel size decreased to 3 and strike step set at 1 in order to realize spaced connectivity between layers. Especially, the 44 layer, whose strike step is 2, replace the max proving layer to prevent a feature loss in downsampling. Value function is recognized to decrease spacity and nonlinearity. Besides, the channels are incremental among convolutional blocks, intending to get enough receptive fits. The fusion block unifies the form of feature representations for the fully connections blocks by convolutional layer and fusion layer. In fully connected blocks, there are 3 fully connected convolutional layers to reduce output channels and the computation complexity. Additionally, the output channel number of the last hidden layer is limited to 2, which indicates that the dimension of the deep feature is reduced to 2 and beneficial to 2D visualization. Finally, with softmax, the output layer could sum to 1 and map multiple scalars to probability distributions. ADCNN consists of 4 parts: attention blocks, convolutional layers, max pooling layers, and fully connected blocks. Initially, attention block is composed of dense convolutional block and attention layer. For dense convolutional block, it has directly connections among layers, incorporating both accuracy and efficiency. Dense convolutional block brings 2 advantages. Firstly, it solves the problem of network gradient disappearance and explosion. Secondly, it reduces the parameters that high-dimensional features can be extracted with low computational complexity. Besides, attention layer is added after every 2 convolutional layers in dense convolution block. For attention layer, it could recalibrate the feature channel width by calculating the interdependence among channels and improve significant performance of the most advanced architecture. In this part, In this part, simulations are operational to illustrate the superiority of HCNN. The signal candidate modulation format set is I. True FSK, full FSK, MSK, BPFSK, QPSK, 16-com, and 64-com. Firstly, we compare the performance of HCNN at different settings of the sample length. For same sample length, the HCNN performs consistently with the range of SNRs, proving the predictability of HCNN. Moreover, better classification performance by exploring more signal samples, proving the better behavior of HCNN. Secondly, we compare the performance of different methods. For example, HCNN with both DCNN, CNN with RCs, and CNN with SCFs, and different SNRs. And the sample length is set as 4096. The result verifies that proposed CNN outperforms the others for the entire SNR range. Especially, HCNN is 3 dB gains over HCNN with both DCNN at 95%, illustrating the superiority of the HCNN. However, the accuracy is only up to 63% when using a single kind of signal feature, shows the wide range of the classification modulations of HCNN. The reason can from two aspects. Initially, ADCN can extract more discriminative features from input features. Additionally, it is illustrated that signal feature limits the types of the classification modulations. In conclusion, in this paper, a novel AMC method named HCNN is proposed. First of all, HCNN combines with DCNN and ADCNN to make classification decisions of 7 modulations with high accuracy. Besides, SCFs and RCS are conducted repeatedly to expand the modulations of classification. Simulations results modify the accuracy, stability, and the log computational complexity of the HCNN. And in the end, thanks for your attention.
Well, my name is Mai Jiajie. The paper's name is Feature Fusion Convolutional Network Based Automatic Modulation Classification. Here, I want to introduce the whole contents of the paper and why the proposed method is effective. The first part is abstract. Aiming at a commonly used feature-based approach in practice, we proposed a novel AMC model that jointly utilized the constellation map and cyclic spectral density map as the signal features in this paper. In order to provide a solution for the model, we put forward a feature-based and supervised network in SISO systems to identify 7 kinds of signals, which is called Feature Fusion Convolutional Network. Generally, there are 2 basic methods of the AMC algorithm: likelihood-based and feature-based algorithm. The LB, which is likelihood-based methods, is used to calculate the likelihood equipment of the received signals in different modulation modes. When the channel and noise are fixed, the algorithm can maximize the possibility of correct classification, so it is regarded as the best classifiers in the scenario. However, despite of its excellent performance, it might cause the high computational complexity and low performance when handling small scales or sparse data. Compared to the likelihood-based approach, the feature-based methods assure the signal features involving cumulants, valence features, and so on to classify the formats with low computational complexity. Although the performance of FB is worse than LB in many scenarios, FB reduced the computational complexity and achieved the low time cost and high reboundness. As a result, FB is widely implemented in practical applications. And there are three main contributions made in this paper. Firstly, in contrast to traditional methods, we proposed a novel AMC model based on discrete signal processed by both constellation map and cyclic spectral density map. We normalized the heterogeneous data from the two maps into the same specification and combined it in the same dimension. Then, according to the format of input, we normalized the residual neural network 18 in FFCN. Depending on the efficiency success rate, cross entropy is selected as our loss function to promote the classification ability of the residual neural network to the maximum extent. Lastly, extensive simulations are carried out, and it is proven that the proposed network is able to automatically learn more discriminative features for recognition performance improvements due to the advantage of powerful ability in ascertaining features of matrix-shaped data. The next section is introduction. With the rapid development of wireless communication and their corresponding service, wireless communication standards and technologies arrive like the 5th generation system. 5G is designed to meet the expanding demand of global communication in the near future. Three essential technologies in 5G are optimized OFDM basic waveform, multiple access, and flexible framework respectively. However, due to the large number of communication standards, the radio environment is becoming increasingly disordered, making it more difficult to enforce the spectral monitoring. Automatic modulation classification can refine such a situation, as it enables the supervision of interference signals, and it can also applied in many military and civilian applications, such as the bridge between signal detection and demodulations. There are two concised introductions of deep neural network and residual neural network, which is the basic algorithm of the proposed framework in my paper. Deep neural network is one of the most essential basic of deep learning and is really crucial on artificial intelligence. Residual neural networks is a source of supervised machine learning and can identify patterns in data according to different inputs, such as examples, direct experiments, or instruction. The number in the residual neural network 18 means the amount of the hidden layer. Then, three traditional classifiers I will utilize for contrast experiment. SVM is basically a two-class classifier depend on the idea of large margin and mapping data into higher dimensional space. KNN is considered to be one of the best classification algorithms under the vector space model. Random forest refers to an algorithm that uses multiple decision trees to change and predict samples. But the next section is to introduce the proposed methods in this paper. In the beginning, I want to introduce the mathematical expression of the received baseband signal on the antennas. Rn is the received baseband signal and H is the channel parameters. And F0 and θ0 here denote the frequency and phase offset. Xn represents the nth complex symbol with unit advantage power, while Wn represents the noise. As far as the noise is concerned, we choose the additive Gaussian white noise. The reason of it is that we prefer synthetic noise to real noise, which brings the advantage that it is easy to analyze the problem and design the algorithm. Before designing the whole framework, I have to decide which kind of aspect features needed and which kind of signal is meaningful to classify in order to show the advantage of feature fusion. The constellation map and cyclic spectral density map are two typical aspect features that I employed eventually. The constellation is a popular and simple feature, but the theory of the cyclic spectral density is relatively complex. The mathematical expression of it is shown here. S here represents the cyclic spectral density, and the coefficient R here represents the cyclic autocorrelation intensity of the frequency alpha. And alpha is called the cyclic frequency of signal xt. In terms of the constellation, it is quite difficult to recognize the difference of MFSK modulation, and the image of QPSK and MQAM is really similar in the cyclic spectral density map. However, this condition can be tackled by switching their aspect features, which provide a perfect chance to prove the feasibility of feature fusion. Here are all the expressions of the chosen modulation. Then, I want to show all the modulation types in different SNR in two forms. The constellation is on the left. It demonstrates that the difference between BFSK and QFSK modulation is hard to identify no matter at what SNR, and the other 5 modulation types can be easily identified in low noise level but not high loss level. Well, it is possible that in this figure, the MQM signal is difficult to recognize no matter in what SNR. It is just because I have reduced the size of the picture. If you enlarge the picture, you can still easily recognize this at a glance. The cyclic spectral density map is on the right. As you can see, the image of QPSK and MQAM are nearly the same, but the difference of MFSK signal is easy to find. Then, I personally divide the whole framework into 2 parts, which are data processing and network chaining. Here, I want to introduce the whole process of data processing. Firstly, I generated the signals by MATLAB in the form of IQ points. When generating the signals, I will introduce different amount of Gaussian white noise. Then, I will transfer the original signal to the constellation and cyclic spectral density map respectively. Due to the demand of network chaining in Python, the input of the network must be as the form of matrix or vector. After considering the number of the sample points, I decided to format the 2 images into a 50+50 matrix. In constellation matrix, each value of a single grid means the amount of points located in that area. In constellation map, in cyclic spectral density map, each value of a single grid means the advanced density in that area. In addition to formulate the matrix, normalization is indispensable because when generating the cyclic spectral density map, all the value of the density is per-normalized, which vary greatly in value compared with the constellation matrix. So, I have to normalize the value in constellation matrix to the range of 0 and 1. Lastly, on the purpose of feature fusion, I combine the two matrices together and form a two-dimension 50 plus 50 matrix as the input of network. In this paper, I want to introduce another part of my model, the network chaining. As I mentioned above, my network model is mainly based on RNN, and I haven't changed the main structure of it. To make the network more practical and perform well, I modified it on 2 points. The first and foremost one is the modification before the second convolutional layer. In the initial design, the first step in network operation is to pass the feature through a 7 plus 7 convolutional layer and a 3 plus 3 maximum polling layer. The significance of this block is to reduce the scale of the input features, like the high-resolution image. But since the quality and length of the signal received in a single time, the number of the sample points generated is usually too small to build such a large matrix. So I changed the original block to a convolutional layer with string equals to 1, just like the convolutional block followed. In this way, not only can I prevent the loss of information due to downsigning, I can also implement the process of feature extraction. The next modification is the selection of loss function. To enhance the recognition of this model, I use cross-entropy function as my loss function, which is called KL divergency, and is the most popular loss function utilized in classification problems. This is its mathematical expression. Eventually, the simulation. This simulation showed the performance comparison of different input types. From the graph, it is clearly that the normal type of inputs outperform both the constellation and the cycloid spectral density in most of the SNR. More specifically, the success rate of the proposed methods is over 90% when SNR is increased to 2 eventually. It is proven that to improve the combination of heterogeneous data is feasible and have better performance than to adopt single data. The simulation on the left is the performance comparison of different kinds of modulation. I test each modulation's classification and comparison respectively. From the chart, we can see that no matter which source of signals, the success rate of them continuously increase and remain stable at about 97% eventually. The proposed method showing its outstanding performance in the aspect of BPSK and QPSK, with the figure of over 95% when the SNR is around 5. The simulation on the right shows the performance comparison of different classifiers. When SNR is high, the success rate of all the 4 classifiers are similar because of the low noise level. In the condition of SNR 5 and 0, the figure of the proposed methods is outstanding at 95% and 88% respectively, which prove the advantage of residual neural network. However, in the condition of low SNR, the performance of residual neural network is around 63% and KNN on the best performance. This is the whole contents of this presentation. Thank you for listening.
Good morning, ladies and gentlemen. I'm very honored to give this presentation for our paper, Optimization Research of Radio Monitor Network for the Beijing 2022 Olympic Winter Games. This presentation is organized in 4 parts. The first, introduction. Second, coverage capability assess method. The third, coverage capability evaluation. The fourth, optimization scheme. And finally, the conclusion. Okay, let's go to the first part, introduction. Olympic Winter Games are planning to use 26 venues, including 13 competition venues and 39 competition venues. These venues are distributed in 3 regions: Beijing, Yanqing, and Zhangjiakou. And shown in this figure, the venues are very dispersed, and most terrains are mountainous and complex. This situation will bring great challenges to radio security work for the game. In recent years, the radio monitor network in Beijing and Hebei province are developed rapidly. Their design concepts and construction skills are both in the leading level in our country. But in Yanqing and Zhangjiakou area, the coverage of radio monitoring stations is too small to satisfy the requirements for radio security for the games. Thus, how to optimize the radio monitor network is the most important work for the responsible departments. And this article includes 3 parts. First, the article introduced a method to do the radio monitor capacity evaluation. And second, it evaluated the coverage capability of the existing radio monitor stations for Yanqing Competition Division. Finally, it brought a scheme to optimize the monitor network in Yanqing, use multiple monitoring stations including fixed stations and portable or mobile stations to improve the monitoring capability. Okay, let's go to the second part, the coverage compatibility assess method for the radio monitor network. The coverage capability evaluation of the radio monitor network needs to define the following factors: the suitable propagation model for the radio waves, the transmitting parameters of radio stations, and the receiving parameters of the monitoring systems. Okay, this page is for the radio propagation model we used. In 2001, the International Telecommunication Union put forward the ITU-RP 1546 recommendation named the method of face-to-face prediction of ground service points and the frequency range of 30 MHz to 30 MHz to 3000 MHz. In this proposal, the prediction method for UHF and VHF band fields intensity are given on the basis of the method data and 3 transmitting frequency, 1000 MHz, 6 MHz, and 2000 MHz. This paper used this propagation model to simulate and evaluate the region coverage capacity of the radio monitor station. In our paper, we selected 6 kinds of typical radio service stations used in the Olympic Games for evaluation. The FM broadcasting stations, radio interphone relay, digital tracked base station, dedicated interphone, digital TV broadcasting stations, digital tracked base stations. Monitor receivers. Sensitivity can be calculated as following. The location and height of the receiving antennas can be gauged from the existing monitoring network, and the antenna height is assigned to be terminated according to experience. Let's say the third part, the coverage capability evaluation of the monitoring stations. The coverage capability of the monitoring stations in BTKT is evaluated in this part as an example. Like division, there are three monitoring stations: BT station, tracking station, and function station. The system parameters and the subspace mentioned are used in the assessment. The evaluation results can be seen in these figures. We can see that for FM forecasting, the monitoring can coverage 100% of the required area. And for the in area is 7.9 square kilometers, and the jurisdiction can cover one square kilometers. The coverage rate is only 7.7%. For 300 meters digital tracked station, and the coverage rate of the station is 0.0%. And for 400 meters dedicated network, the coverage rate is also low. The same situation as for the 700 meters digital TV broadcasting stations and 800 meters digital tracked stations. The coverage rate of the radio monitoring stations for these services is also 0%. And we can see from the results the radio monitor network in BT can only be used to monitor FM broadcasting stations, which are large transmit power and low frequency. And also the coverage rate is only 9%. As competitive among monitoring the other forecasts of the services is basically lack. We can draw a conclusion that the monitoring capability is far short of what is required to do the radio security work in the major BT and the Olympic Games. Okay, let's go to the fourth part, the optimization scheme. We aim to maximize the use of existing resources. This includes the scheme operating request station facilities with the complete integration of the old and new systems to protect reduce the safety for the Beijing Olympic Games. First, Heterogeneous return stations located on the top of the Heterogeneous and the Beijing Olympic Village, respectively, coverage capacity evaluation. The distribution of the two ultra-fixed radio return station is shown in this picture. The evaluation results comparison before and after the addition of the two ultra-fixed radio return stations can be seen in these following figures. Some incidents after this transitions for the radio intertron relay, the coverage rate raised from 7.46% to 100%. For the digital tracked base stations, the coverage rate rose from 0% to 100%. As for the dedicated interphone service, the coverage rate also raised from 0% to 41%. For the 700 MHz digital TV broadcasting stations, the coverage rate is from 0 to 100%. And for the 800 MHz digital track station, the coverage rate is from 0 to 100% too. The simulation results shown in this table. After the addition of the two new stations, except for the dedicated interphone, the coverage for other typical services are all raised to 100%. Compared with before, the overall coverage has been greatly improved. It can be seen that the addition of the two new ultra-fixed stations in Yanqing division can basically guarantee that the radio motor coverage of key protection area is able to reach 100% for several high-power typical service stations such as FM, digital tracked communication, and digital television, but the coverage for low-power stations is still poor. In order to increase the coverage of low-power stations and realize the multi-station joint coverage for important protection areas, it is necessary to build portable or small monitor stations near the regional MSK Center and the National Sliding Center. Considering the large area of the open field and the complex terrain of the mountains, it is planned to set up a station in the high point near the end of the jet slalom of the National MPC suited for covering the Heterogeneous mountain and both sides of the valley. The other station can be located in the regional sliding center to monitor the environment around. The distribution diagram of the two new water region monitors is shown in this picture. After ending the two water stations, the monitoring coverage of 400 acres dedicated intercom services was recalculated, and the result is compared with the coverage only any water fixed stations. And so in this picture, in this figure, you can see that the coverage for this service, the coverage rate is raised from 41% to 100%. It can be seen that through ending the two fixed radio monitor stations and two portable small stations, the radio monitor network in computation area can be basically until 100 coverage for the typical services in theory. Also for low power equipment like 400 acres dedicated interface. With this layout, the coverage compatibility can meet the security requirements for various radio stations in 2022 Beijing Olympic Winter Games. Okay, let's go to the final part of this presentation, the conclusion. In this paper, through calculating the coverage of the radio monitor network in Yangtze computation area, the layout optimization suggestions of the new ending radio monitor stations are proposed based on the coverage evaluation results, so that the monitoring coverage effect of the computation area is greatly improved, and the monitoring coverage can reach to 100%. The full monitoring coverage of typical service stations provides theoretical and detailed support for the radio management department to optimize the construction of the regional radio monitor network, and lays a certain foundation of improving the refined technical supervision ability of the radio safety guarantee of the 2022 Olympic Winter Games. Thank you for your time.
Hello, experts and professors. I'm honored to have the chance to participate in this conference. And the topic of my paper is Research of Frequency Allocation based on Improved Genetic Algorithm. Here is the overview of our work. First, we propose an improved genetic algorithm which is suitable for spectrum allocation in open space. And then the algorithm has good applicability under the situation of tight spectrum resources. The outline of my talk as follows. The part 1, I want to introduce the background and previous works of this research. The part 2, we propose system model of spectrum allocation. The part 3
describes the specific method and the principle of the allocation algorithm. Finally, in the part 4, the conclusion is given by the simulation. Well, let's focus on the first part. Wireless spectrum, the foundation of network speed and quality, is an important but non-renewable resource. Different signals working on the same frequency may produce mass mutual interference. So, it becomes very important to manage and allocate spectrum resources. The goal of our research is to get the spectrum allocation result with the least total interference among devices in the open space scenario. And if the number of devices and platforms change, the algorithm can reallocate spectrum faster based on the previous results. Meanwhile, the algorithm needs to be universal, so it can be applied to two scenarios with sufficient spectrum resources and insufficient spectrum resources. There are many traditional algorithms used in spectrum allocation, like simulate annual (SA) and colony optimization (ACO) and genetic algorithm (GA). Both SA and ACO has difficult to find global optimal solution. Due to their disadvantages, they do not apply to the global allocation in reality. But GA is a method to search for the optimal solution by simulating the natural evolution process. It takes advantage in getting global optimal solution, and has a disadvantage like slow convergence speed. Thus, many researchers try to improve GA to make it more suitable for spectrum allocation problem. Yasmina I. Morabit proposed a GA-based model for channel allocation, and Chang Shengyin combined GA with greedy algorithm. For the content of my paper innovation point, first, we proposed a new interference model, in which spatiality and energy is considered in the interference model. Compared with traditional GA, the new interference model is better simulation of real environment. Meanwhile, it can solve the problem of channel multiplexing under the situation of tight spectrum resources. Secondly, we allocate spectrum according to the numbering sequence of platforms. It fully considers about independence and particularity of each platform in this method, and be able to increase the speed of convergence by reduce the complexity of a single allocation. Let's move to the part 2. Here is a schematic diagram of the system model in this research. There are multiple platforms in an open space, and each platform has multiple devices. Comparing with the distance between platforms, the size of platform can be ignored. Thus, we assume that each platform is a single point, and all the devices are located at the point. All of them use a same frequency band. We divided the band into several channels. Take this diagram as an example. We have 3 platforms in the space and 4 devices on each platform. A total 10 channels are set to allocate. The blue square represents the channel occupied by the device. The number of devices is more than the number of channels. There will be situations where different devices use the same channel, like these two devices, which cause a lot of mutual interference. The distance between devices and the frequency determine the interference value. Depend on whether the number of devices exceeds the number of the channels. We divided the allocation scenarios into sufficient or insufficient spectrum resources. Changing the number of devices allows you to switch scenarios. The allocation algorithm needs to find an allocation scheme with the least interference in the two scenarios. Then, the part 3 shows how we improve GA to meet the requirements and solve the shortcomings. Here is a basic flowchart of GA. We mainly improve fitness calculation and evolution performance by using new interference models. Traditional interference models only use 0 or 1 to distinguish whether there is mutual co-channel interference, and generate interference matrix. This kind of method does not take the problem of channel multiplexing in spectrum-tight scenarios into account, and cannot obtain the best channel multiplexing scheme. So we use the total power of the interference signal of each channel as a criterion for evaluating the interference. Take the interference of one channel as an example. First, signals interfere with each other because of their power, and the pace loss function is used to calculate the interference between devices. Formula 1 is the open space pace loss function, wherein L represents the signal pace loss, D represents the distance of signal traveling in space, which can be simplified to distance between two platforms in our scenarios. M represents the signal operating frequency. Second, a channel may be occupied by more than two devices. We use the formula 2 to sum interference power, wherein N represents the number of interfering devices, I represents the total interference in the channel, IK represents interference from each device. The interference value of channel is calculated by this method, and the interference matrix is formed as shown in Formula 3. Scenarios for spectrum allocation on open space platforms are more complicated than the ordinary allocation. All devices are naturally classified by each platform, so we carried out sequential spectrum allocation in order to reflect the difference of each platform. The more devices, the longer length of chromosomes. Sequence allocation can greatly reduce chromosome length by allocating only part of the device at a time. Then we set Tm, reduce generations. If fitness value has not changed for Tm generations, there is GA process. This GA process ends, and the next GA process on other platforms starts. Meanwhile, sequential spectrum allocation can read the previous allocation results to calculate the interference, which will greatly increase the convergence speed. Improved genetic algorithm is a kind of optimization problem. Algorithm convergence criterion is shown in formula. The allocation scheme is to find the optimal solution under the current conditions. We use the sum of the interference from each channel as the fitness function in the genetic algorithm, and define a standard named max reward to evaluate it. Convergence speed is the number of generations required. We think that the less generations the algorithm needs, the faster the convergence speed. Finally, comparing IGA with the original GA. Simulation shows the improvement of convergence speed and max reward. There are some global parameters shown in the table. There are array radius, number of channels, number of devices per platform, and generations. First, we simulate initial allocation with 4 platforms in scenario 1. It shows that both algorithms find the global optimal solution, but the convergence speed of IGA is much faster. Therefore, the IGA can significantly reduce the number of iterations in the situation where the spectrum resource is sufficient. Then, we add a new platform and reallocate the spectrum. As the result illustrates, the new method figures out the global optimal solution, but the ordinary GA fails. Besides, the convergence speed of IGA is faster than the ordinary GA. Finally, we simulate initial allocation with 6 platforms in scenario 2, where the spectrum resource is insufficient. In this complex scenario, 2 methods have close convergence speed, but the results obtained by IGA are much better than GA, which shows IGA provides an ability on reducing interference when multiplexed channels. Then, we add a new platform and reallocate the spectrum. As a result illustrates, both ordinary GA and the improved GA scheme suffer from a huge interference. However, the IGA has better max reward and convergence speed. As a result, the ordinary GA does not take space factor into account, but IGA does. Therefore, especially in the complex scenario, where the spectrum resources are insufficient, IGA can effectively reduce interference between co-channel signals and increase the speed of reallocation. That's all. Thanks for your listening.
Hello, ladies and gentlemen. My name is Zhang. I'm from Jin University, and I'm the speaker of this speech. The topic of my speech is spectrum-efficient D2D-based puncturing algorithm for eMBB and URLLC coexisting networks. Today, I will start my discussion from the following four aspects. The first part is the research background. eMBB is the enhanced mobile broadband which proposed to support 0.1 to 1 Gbps per second user experience rates. URLLC is ultra-reliable low-latency communication, which requires the end-to-end delay below 1 millisecond, with the probability at least 99.999%. Device-to-device technique is a variable way to reduce the end-to-end delay of URLLC. These three techniques can be used in following four application scenarios, like V2V, VR, industrial control, and telemedicine. The second part is research accuracy. In 2017, 3GPP proposed a two-time scale scheduling slot structure. They regulate the TTI of eMBB equal to 1 millisecond, but the TTI of URLLC is less than 1 millisecond. In 2018, in the two-time scale scheduling slot structure, the puncturing type multiplexing schemes were proposed. In the same year, a single URLLC user puncturing algorithm was developed. Some researchers focus on mitigating the rate loss of the punched eMBB traffic. In the next year, a multi-user punched scheduler was developed for achieving a balance between the spatial efficiency of eMBB and average latency of URLLC. But in the existing works, only the spatial diversity gain of D2D was exploited to boost reliability of URLLC. Resource allocation schemes has been started to maximize spatial multiplexing. The third part is research content and significance. The system model is described as follows. M circular links carrying eMBB traffic and N D2D links carrying URLLC traffic are considered to coexist in a single-shell wireless network. The frequency diversion duplex is utilized. The D2D links reuse the uplink resources of circular users. The base station is assumed to know the channel statement information of circular users and the D2D links. And then we'll analyze on the achievable transmission rates of the eMBB and the URLLC traffic. We use some ρij less or equal to 1, ρij belongs to 0 or 1, represent each D2D link share at most one circular user's resource block, and we use some ρij equal or less than to lambda, represent circular users' resource blocks are allowed to multiplex by different D2D links. The average power of interference caused by multiple D2D links is considered in deriving the transmission rate of circular communication. The average interference is given as this formula. In the formula, lambda multiple omega less than 14 holds for the normal static prefix condition that one TTI of eMBB traffic contains 14 OFDM symbols. According to the average power of time-varying interference, the SNR of secular user I is given as this formula, and according to the channel formula, the achievable transmission rate of secular users I can be calculated as this. Because the data packets with finite block length channel codes are transmitted in URLLC, the block error rate of short packet transmission is inevitable. Hence, Shannon's formula is not suitable to characterize the achievable transmission rate of D2D link with carrying URLLC traffic. So, the D2D link transmission rate is given by a short packet formula. And then is the statistical delay QoS analysis of URLLC. On the basis of large derivation principle, the relationship holds as follows. Cj is QoS exponent of URLLC traffic carried by D2D link J. The larger the Cj is, the more stringent of the QoS requirement is. The statistical delay QoS requirement of URLLC traffic carried by D2D link J is defined as dgmax and epsilon J. The approximated function of delay violation probability is given as this formula. Effective bandwidth of URLLC traffic carried by the D2D link J when the average arrival rate is alpha J. The effective bandwidth for a Partition process is this formula. For URLLC, the delay band is much smaller than the coherence time of various channels in typical scenarios, except high mobility scenarios where the velocity is larger than 100 km per hour. Hence, the channel is referred to as quasi-static fading channel. The random fading coefficients of which keep constant in the duration of transmission one data packet of URLLC traffic. Then the effective capacity of D2D link J carrying URLLC traffic is derived as this formula. For statistical independent arrival and service process, if and only if effective capacity is greater than effective bandwidth, the statistical delay QoS requirement characterized by Cj can be guaranteed. We formulate spectrum-efficient D2D-based puncturing algorithm as a system throughput maximization problem with multiple constraints, including the statistical delay QoS constraints of URLLC, which is formulated as follows. Because the optimization problem is a mixed 0 to 1 nonlinear programming, we employ the PSO algorithm with penalty function to cope with the optimization. From the first picture, the Fig 1 shows the system throughput of our D2D-based puncturing algorithm versus the allowance max maximum transmission power of secular users. It shows that the system throughput is unaffected by the maximum transmission power in the case of more D2D links existing. When the D2D link is 5, the system throughput increases slightly along with the maximum transmission power of secular users. On the one hand, a larger transmission power of secular users with eMBB traffic can evaluate the transmission rate of the secular user. On the other hand, a larger transmission power also causes more interference to D2D links with URLLC traffic. When the number of D2D links is small, the larger transmission power is taken by our algorithm for the secular user to improve their transmission rates. When there are more D2D links, a moderate transmission power is obtained by our algorithm for reducing interference and satisfying the statistical delay QoS of URLLC. From the second picture shows the system throughput of our D2D-based puncturing algorithm in the scenarios with a different maximum communication distance of D2D links. We can find that increasing the maximum distance of D2D link makes the system throughput decrease. The decreasing rate of throughput curve for the case of 5 D2D links is obviously lower than the others. In the case of existing 5 D2D links, the transmission causes less interference than the other cases. Hence, for the case the D2D link is equal to 5, increasing maximum distance for the D2D link does not result in a dramatic reducing in the system throughput. From the last picture, we can see that the average packet rate is increasing, but it shows that the packet arrival rate has little effect on the system throughput when the arrival rate is smaller than the 0.1. It is indicated that our puncturing algorithm is robust to variation of the average arrival rates. The fourth part is summary of research work. Our main contributors can summarize following three points. The first one is, in the D2D-based multiplexing scenario, we calculate the average power of time-varying interference caused by multiple D2D transmissions and derive the achievable transmission rate of the secular link. Then we derive the achievable transmission rate of D2D link considering short packet transmission feature of URLLC. And the second one is we derive the effective capability of D2D link with URLLC traffic. Based on the effective capacity theory, we quantify the constraints on the transmission rate of D2D link, considering the statistical delay QoS requirement of the random and sporadic URLLC traffic. The D2D-based puncturing algorithm is formulated as a throughput maximization problem subject to the rate requirement of eMBB traffic and the statistical delay QoS requirement of URLLC traffic. The problem is solved by the practical swarm optimization algorithm. This is all my speech. Thank you for your attention.
Today, I will share this paper, Discriminative Graph Learning with Low-Rank Constraint for Semi-Supervised Learning. First of all, we mainly share this paper from 4 parts, which are brief introduction to the background, the progress or method proposed, experiment, and conclusion. The brief introduction to the background is graph learning is more and more widely used in discovering associations and meaning relationships between data and data. Our paper proposed a discriminative graph learning for semi-supervised learning method. Discriminative graph learning with low-rank constraints. Traditional semi-supervised learning method exists the problem of similarity between similar species is not high. How to improve the similarity between similar species has become a problem we need to solve in this field. With the increasing application of face recognition and image classification technology in our daily lives, how to extract a feature more conducive to classification from high-dimensional and complex data has become more the focus of today's research. Recently, because supervised learning and unsupervised learning have many problems in real life and cannot practical applications, researchers have combined supervised learning with unsupervised learning and proposed semi-supervised learning. Semi-supervised learning is to learn the features of non-label images to extract the features that have a higher proportion of image classification and classify the image data of unknown labels according to the learning results. And then is the progress of method proposed. The process of proposing the method is mainly divided to 3 parts: semi-supervised learning, discriminative graph learning, low-rank constraint. First of all, we will introduce the logic of semi-supervised learning. Semi-supervised learning need to manually label the data and then use these labeled data to train the model, and then use the trained model to classify the unlabeled data. And that is semi-supervised learning. And then is discriminative graph learning. In order to feature enhance the accuracy of semi-supervised learning, so that the method can maintain higher performance even under noise condition, we propose a discriminative graph learning error constraint term The term is obtained by training simple data and finding the matrix D according to the training results. The matrix D is composed of 0 and 1, when only one value in a column is 1 and the other values are 0. The image belongs to this kind. For instance, suppose Z exists where Z1 belongs to class 1, Z2 and Z3 belongs to class 2, Z4 belongs to class 3, then D should be defined as the picture as this. To reduce the error when classifying unknown label data, we construct the discriminative graph learning error as this. Among them, the matrix W is a coefficient, and this one F is a Fabulous subspecification, which is commonly used to process data containing Gaussian noise. This one can be rewritten to this one. Let's our paper propose the discriminative graph learning error. The low-rank module can represent the simple data with a low-dimensional structure. This representation can play a role in limiting the noise of the simple data to a certain extent, compared with the method of directly processing the dry data by using the low-rank module to eliminate the noise of the simple data. The model is the low-rank representation model. By applying a low-rank constraint to coefficient representation matrix, it is easier to find the local similarity of the training sample itself, and it is beneficial to eliminate noise interference in the simple data. And this one is the model our paper proposed. The performance of this model is more prominent and increase the robustness of semi-supervised learning. And then we will introduce the experiment of this paper. In this paper, we do the experiment In the experiment, we compare the method proposed in this paper with several existing semi-supervised learning methods, such as semi-supervised discriminative analysis, and so on. And next, I will introduce the experimental dataset. First, we will introduce the extend will-be database. The extend will-be database contains 2,414 frontal-face images of 38 people. There are about 64 images for each person. The original images were cropped to 192 and 168 pixels. This database is challenging due to varying illumination conditions and expressions. And then we will introduce the AR face database. The AR face database consists of over 400 color images of 126 people. Each person has 26 face images taken during 2 sessions. And then we will do the experiment. And then we will introduce the experiment results. We compared our method with several means in extend will-be, and the result is like the pictures show. And then we compared our method with several other methods in AR phase. And the result is like the picture show. From the above experimental results, we can see that our proposed method has higher accuracy than other semi-supervised learning methods. And then is the conclusion of our paper. This paper proposes the discriminative graph learning with low-rank constraint for semi-supervised learning to classify data of unknown labels. This method designs 2 constraint terms based on low-rank representation, discriminative graph learning error, and iterative solution method. Almost efficiently solves the coherence problem of the objective function and compares it with the existing semi-supervised learning method on 2 different datasets. Through experiment, we learned that the method proposed in this paper is better than some current semi-supervised learning method. That's all I want to share. Thanks for your attention.
Hello everyone, I will introduce this paper to you. The title of the paper is Interaction Representation-Based Subspace Learning for Domain Adaptation. I will introduce it from the following steps. First, I will introduce the background. We know convolutional machine learning algorithms are based on the assumption that the training and the test data lie in the same feature space with the same distribution. However, this assumption may not hold in many real-world scenarios, especially in the field of computer vision owing to various factors such as different camera device illumination background. We can look at this picture. This picture shows some images of different distribution when the disparity exists between the training and the test data. The classification accuracy dropped dramatically. However, retraining a new classifier often requires a large amount of neighbored training data and of the same distribution, which consumes a lot of human resource and is not realistic with the explosive growth of unlabeled data. Domain adaptation methods have been used to solve this problem. We can look at this picture. What is domain adaptation? When the condition of same source and target marginal discrimination on X is false, and the same task on source and the target domain is true. That is domain adaptation. It's aim to transfer well-learned knowledge from the source domain and to the target domain. Conventional domain adaptation method can be divided into classifier-based method and representation-based methods. The classifier-based methods tend to solve the domain disparity problem by adapting the existing classifier to the data with different distribution, such as with SVM. However, they may not utilize the intrinsic information of the data, and it strongly depends on the specific classifier. Further, the representation-based method tends to learn a better representation for classification, such as TSL. However, most of them only consider the domain adaptation at the data level, which ignores the global information of domain. Domain adaptation can be used to solve the question of data coming from two different domains but related to each other. The method of domain adaptation is to explore the invariant structure in the two domains, through which a subspace can be formed to connect the source and the target domain. In this paper, we think that the domain adaptive method only considers the unidirectional alignment of datasets and ignores the possibility of bidirectional alignment. Therefore, we advance a subspace learning method based on interactive representation. Next, I will introduce the related work. First, I will introduce the subspace learning. The main principle of subspace learning is to map high-dimensional data in low-dimensional space. This formulation represents the process of mapping. It is not enough to get robust representation for classification by only exploiting the data level information of two domains. Subspace level approach can analyze the statistical feature of two domains. It is expected to find a subspace in which all required data are kept. Subspace level method can analyze the feature of both domains. So I will give some example of for subspace learning. For example, PCA will project data along the direction of the maximal variance. PCA pursues to maximize the internal information of data after dimensionality reduction. It does not consider classification information. LDA seeks the most effective recognition direction by minimizing the relative between in-class and inter-class sketches. What LDA pursues is that data points after dimension reduction can be distinguished as easily as possible. That is, the data has better spatiality in the no-dimensional space, so that the data sample after dimensionality reduction have not only the largest distance between class, but also the smallest inter-class values in this new dimensional space. Next, I will introduce the no rank. First, X is a matrix including samples for K subspace, which can be composed of a linear combination of alternate dictionary and sparse noisy mixtures. Especially, we use X itself as dictionary. The no rank can be modeled by this formulation, where there is a no rank representation mixtures, this denotes the nuclear normal of mixtures, which can be seen as a good surrogate for rank minimization and used to constrain the rank of Z. The noise data E is a special generation, which can be handled by LE normal constraints. Lambda is the balanced parameter between linear representation and noise. I will give an example. When data is affected by noise, the robust principal component analysis most are proposed. RPCA is a typical no-order method of study. The principle of RPCA is to recover from no-rank mixture to the observation mixture. It can correspond to a rank minimum optimization program. In the shadow remove and the background, the modding has a good effect in actual application. Recently, a few studies have proposed the introduction of no-rank constraints in transfer learning. The learning most of no-reader transfer space is to constrain the shared subspace of two domains, while the adaptive most of no-rank domains is to use no-rank representation to reduce the difference in domain distribution. Our most is different from the most above, which only adopt one-way domain analysis in subspace learning, while our proposed IRSL most is the interactive representation of two domains. Not only the training set alignment test set, but also the test set alignment training set. Next, I will introduce our method. First of all, we can learn PT from the invariable information in the data. Then, we expect to find an invariant subspace. In this subspace, the target domain and the source domain are infinitely close. Thus, for the target domain and the source domain can be expressed linearly with each other. In this way, two domains achieve the interactive effect, and the two domains achieve a better effect in alignment with each other. Mathematically, a low-order model can be formed. That is, a low-rank constraint is used to realize the reconstruction mixtures, and its expression is as this formulation. Then, we hope to settle the question of domain inconsistency by aligning the two domains. Therefore, we set the distance constraint on the subspace of the two domains so that the two fields are close. This distance constraint can be achieved by minimizing LR normal, like this formulation. This formulation can return the useful information of two datasets to a great extent. Meanwhile, adjust the subspace of two domains. Therefore, a bad PT can be obtained. For the final classification model, it is not enough to use only subspace to distinguish, and the extensive neighbor information in the source domain is ignored. Therefore, we suggest a neighbor in the two domains into the classification mode to obtain additional discrimination information and improve the resolution of the model. In order to make the best of known neighbor information in the source domain, we define the constructed neighbor mixture Y as this formulation. The purpose of introducing neighbors into the model is to find a discriminative PT, which is similar to a subspace between domains. The formulation can be expressed as this, and we can get the final formulation by above formulation. And we can solve this formulation by the method of inexact augmented Lagrange multinomial method, in which two n oppositional variable LE and LR are involved. Now, here is the solution formulation for each variables, like this picture shows. And next, I will introduce the experiment. We use two datasets in this experiment, CDA dataset and the CMU dataset. This is the experiment result. It can be seen that the accuracy of our method is higher than that of other methods, which proves the effectiveness of our method. Finally, I will give some conclusion. So first, I will give three paper innovations. First, inspired by the alignment of two domains, we propose an interactive representation mode based on two low ranks. In this model, we make the two domains align with each other. In addition to make the target domain use the linear representation of the source domain, we can also make the source domain use the linear representation of the target domain. Second, distant constraint is added to the model, which makes the two domains approach each other infinitely and further achieve the effect of mutual repetition. In order to obtain extra discrimination information, we explore a grid of neighbor information in source domain to strengthen the robustness of the model. In this paper, we propose a subspace learning based on interactive repetition framework to solve the question of domain inconsistency. In this framework, we align the two fields and make the two fields as close as possible. In order to achieve this better, we further constrain the distance of the model to make the two domains closer. Finally, in the source domain, we take full advantage of the known neighbor information to obtain additional classification information, so as to increase the robustness of the model. A grid of experiments show that our way is superior to the existing method. There is all my report. Thanks.
Hi everyone, I'm Yuding from Harbin University of Science and Technology. Today I'm going to introduce our work on joint cross-view heterogeneous discriminative subspace learning with low-rank representation. This is a joint work with Oli. In the real world, an object can be described under various conditions, including different angles and illumination. So, cross-view dates are frequently seen, and erect gradually considerable attentions. Feature space learning is one of our baseline. It is an interesting method all the time. The aim of subspace learning is to find a feature space which can use low-dimensional data to represent high-dimensional data effectively. In addition, the learned subspace can make within-class data more similar, and between-class data far away. However, for cross-view data, the data from same view but different classes are much more similar than within same class but across different views. Because there is a large divergence between views, well, how to decompose the class structure and the view structure of cross-view data, and how to use information between different views. The other baseline is low-rank representation. Low-rank representation can build a linear subspace to uncover the latent structures hidden in data. In addition, we replace solution of rank with nuclear norm, which is easier to solve. We use the original data as its own dictionary. E denotes arrow matrix, so the learned subspace become clean. Low-rank representation can not only learn the original subspace of the date in noise environments, but also have ability to uncover the latent manifold structure of date. This is believed to be feasible for rephrasing cross-view date. For cross-view date, the samples from different views, but within same class, have large divergence due to those two interlaced structures. On the contrary, the samples from same view but different classes are more similar due to the latent connected from view structure. So we adopt a draw low rank representation to uncover class structure and view structure. But class structure and view structure are equal in this function. So we design a supervised discriminate variance constraint term to separate class structure and view structure. We first set two distance of date between classes and views. This can choose the class and this can choose class over view of samples. Then we make the distance between classes larger and the distance between views smaller, based on Fisher criterion. L is Laplacian operator. We can get the learned specific subspace by mixture P. Finally, we can combine the discriminate constraint term with the draw low-rank representation to get the draw structure decomposition framework. In addition, we add the orthogonal constraint to eliminate the trivial solution and reduce the redundancy. In this work, two interleaved structures hidden in cross-view can be unlocked. By discriminating term, we can separate two structures, which are class structure and view structure, and get a common space in which the within class state, regardless of their views, are closer, while between class states in the same view are far away from each other. It is noted that, different from single view, the between view shared and view specific information are both existed within semantic space for cross-view dates. So we hope to use a special regression scheme which explores the shared and view specific structures at the same time to give better feedback guidance to cross-view feature learning. We use several weight matrices to capture isomorphic and heterogeneous information with semantic space like W0, W1, W2. This is a joint learning term to get feature subspace learning beside on rich regression, because rich regression can prevent the overfitting and enhance the generalization. W0 at work at two wheels in the meantime to learn isomorphic information. W1 and W2 work at their own wheel to get their own heterogeneous information. Therefore, the learned feature subspace contains isomorphic and heterogeneous information from different views. This is our proposed mode. We use a draw low rank representation to describe the manifold structure of cross-wheel dates in a high-dimensional subspace. By discriminating with various constraints, complex date is projected into a low-dimensional subspace structure that is easier to identify, and its class structure and wheel structure are decomposed into each other. We also design a joint wheel heterogeneous feature subspace constraint that can extract hidden wheel heterogeneous information from different wheel dates. The above minimization is an non-convex problem with master variable, which is difficult to solve directly. So we develop an alternating numerical scheme to solve each variable iteratively. This table is our algorithm, in which we set some parameters empirically and test others through experiments. We evaluate the performance of our method on 3 standard datasets and compared to several feature learning methods. This table is classification results on CMU-PIE face database. The right highline is our results. This figure is classification results on COIL 100 object database. The great highlight is our proposed method results. This figure is classification results on extended UB face database. From these experiments, our proposed method is more effective than that of other comparison ones for classification texts. Moreover, performance based on low-rank method is generally better than others due to capture latent subspace structures. To solve the cross-wheel dates recombination and classification problems, this paper provides a joint cross-wheel discriminative subspace learning method based on low-rank representation for feature learning of cross-view data. The proposed framework learned the projection subspace by seeking two manifold phases with draw low-rank representation, which can be used to unlock the class and view structures. To further ally the cross-view data, a discriminative joint heterogeneous constraint is designed in semantic space. Our method puts the representation and semantic arrangement into unified framework. Meantime, the numerical scheme is developed to guarantee the convergence, and we test our method on 3 kinds of public datasets and find it outperforms other conventional comparison methods and achieves competitive performance. And thank you for your attention.
I am so honored to be here to communicate academic questions and ideas. First of all, I want to introduce myself. My name is N-ary. I come from Harbin University of Science and Technology. The topic of my academic presentation is rank-simple, reconstruction-based, semi-supervised feature subspace learning. My presentation is divided into 4 parts. First, some background information about this paper. Second, the main work we have done. Third, the experimental results we have got. And the last is the conclusions. Subspace learning is the most effective way of data dimensionality reduction. The central idea is to learn a projection space, projecting data into a lower dimensional space and store useful information from the data. In the study of data dimensionality reduction, feature subspace learning is a common method. During processing, useful information will be preserved as much as possible in the feature subspace through maximizing inter-class distance and minimizing intra-class distance. As can be seen from the practical manual of the feature subspace learning models, there's a significant pre-treatment during most complex visual data processing. Many researchers have been focused on subspace learning. However, majority of them are supervised. It remains challenging when the data contains only partial labeled symbols. Therefore, the research on feature subspace learning method based on semi-supervised learning is of academic significance and practical value. In early research, feature subspace learning can be divided into the following 2 classes: supervised and unsupervised. The general idea of supervised feature learning is based on existing training sample to train to get an optimal model. Each input of the model will have a corresponding output and make a discriminate and analysis on the output to achieve classification. The purpose is to have the ability to classify unknown data. In contrast, unsupervised feature learning is a model for identifying unlabeled data structure. Among other unsupervised models, principal component analysis is a representative method. Linear discriminate analysis is a classical supervised feature subspace learning model, and locality-sensitive discriminate analysis is an extension of LDA. This method lays a solid foundation for subspace learning. Many semi-supervised models have been proposed for feature learning recently, such as a semi-supervised discriminate analysis, flexible manifold embedding, and rescaled linear square regression. While the research on feature subspace continues to deepen, the representation model also has been widely used in various research fields. Commonly used representation models are sparse representation and low-rank representation. They are the promising research direction in machine learning. By combining these representation models, the study of feature subspace learning method has developed rapidly. To identify the noisy information in the original sample and obtain the robust subspace, we implement low-rank constraint on representation coefficient. Meanwhile, the low-rank constraint is used to predict the labels of unlabeled samples. The low-rank constraint can efficiently eliminate the noise component in the sample. Moreover, the reconstruction of sample can further explore the nearest neighbor relationship. It makes different classes of samples far away from each other and improve discriminability of the model. So, the objective function with low-rank representation constraint can be obtained as following formula. In this objective function, Z is representation coefficient matrix, P is feature subspace, lambda 1 and lambda 2 denotes two regularization parameters, D is the constant coefficient matrix. Graph learning is frequently used in semi-supervised model for predicting label information of unlabeled samples. By integrating graph learning and low-rank reconstruct subspace learning into the same learning framework, the first two items learn the complete label information through label propagation. Z is used as similarity weights to construct the relationship between two labels. We also introduce a non-negative construct on Z as the non-negative regularization parameter. The similar between the two samples is constrained by low-rank representation coefficient. So, the final objective function we can obtain as shown in the following formula. In the final objective function, B denotes the matrix with all the label vector of unlabeled samples and labeled samples. F represents the learned label matrix through the similarity mirror with B. We have described the graph-based semi-supervised approach and low-rank reconstructed subspace learning jointly. Next, we will introduce the optimal scheme. Since the minimization for all variety is not a convex problem, we design a solution based on alternating iteration. Aimed at relaxing the issue of minimization, we introduce two variables R and J. Therefore, final objective function can be rewritten as shown in the following formula. Next, the Lagrangian function can be obtained as the following form, and the minimized problem of objective function can be rewritten as shown. To solve the minimized problem, we alternatively update the variables by solving each variable and fixing others, as shown in algorithm 1. In this manner, in the kth iteration, we have the objective function about f, p, j, r, and z, and finally solving them in sequence. In the experiment, we choose 3 datasets to verify our method, respectively named Extended EOB, Coil20, and USPS. Extended EOB was photographed under a variety of controlled lighting conditions, including totally over 2,000 frontal faces images. Coil20 contains 20 objects. Each of them is rotated 300 degrees to take an image every 5 degrees and 72 images of each object. And USPS is a database for digital handwriting recognition. There are 9,298 images from 0 to 9 in the dataset. According to the experimental criteria of the semi-supervised model, half of the whole sample were labeled and the rest of sample were not labeled. To verify performance of our model in the experiment, we compared two classic feature subspace learning methods and several novel semi-supervised feature learning models with sparse representation classifier and k-nearest neighbors. All experiments were performed 5 times to calculate standard deviation and the mean as shown in Table 1 and Table 2. In two tables, unlabeled and test represent the test sequence of the data with no labeled part of the training set and the test set. Compared with this method, our method shows better performance on all data sets. Next, in the following, we choose Coil20 to discuss the influence of the change of this parameter value on the model performance, and draw the recognition rate curve with the change of the parameters, as shown in the figure. It can be seen from the figure, the recognition rate doesn't fluctuate greatly with the change of parameter values, and the performance of the model is very stable. The last, to prove the convergence of the model, we choose the extended EMBB dataset to draw the convergence curve with the increase of iteration times. As shown in the figure, the convergence curve in our model can rapidly converge, and the convergence curve will be stable within 50 iterations. Finally, I summarized our work in short. We proposed a semi-supervised subspace learning model based on low-rank simple reconstruction to obtain complete label information in incomplete labels and improve the robustness of the model. We jointly learned low-rank simple reconstruction and graph-based semi-supervised learning to calculate the objective function and ensure its convergence. We designed an optimization solution. These variables can facilitate each other to achieve the optimization of our model during the iterative processing. Then, an effective iterative solution scheme is developed to ensure convergence. We test our method on several available vision datasets with several feature learning methods. From the comparison experiment, the experimental results indicate that our approach is the most competitive. And last, in the future, a better discriminate constraint will be designed to enhance the accuracy of label prediction. Thanks.
Hello everyone, it is Zhang here. Today I'm going to talk about. First, let me introduce myself. My name is Zhang, a junior student from Harbin University of Science and Technology. In the real sense, I was introduced to machine learning 2 years ago, and I was in the grip of a fascination, and then I have a clear goal. Perhaps it is my life to struggle to pursue. A year ago, by chance, I got to know my tutor, Li, and under his careful guidance, I completed this research and this paper. Next, I will introduce my research and its background from many aspects. Semi-supervised learning aims to training model with both of labeled and unlabeled data by exploring the relationship among them. Graph-based semi-supervised learning is a classical representative method that learning the class indicator matrix by propagating the similarity within the well-designed graph contrasted by data. However, for face data, they often happen to pixel missing or occlusion, which will degrade the graph learning performance, leading to semi-supervised classification results. To address this problem, a novel semi-supervised corrupted face classification method via graph learning is proposed, in which the dynamic graph is learned by the completion phase data recovered from the low-rank subspace. In our proposed method, the robust data representation and graph learning are implemented alternatively to obtain the overall optimal solutions. Experimental results demonstrate that our proposed method outperforms comparison method on both of classification accuracy and robustness. In the face of massive high-dimensional data, how to conduct effective data analysis and processing has become a major problem in machine learning and other fields. In recent years, studying map automatically is hard, which is one of the important methods for adaptive neighbor method. We construct a matrix by setting each data point as the probability that the current data can be used as the neighborhood of another data. And this probability is used as the similarity between the two data points, which does not require similarity measures sensitive to noise and outliers. So the result obtained is of high precision. However, in the process of graph learning, there is noise or interference in the original data, so the graph obtained may be inaccurate or suboptimal, and cannot accurately describe the true relationship between the data. In order to solve this problem, Zhang proposed a new robust graph learning scheme based on the adaptive neighbor method, which decomposes the original data into low-rank matrix D, which means clean data, and a sphere matrix E, which means noise and error. They can then use the adaptive neighbor method to build graph on clean data D, so they can remove the image disturbances and learn to map that at the same time. However, when there is occlusion or partial absence of data, the results of this method are not reliable, or even the learning result is not available. The Laplace score method proposed introduced the analysis of local structure of the data based on the maxVAR. But these two methods only consider the characteristic of data itself, ignore the correlation between the characteristics, and cannot guarantee the optimal feature subsets. Inspired by the self-similarity of images, Zhu believes that images should not only have self-similarity in structure, but also have the ability to express themselves in terms of feature expression. They propose an unsupervised feature selection method based on the regularized self-representation by constructing the regularization self-representation (RSR) model. This method constructs a self-representation model by assuming that each features in the high-dimensional data can be expressed as a linear combination of other features, and removes insignificant features by adding. by adding one norm constraint to features weight matrix W. We borrowed the method of regularized self-representation to solve the problem of large-scale image interference or missing. And next, let's introduce the model. Given a sample set X, where Xi represents the ith sample, as locality preserving projection LLP does, we can assign a probability Sij for Xj as the neighborhood of Si. Thus, the Sij characterizes the similarity between Xi and Xj in some sense. To achieve graph S, we can solve the following problem as model 1. And where lambda is a trade-off parameter, by defining the graph Laplacian matrix L is equal to D minus S plus St divided by 2, where D is a diagonal matrix with dii, and the model 1 becomes to model 2. Then, by optimizing the above problem, one can learn S adaptively from the data. However, its method degrades performance where it comes to input data with noise. To solve this problem, Zhang presents a principle of robustify graph learning. They assume the data to be decomposed into two parts. The model 1, the clean data D, and the model 2, the correspond and the corruptions E. And they proposed robust graph construction RGC model can be formulated as model 3. And in this paper, propose a new robust learning graph scheme. We use the self-representation probability of property of data. That is, every data point in the space can be effectively reconstructed through linear combination of their points in the data set to construct the similarity matrix. Specifically expressed as X equal to XZ, where Z is a similarity matrix and each Zi is a linear representation of the original data point Xi. We propose a new robust learning graph scheme, and we introduce theta 4, and then the model 3 becomes the model 4. We then use the adaptive neighbor method to build a graph on clean XZ. We used a joint learning method to optimize both S and XZ, which enabled us to construct the clustering graph while recovering low-rank clean data. Compare with the existing work in the literature, the main contribution of this paper are as follows. Through the establishment of self-representation model, the vacancy of graph learning method in solving data interference or lack is filled, making the adaptive map learning method more robust. Second, through joint solution, denoising and graph learning can be carried out simultaneously. Third, a large number of experiments have been performed on face clustering, document clustering, face or target recognition, and face image shadow removal, etc., which varies the effectiveness of the method. To draw a conclusion, this paper presents a model for learning robust graph from data to serve the semi-supervised classification. It solves the problem of robustness of adaptive neighbor graph learning. We improve the conventional method by introducing the self-representation model and the idea of joint solution. Therefore, our proposed framework can not only enhance performance of semi-supervised classification, but also improve low-rank recovery from damaged data. Experiments on several public face benchmark datasets shows that the robustness of our method is superior to various advanced existing graphing learning techniques. So, that's all for my speech. Thank you very much for listening. Goodbye.
Hello everyone, thanks for listening. I'm glad to have an opportunity to share our research outcome here. My name is Jiaming Li. I come from Kansas State University. The title of our research is a machine learning method for optimizing partition of prediction block encoding unit. Here is our agenda. First, I will bring some basic background knowledge about our research topic. Then, I will introduce some former researches that inspired us. Next, I will illustrate our model, experiment, and result. Our research is aimed to reduce the encoding time consumption of high-efficiency video coding, HEVC for short, or H.265. H.265 is a video compression standard which promises a 50% storage reduction while maintaining a high image quality level. Until now, it's still a widely accepted hybrid coding framework. But there is no free lunch. Splitting coding tree unit, or CTU, into coding unit, or CU, is a very time-consuming procedure in encoding process, because the algorithm has to traverse the entire quad tree, like the figure 2 shows. That's right, with maximum depth of 4. Besides, it needs to compute the rate distortion cost for each possible pattern. High cost in video coding makes H.265 impossible for real-time streaming service use. Thankfully, previous researches has observed that CU depth is strongly correlated with its texture complexity. Researchers propose a lot of novel techniques to reduce the time consumption on CTU partitioning. For example, Monfclevig et al. Proposed an approach decouples the requirements of any pre-train and yields a high adaptivity to the dynamic change in video contents. Dom et al. Proposed a machine learning-based method to reduce the complexity of screen content coding encoder, using features that describe CU statistics and sub-CU homogeneity. Allen and colleagues utilized the contrast gain control model to improve the compression efficiency for spinal Luma channels with maximum cost. Liu et al. Proposed a CN-based algorithm for fast CPU model decision to reduce the complexity of intra-coding. They were able to achieve this by analyzing the texture of CU using CN model and, as a result, reducing number of CU models in each CTU for full rate distortion optimization processing. The models and approach presented by former researchers are brilliant. They give us a lot of inspiration, especially the CN model. But training a CN model from zero is very expensive. The model needs large quantities of data and computing power to learn the features. Actually, we don't need to train a model from the beginning, because we can adopt the methodology of transfer learning to build our network based on the existing pre-trained models. There are a lot of pre-trained models already has the ability to extract deep and abstract features, just like the figure at right shoes, which is the feature filter done by AlexNet. Therefore, we can use the convolutional layers of pre-trained models as feature extractor to extract texture features from CTU, and add our dense layers as classifier to decide partition pattern. The proposed model uses convolutional layers of the VGG16 and 19 as convolutional base, and two fully connected layers as final classifier. We customize the input shape as 32 by 32 by 3, same as the dimension of one single CTU block. VGG16 model mainly has 5 convolutional blocks separated by max pooling 2D layers. VGG19 has similar structure, but 3 more convolutional layers in convolutional block 3 to 5. As input CTU, it passes through convolutional layers. 3 by 3 kernel extracts the features and expands the feature maps channel. Using small size kernel is main innovation of VGG model. On one hand, small kernel helps reduce the number of trainable parameters. 3 by 3 kernel only requires half of trainable parameters compared with 7x7 kernels. On another hand, several smaller-sized kernels could generate more detailed features than one single large kernel. The thread of convolutional kernel is 1, and the padding is added to keep the output size the same as the input size. Max pooling layers are added between the convolutional layers to downsample the dimensional narrative of inputs. Max pooling layers can improve the model generalization performance by forming the abstracted representation of features. Besides, it also reduces the computational cost as input size becomes smaller. The thread of max pooling kernel and the size are 2 by 2, so the input width and height will be reduced by half after going through the max pooling layer. In the end of convolutional base, 32 by 32 by 3 input is compressed to a 1 by 512 vector. Flattened layer reshapes this high-dimension vector to a flattened vector and pass it to fully connected layers. The first fully connected layer had 256 neurons activated by ReLU function. Softmax layers located at top of the model to generate the final partition pattern prediction. Here is the structure of our model. Due to the limited size of training data, dropout layers are added after the first fully connected layer to prevent overfitting. The dropout ratio is set to 0.3. As you can see, here is the convolutional block 1 and block 2 to 5 due to the limited size we omitted here. And here is the first fully connected layers, has 256 neurons. Here is the final output layers with 17 output represented as 17 partition patterns. Here is the structure of VGG16. As we can see, it's very deep, but we only need to train the last two parts of its convolutional layers. The pre-trained VGG model already has the ability to extract universal features like curves and edges in its early convolutional layers, but it may not be able to distinguish CTU partition pattern. In order to use the model for our task, fine-tuning is necessary. The strategy we use is freezing the first three convolutional blocks. In another word, only weights of last two convolutional blocks and the fully connected layers can be trained. Other weights loaded from pre-trained model will maintain constant during the training. Now let us jump to our experiment. The training and validation dataset consists of 14 video clips, in total of displayed resolution 352 by 288. The partition patterns are generated by reference software HEM and stored in Python dictionary, paired with its corresponding CTU blocks. In order to enlarge the size of training dataset to prevent potential problem of overfitting, we count by 7 video clips as one group. Each group has around 200,000 CTUs, and 80% of CTU are used as training data and the rest of 20% as validation data. Instead of training the model for a specific epoch number, we use early stopping strategy to avoid overfitting. Actually, the biggest problem we met during the training process is overfitting. We build the models using convolutional-based of VG16 and 19 respectively, and train them on dataset mentioned. Both models compiled with SGD optimizer with initial learning rate of 0.001. Since the partition pattern prediction is a multi-class problem, we use categorical cross-entropy as loss function. This graph shows the training and validation accuracy of model based on VG16 during the training. This graph shows the training and validation accuracy of model based on VG19. After we have trained the model, we also integrate the deep learning prediction process into HEVC encoder, which is use the model to predict the partition pattern before HEVC encoder starts its exclusive search. The results from our experiment indicate that, with the help of CNN model, HEVC encoder could encode one frame of size 342 by 288 within 1 second, compared to the traditional way, which uses 3 seconds to encode one frame. Its average encoding time reduction is 66%. As we discussed earlier, the CU split pattern prediction method in HM software is inefficient and not well suited for real-time use case. In this study, we took advantage of convolutional neural network to improve the prediction speed of CU split pattern. Our result demonstrates that the deep learning method model achieves 66% encoding time reduction and more than 65% prediction accuracy. In the future, we are planning to apply CNN to replace other computationally intensive models in H.265 HEVC encoder and speed up the encoding process of Ultra HD video. Here is the reference list of our presentation. And thanks for listening again. That's all of my presentation today. Thank you very much.
Hello everyone, it's an honor to participate in this meeting. The title of the paper I want to introduce is A Novel 3D Reconstruction Algorithm of City Images based on improved marching cube algorithm. In the following time, I will introduce this paper from the following 4 parts. The first part is the introduction. The second part is the marching cube algorithm overview. Then the third part is the improvement of the marching cube algorithm. And finally, I will show the experiment and analysis of the improved algorithm in this paper. In recent years, with the development of modern medical imaging technology, CT, MRI, ultrasound, and other medical imaging technologies have been widely used. In the great medical diagnosis, the doctor creates a 3D module in his mind by observing the CT sequence pictures. However, this approach obviously increases the difficulty for doctors to diagnose. The accuracy of the diagnosis made in this way depends largely on the experience of the doctor. In order to reduce the negative impact on the diagnosis, medical image segmentation and 3D reconstruction are performed with the help of computers. Generally, 3D reconstruction methods are mainly divided into two categories: 3D surface running and 3D volume running. Volume running operations are huge and can't meet the need of clinical interaction. Therefore, surface running is still the mainstream of clinical 3D reconstruction. Surface running is the reconstruction of intermediate geometric units from the original 3D medical image data. The geometric unit is used to describe the 3D structure of the object. In 3D reconstruction of medical images, the main algorithm used for surface running is the matching cube algorithm. Its essence is to extract an isosurface from a 3D data field, so it is also called isosurface extraction algorithm. In 3D reconstruction of medical images, the CT image is a tomographical slice, and two CT images in the sequence are taken to form the upper and lower sequences. The RDCT tomographical image is described by 3D coordinates to obtain a 3D image of the human body. A 3D image of volume data can be described by a 3D array with corresponding values. Each of these elements becomes a volume element, referred to as a voxel. A voxel has 8 vertices, and each vertex has 2 states, in-plane and out-plane. So there are 255 cases of the relationship between voxels and isosurfaces. By enumerability is 256 cases, we can get a trivial patch configuration index table to record the information that the isosurface intersects with the side of the voxel. The 256 cases are finally reduced to 15 types of the triangular patch configuration index table as shown in figure 1. The key of matching cube algorithm is to find the isosurface in the original data. To find the isosurface with a threshold value of C, you must find the points where the gray value function is C. The isosurface can be expressed as a collection of isosurfaces
as shown in quotation. In order to display the isosurface image, the normal vector of each triangular patch forming the isosurface must be calculated. However, directly calculating the normal vector of each triangular patch is complicated. The matching cube algorithm uses gradient vectors instead of normal vectors. The gradient of the vertices of the triangular patch is obtained by linear interpolation of the gradient of the voxels. In actual calculation, the century difference method is used to calculate the gradient of each voxel vertex. The basic idea of matching cube algorithm is to divide the Sandy space into multiple voxels, then iterate through each voxel to find a voxel that intersects the isosurface. Intersection points of voxels and isosurfaces are calculated by linear interpolation. Intersection points form trivial patches of different configuration within the voxels. The trivial patches are connected to complete the Sandy reconstruction. We can see that the CT image sequence is used as an input of a Sandy reconstruction process. The Sandy reconstruction module of the CT image is displayed as the final output result. And among the matching cube algorithm-based voxel improvement algorithm will replace the original voxel selection process. The smoothing and the distort coefficient are introduced in the calculation of the coordinates of the equivalent points by the matching cube algorithm to control the smoothness and the distort of the Sandy reconstruction module. Finally, before the output of the Sandy reconstruction module, a step of simplifying the triangular mesh is added to reduce the number of triangular meshes in the Sandy reconstruction module. First, introduce the improved voxel algorithm based on matching cube algorithm. A voxel is the basic unit of volume data. Due to the huge number of voxels and the complicated calculation process of the interpolation method, the calculation among the matching cube algorithm is very large, and there will be a delay during Sandy reconstruction. In order to improve the execution efficiency of the matching cube algorithm, this paper improves the voxel representation based on the matching cube algorithm. In the improved matching cube algorithm, the length of one side of the voxel is increased, as shown in Figure 4a and Figure 4b. The side length of the voxel in the x direction and the y direction is improved to 2 pixels. The improved voxel volume is doubled to the original voxel volume. Therefore, the number of voxels to be traversed during the Sandy reconstruction process is reduced to half, and the time required for reconstruction is greatly reduced. In terms of the influence of Sandy reconstruction accuracy, the improved voxel representation can still control the error range within 2 pixels, which has a little effect on the reconstruction accelerators. In order to further reduce the number of voxels that need to be traversed, this picture changes the voxel side length to 2 pixel length in the x and y directions at the same time, as shown in Figure 5. When calculating the coordinates of the ISO points, the margin cube algorithm first calculated the case where a voxel intersects the ISO surface and obtains several trivial patches. The traditional margin cube algorithm uses linear interpolation to calculate the coordinates of the equivalent points. When using linear interpolation method, it is necessary to assume that the function value of the discrete data field in 3D space changes linearly along the voxel boundary. The medial interpolation method is a simpler interpolation method. When calculating the coordinates of the equivalence points, it's only necessary to take the median of the coordinates corresponding to the edge where they are located. The medial interpolation method can reduce distortion at the cost of smoothness. In order to control the smoothness and the distortion of the 3D reconstruction module, parameter alpha is introduced in this paper to represent the smoothness and the distortion coefficient. Next, I will introduce the experiment and analysis of this algorithm in order to illustrate the effectiveness of the above algorithm. This paper implements a 3D reconstruction algorithm and the process of city images based on the improved margin cube algorithm. Two sets of city images are selected as environmental data. The pixel size of the two sets is 512 multiple 512. The first set consists of 29 city cells, and the second set consists of 250 city cells. Figure 6 shows the result of processing the first set of reconstruction data, which can clearly reconstruct the surface of a single liver tumor, as can be seen from the figure. Compared with the traditional margin cube algorithm, the proposed algorithm has a larger area and a smaller number of triangles. By comparing the reconstruction time, it can be seen from Table 1 that no matter for the reconstruction of the first or second set of data, the operation efficiency of the margin cube algorithm based on voxel changes is much greater than the traditional margin cube algorithm. This is because when the size of the voxel becomes longer, the number of voxels traversed during the 3D reconstruction process will be reduced. Therefore, the time of 3D reconstruction is greatly reduced, and the operation efficiency of the 3D reconstruction algorithm is greatly improved. When the amount of data that needs to be reconstructed is larger, the difference in visual perception between the results of the proposed algorithm and the traditional margin cube algorithm is smaller, and the efficiency of the algorithm is significantly improved. And then the smoothness and distortion can be controlled by introducing smoothness and distortion coefficients. In Figure 8a, under the condition that the smoothing distortion coefficient is equal to 0, the interpolation method at this time becomes the medial interpolation. It can be seen from the figure that the triangles that make up the isosurface are of uniform size, consistent shape, and neat orientation. The 3D reconstruction module is more rigid in visual effects, and the smoothness is reduced. In Figure 8D, under the condition that the smooth distortion coefficient is equal to 1, the interpolation method at this time became a linear interpolation method. It can be seen from the figure that whether on a flat surface or an uneven surface, the triangular patches that make up the actual surface will change in size, shape, and direction according to the gradient of the gray value. The smoothness of the 3D reconstruction module is improved, but this is at the cost of distortion of the 3D reconstruction module. Based on the above explanation, I got the following conclusion. Aiming at the problem of efficiency of 3D reconstruction algorithm of city image, this paper proposes an improved algorithm based on matching cube. First, by improving the representation of voxels, the volume of voxels can be increased. This reduces the number of voxels that need to be traversed during the 3D reconstruction process, and further improves the operation efficiency of the 3D reconstruction algorithm. At the same time, smoothing and distortion coefficients are introduced in the process of calculating the equivalent points to control the smoothness and distortion of the 3D reconstruction module. Before drawing the actual surface, the triangular mesh based on the measured error is used to reduce the output triangular mesh. The real-time interaction of the 3D reconstruct module is enhanced so that the module has a faster response speed in the process of translation, enlargement, and rotation.
Hello everyone, my name is Wang He. I come from Harbin Engineering University. It is my great honor to be here today to present my paper. The name of my presentation paper today is another simple enhanced dataset based on MFF for large angle face recognition. In the first part, I will give the background of the research. In the second part, I will give a detailed introduction of the methods I adopt. In the third part, I will introduce my dataset, experiment, process, and results. And finally, I will give a summary. First, Background 1. With the increase of information, face recognition has been widely used in public security, multimedia, identity, authentication, and other fields. Background 2. Physical single small range, clear environment, easy to recognize. It is called general face recognition. The face pose is the device. The range is relatively large. The environment is complex, and the recognition difficulty is high. So it is the reason of my research, the large angle face recognition. Then is the idea and method. It can be shown in these pictures. We first do face alignment on the photo, then obtain 3D parameters, and finally generate deep face estimation with MFF multitasking framework to generate large post-face samples. Next, I will discuss the samples in detail. On the first face alignment. On the face alignment network, FAN constructed by setting 4 edges in which are bottleneck blocks. This network uses the RGB images as input and face landmarks as output. It can be seen from this picture that this method has a strong robustness and performs well under the complex conditions, such as dark light and large face angle. Then is the pose estimation. We performed pose estimation on the face samples in CSI web face, where figure A, B, C, and D as the cases of 45 degree, negative 45 degree, 56 degree, and negative 57 degree around the y-axis. In most cases, pose estimation can be performed accurately, but a lot of face occlusions will reduce the accuracy of pose estimation method. And then is the 3D parameters. The 3D parameter is an important part of the MFF multitasking framework. The MFF framework and generate large angle. As shown in this picture, MFF is a multi-feature test framework that can reconstruct the 3D face with annotated information and the constraints of 3D parameters and texture conditions. In the before steps, we already obtained the 3D parameters and the image alignment points. After using MFF multitasking to form a strong constraint on facial identity information, we follow the method of Liu to mark some entry points outside the surface area and estimate their depths. After the depth information is obtained, a large angle face image can be generated. As shown in this figure, among A is the input picture and the raw angle is estimated to be 30 degrees after altitude estimation. B, C, and D are the results after the large angle is generated and the identity information is better retrieved. And then is parameters. First is this set. To begin with is the validation dataset. The first row is LeBron James. The second row is Calvin Durant. In this dataset, face pictures of 15 basketball players are extracted. These face pictures have various angles, most of which have raw angle greater than 30 degrees along the y-axis. The backgrounds of these face pictures are from different basketball games, which can keep these face pictures in a wild state. The simple dataset is constructed by 30-degree face pictures in total and 30 face samples extracted from every basketball player in average. Each and the next is the generated dataset and the performance. To generate high-angle face samples, 100 subjects are extracted from the CSI-web face dataset, which is called CSI-web face 100. The face arrangement of these selected 100 subjects is finished by using method of FEN. Then the selected dataset is divided into intervals -90 degrees to 0 degree and 0 degree to 90 degree by employing the method of pulse estimation using 5K points. To more accurately estimate the rotation angle of faces pictures, the divided two big intervals are further partitioned into small intervals by the step of 50 degree. Finally, 20 simple intervals are obtained, which is shown in table. We can see the CSI-web face 100 include the most samples are focused on the interval from -30 degree to 30 degree, and a few samples are distributed outside the interval from -degree to degree. Therefore, some additional work is conducted to enhance samples, especially in the interval from -90 degree to 30 degree and 30 degree to 90 degree. We can see from the table, the CSI-web face 100 in the interval 75 degree to 90 degree only have one face, but in our generator dataset we have the more than 800 faces. And then is our experiment results. The samples dataset is divided into 3 intervals, which are 0 degree to 30 degree, and 0 degree to 75 degree, and 0 degree to 90 degree, respectively. The face net is used to train the sample set in 3 intervals, and the CSI-web face 100 to investigate the influence of different face angles on the extracted features of the neural network, which can be used to verify the effectiveness of the sample enhancement method. Where we divided the dataset into 3 intervals. We want to see whether the large faces symbols is the important reason of large angle face recognition accuracy. And the FaceNet is the famous network to train the face in many environments. FaceNet is trained using 4 types of simple set. The lesser symbols is the CSI web face 100 and the 4 narrow networks after fine-tuning training are named A, B, C, and D, respectively. The validation set consisting of 30 hundreds basketball. Then we can see this table. Before we use our generated set, the accuracy only 0.8. But after we use our generated large angle faces symbols, we can see the accuracy is increments. And the last is conclusion of this paper. In this paper, a now simple enhanced dataset is constructed, which is composed of various angle phase picture symbols from 90 degree to 90 degree relative to the font phase. To generate the constructed dataset, multi-test feature framework is employed in this paper. The generated dataset is development by the CSI web face dataset, which greatly expands the symbols of the CSI web face dataset, especially for the large angle symbols. The FaceNet is employed and trained by using the generated dataset to test the effectiveness of large angle face recognition. 300 large angle face pictures of different basketball players are selected as another sample by using 4 different trained networks. The results demonstrate that the accuracy of face recognition has been greatly improved when the large angle face picture symbols are used to the work. And finally, thank you everyone.
Today it's my pleasure to introduce my study, a resilient multipath routing for the SDN-based space-based network. Here, to show my study, we will follow the 4 paths: background, multipath routing algorithm, experiment and results. The last is conclusion. First of all is the background of study. There is a question, why we do the study? In recent years, with the new development of space communication technology, more and more commercial space companies are launching aerial satellites to build space-based network for global communication. Inter-satellite networking and routing issue has become an urgent focus to be studied. So, it is worth considering the challenge in the research direction. Here, we present our study of multipath routing to solve the network resilience in space-based network. The space-based network is regarded as a very important network architecture to improve the efficiency of data communication, like this picture. It is a space-based network with 3 geo satellites, large aerial satellites, and the ground communication equipment. With the aerial satellite moving, the network topology is changing, and the space-based network faced many open challenges. First one is the high cost of the equipment for updating and deploying. The second one is the low robustness and resilience against the dynamic network structure changes. So, in this work, we incorporated the SDN architecture into the SBN to ensure the feasible implementation by separating the control panel and the data panel, like this picture. We deploy the aerial satellites, geo satellites, as the infrastructure layer, which affords the ability to transfer network data. And the ground network controller center regards as the controller layer to compute the routing path. So we can decrease the cost of network deployment and manage the network easily. However, with the time-varied network topology, there are still some problems of communication. So we present a new multipath routing to compute the backup path to adapt the fast network state changed and enhance the network resilience of the space-based network. Then, how we compute the multipath? Look at this graph. Firstly, we need to know how many paths we need. Secondly, we need to compute the path which has the smallest weight and judge whether the path already has exist. If not, add the path to the backup path set. Thirdly, adding an increment to the length of the path and update the weight of the network. Finally, repeat the whole process until the number of paths what we need are obtained. In this graph, we need to compute the 3 paths. First of all, we initiate the link weight of the network in graph A. We can see the weight value of every link equals to 1. Then, we compute the first one path ABF and add the increment weight equal to 1 to the link AB and link BF, like the graph B shows. In the graph B, we compute the second shortest path ACEF, then update the weight in graph C, but in the graph C, we compute the ABF which had existed in figure A. So we will absorb this path and add the increment to the path and update weight in the figure D. Finally, we calculate the third path ADEF and update the link weight in graph E. So we have finished the process of routing calculation and get 3 different routes. But in the space-based network, some nodes and links are easily filled. So we could initiate weight of these links with a bigger value to help us avoid these unreliable paths. Here, we compare the available paths in the graph from source node 1 to destination node 6 in different routing algorithms, including the following 5 routing algorithms. The 5 algorithms can compute different routes and the multipath routing of our study can calculate more available paths and more reliable paths, as the table shows. Then, we compose experiments on both random networks, ER network, and scale-free networks, B network, to verify the effectiveness of our MPR mechanism, which has potential applications in the future deployment of SBN. And the evaluation matrix we adopt is the successful forwarding rate and average path length. In our experiment, we compare the shortest path routing algorithm and our multipath routing algorithm with different link fill rate f and a different number of backup path k. Then let me show the results of our experiment. The first experiment is the SFR of ER network. In the figure A, we investigate the comparisons of two routing algorithms with different backup path k and the same link failure rate f in the efficient routing network. The data of a red circle is MPR and the black triangle is SPR. We can see that the MPR have a greater successful forwarding rate than the SPR, and when k is greater than 5, the successful forwarding rate of MPR is equal 100%, which means all the packets will arrive at their destinations. However, there is nearly no change in SPR. In the figure B and figure C, we increase the F, the failure rate reaches 10% and 20%. In general, the successful forwarding rate of MPR is higher than that of the SPR. Moreover, when the node failure rate reaches 20%, the successful rate of MPR is not low. In the figure D, we can see that the MPR have good performance in different node failure rates. The higher node failure rate is, the more backup paths needed. The next experiment is SFR of BA network. In the figure A to figure D, we set the same parameters as that in ER network experiment. The only difference is the network model. This experiment is in BA network. We can see the MPR have good performance in different node failure rate and better than the SPR, nearly same as the result in ER network. This experiment is SFR of ER and BA network with different K. In the figure A and figure B, we can see the effective of K value for the successful forwarding rate. The x-axis is node failure rate F, and the y-axis is successful forwarding rate. The K value is larger, and the successful forwarding rate is higher. Especially with the F is becoming larger, more nodes failed, so the number of backup paths is more important. As the figure shows, when k equals to 5, even the node failure rate reaches 20%. We can restore more than 90% of communication in the BA and ER network. The next experiment is the APL of ER and BA network with different K. In the figure A, we investigate the comparisons of 3 different values of F with different backup path K in ER network. As the K gets larger, the value of average path length is also smaller, because larger K means more feasible options for the alternative path switch. When the number of the backup path K is equal 4, the average path length just is nearly unchanged. In the figure B, the BA network is complicated, but the average path length tends to be stable and the value is lower than that in the ER network. As in the figure B, although there are some fluctuations, the average path length is becoming smaller as a whole, with the K becoming larger. With higher failure rate, the available alternative path number reduced, and a larger average path length is needed. The last experiment is APL of ER and BA network with different F. In the figure A, we investigate the comparison of 3 different values of F with different backup path K in ER network. As F gets larger, the value of average path length is also increasing from 3.9 to 5.3. Because the F gets larger, there are more links disconnected. Therefore, X arriving at the destination node will pass through more nodes. In other words, when the number of the backup path K is larger, the average path length is shorter. With F larger, the average path length is larger. In the figure B, the average path length of the BA network varies from 3.3 to 4 when the F changes from 0.05 to 0.2. However, when K equals 2 and 10, the average path length of the BA network has not obviously changed with the same F. Conclusion. To sum up, this work studied the resilient multipath routing for the SCM-based space-based network. It increased the successful forwarding rate and reduced the average path length when the nodes failure occur. With the rate of nodes failure is high, the resilience of the network is still high if the number of backup paths is big enough. Therefore, the multipath routing is meaningful for the resilience of space-based network based on HDN. That's all. Thanks.
Hello, all the members of the conference. It's my great honor to accept your criticism here. Thank you for your serious work. For nearly half a year's hard work, I have finished my paper and could share it with you. I will present my efforts to you all, and I gratefully welcome any correction. The title of my paper is a 3-part repeated game model for data privacy in mobile edge processing of IoT. Then, I will follow in these 6 aspects to introduce my paper. In the first part, I will tell you the introduction of this thesis. First, background. The IDC's report shows that there is an explosive growth in global data. IoT devices with numerous sensors are growing repeatedly, and computing power is getting stronger. The construction of smart city promotes the emergence of MECS paradigm. Subsequently, a series of data security challenges with MECS emerged, such as data ownership transfer, semi-trusted nodes, and so on. Second contribution. The main contributions of this paper are as follows. A. Build a repeated game model based on three-part entities and analyze the deviation behavior and payoff change among players in multiple phases of the sensing data life cycle. B. On the premise of maximizing benefits, identify the influencing factors and constraints of honest behaviors of players in different phases of MECS. Related work mainly includes the encryption scheme, blockchain technology, game theory, and so on. Encryption scheme. Based on cryptography, the scheme design and construction of data encryption, anonymity, disturbance, aggregation, and other aspects can be grayed out. But scheme overhead is subject to device performance constraints. Blockchain technology. Blockchain technology provides verification, support, and portable management for data security sharing. High reliability, tamper resistance, and so on. But the weak nodes are vulnerable to attack, and the transaction correlation exposes sensitive information. Game theory. From the perspective of game theory, through modeling and analyzing the behavior game between players, the prisoner's dilemma and other problems could be solved. But fine-grained studies of behavior interactions between multi-part entities are lacking. This section mainly introduces some preparatory knowledge. Next, we can take a look at our system model as shown in Figure 1. The excite entities such as sensing users, SUS, edge nodes, ENS, and cloud service providers, CSPs, in MECS, which are described as follows. Sensing users. A large number of ordinary people who apply smartphones, tablets, wearable devices, and other mobile devices as basic sensing units. After selecting the sensing task independently, they utilize various sensors integrated on the device to carry out sensing activities and upload the data to ENS with the help of wireless network. Edge nodes. With the help of mobile internet, sensing tasks are distributed to USUS and the sensing data are collected and processed by ENS. A large number of nodes with different functions and dispersions cooperate to complete a large cycle and complete social sensing tasks, and employ the processed data to trade with CSPs. Cloud service providers. They provide real-time services to SUS to meet their personalized needs by using sensing data or service models obtained from transactions with ENS. Then, we give the definition of repeated games. An infinite number of repeated games is a game process in which players repeated the same struggle for many times, and there is no fixed time to end the game. The behavior process of repeated implementation is called a stage game. Figure 2 shows an extended behavior game tree for repeated interactions between three entities. Figure 3 shows the observable behavior game tree of a single stage game played by three entities. It is also the basis for our repeated game work, as detailed in the reference 38 in our paper. You can see Figure 3a is the observable behaviors among SU, adversary 1, and EN in the data uploading phase. And Figure 3b is among EN, CSP, and adversary 2 in the data trading phase. Our repeated game model would include two phases of data uploading and trading to build and discuss. In the sensing data uploading phase, error, sigma, and tau denote the probability of players choosing to upload, attack, and leak, respectively. If all participants abide by the initial behavior of the social norms in our thesis, the strategic path in infinitely repeated games would be ideal, and the total payoffs of each enter are shown as Formula 1. With the premise condition of mu5 greater than mu3, we consider three cases in which adversary 1 and Heterogeneous make deviation behavior and calculate the total payoff function respectively. At the same time, in order to restrain the game participants from choosing deviation behaviors, their payoff function should satisfy the inequalities shown as Formula 5. Finally, we can get the constraints on mu6 and delta En to get to Nash equilibrium. Obviously, when the discount factor delta En and mu6 satisfy the relevant range, the game participants will not choose to deviate from the social norms, so as to protect the sensing user's personal private information. Similarly, we can get the constraints for the sensing data trading phase, as shown in this page. In this section, we conduct a numerical analysis on the proposed three-part repeated game model. In the sensing data uploading phase, Figure 4a illustrates that when delta En exceeds a certain value, En would change from the leaking strategy to the non-leaking strategy, and this value depends on mu5 minus mu3. With the increase of mu5 minus mu3, the critical value also increases, which is consistent with Formula 6. mu5 is the positive influence coefficient reflecting the payoff obtained by En's leakage behavior, and mu3 is the repetition punishment coefficient of En's leakage behavior. mu5 is a constant value for the sensing data of certain accuracy. By increasing mu3, that is, increasing the punishment for En on user's side, the critical value goes down, which makes the constraint conditions in Formula 6 easier to be reached, forcing En to choose the non-leakage non-leaking strategy. Figure 4b and Figure 4c show that the payoff of En and Su increases with the increase of delta En. At the critical value, the payoff of Su will increase greatly with the change of strategy choice of En. It is verified that En would be more inclined to comply with social norms within the range of constraint conditions. In the sensing data training phase, Figure 4D shows that CSP will be more prone to non-leakage behavior with the increase of delta CSP, and its critical value depends on K3 minus K2. K2 is the punishment coefficient for CSP's leakage behavior, and K3 is the positive influence coefficient reflecting the payoff of CSP obtained through the leakage behavior. Similarly, we can adjust K2 on the side of En to reduce the critical value according to Formula 7. Forcing CSP to comply with social norms and choose not to leak. As can be seen from Figure 4e and Figure 4f, the payoff of CSP and En are increasing with the rise of delta CSP. In detail, Figure 4e shows in the case that the value of K3 minus K2 increases, the payoff of CSP increases with the rise of delta CSP, which indicates that the smaller K2 is, the lighter the punishment on CSP is, and CSP is more likely to choose the leakage strategy. It is verified that K2 is the critical factor influencing CSP's choice of leakage and a non-leakage strategy. Additionally, when delta CSP is at the critical value, the payoff remains the same regardless of whether CSP chooses the leakage behavior or not. When delta CSP exceeds the critical value, CSP would gain more from choosing non-leakage behavior over leakage behavior, which verifies CSP's corresponding constraint conditions on compliance with social norms in Formula 8. Figure 4f shows that En's payoff has a significant change at the critical value, which also reveals the key influence of CSP's leakage and non-leakage behavior on En's payoff. When K4 is greater than 3 mod C over cells D, Formula 8 indicates that a smaller discount factor delta adversary 2 is required to satisfy the constraint. Figure 4G manifests that adversary 2 strategy is more inclined to leak with the increase of K4, forcing us to choose smaller delta adversary 2. Additionally, Figure 4H shows that when K4 is at a small value and delta adversary 2 does not meet the constraint conditions, the payoff from adversary 2's choice of leakage is much less than the choice of non-leakage. Therefore, on the premise of meeting the constraint conditions, the adversary 2 after repeated games would not deviate from the social norms. In this case, En's payoff would also increase significantly in this range, which is consistent with the results in Figure 4i. At last, I have a summary of our shape. Based on game theory, we constructed a 3-part repeated game model, considering the possible interaction strategies among 3-part repeated game model for data privacy participants in different phases. We analyze their potential differentiation strategies, calculating the change of payoff, and further explores the influencing factors and constraints that regulate participants' honest behaviors in the game. That is all my content. Thanks for your listening.
Abnormal data mining method in environmental monitoring data of animal husbandry farm by Xu Xiaohua, Chen Changxi. Abstract. In order to solve the problem of low accuracy of traditional anomaly data mining methods, this paper proposes an anomaly data mining method in the environmental monitoring data of livestock farms. Through collecting the environmental monitoring data of animal husbandry by sensors, after getting the environmental monitoring data, the environmental monitoring data is pre-processed, and the data after pre-processing is mined to complete the design of abnormal data mining method in the environmental monitoring data of animal husbandry. Compared with the traditional methods of outlier data mining, the experimental results show that the proposed outlier data mining method has higher mining accuracy. Keywords: animal husbandry, environmental monitoring, abnormal data mining. Introduction. With the adjustment of agricultural structure and the support of relevant national policies, agriculture, forestry, animal husbandry, and fishery have developed rapidly. Especially animal husbandry accounts for 1/3 of the overall output value. According to the data of the National Bureau of Statistics, animal husbandry is maintained at an average value of about 30% every year, which not only increases the economic income of farmers, but also promotes the circulation of the national economy and increases the GDP. Although large-scale breeding had gradually replaced the traditional extensive breeding mode, this trend still cannot change the extensive management mode in the breeding process. The ventilation, sewage, heating, and other facilities are not complete, or even not, resulting in the poor growth environment of livestock, which is easy to cause animal disease, death, and poor quality of animal products. With the concept of healthy breeding, some domestic farms have improved their understanding of breeding management, strengthened supervision, and ensured product quality. However, imperfect breeding management is still common, resulting in frequent occurrence of animal diseases. Traditional breeding, extensive breeding, and sky-dependent breeding still account for a considerable proportion. With the emergence of new animal husbandry production or organization forms, the traditional family and single-family farming forms decrease year by year. It is of great practical significance to use high technology to carry out environmental monitoring on livestock farms for improving the quality of livestock products and reducing the occurrence of various animal diseases. By mining the abnormal data in the environmental monitoring data of the animal husbandry farm, we can find the abnormal environment in the animal husbandry farm so as to deal with it in time. However, in the traditional animal husbandry environmental monitoring data, the method of abnormal data mining has the disadvantage of low mining accuracy, which needs further research. On this basis, a method of mining abnormal data in the environmental monitoring data of livestock and poultry farms is proposed. Method of abnormal data mining in environmental monitoring data of livestock farm. Data collection. First of all, the environmental monitoring data of livestock farms are collected by sensors. The sensor is responsible for collecting data and then transmitting it to the microcontroller, which then transmits it. Figure 1 shows the follow chart of the sensor. As can be seen from Figure 1, the upper computer can control the acquisition of data by sending instructions. The upper computer sends instructions and the MCU receives the collection information instructions from the monitoring end, then packs the data and sends the data to the upper computer system. After obtaining the environmental monitoring data of animal husbandry farm, the pre-treatment is carried out. Data pre-processing. Data pre-processing includes data cleaning, data integration, data conversion, data discretization, data reduction, and data reduction. The data pre-processing process is shown in Figure 2. In the integration stage of data cleaning and data, first, simple data filtering and cleaning are carried out. Errors and duplicate data are removed. And then relatively clean data is obtained. And then incomplete data is merged or completed. Then data is standardized and normalized, and the final data values are all between 0 and 1. So it provides a good foundation for the abnormal data mining of environmental monitoring data of livestock and poultry farms. The data reduction algorithm can well deal with attribute reduction under the condition of dynamic increase of environmental monitoring data in animal husbandry farm. The reduction effect is obvious and the time is very short. The processing structure is shown in Figure 3. In Figure 3, the environmental monitoring data is reduced. The specific implementation process is as follows. According to the rough set theory, mutual information equality can be used as the termination condition to find the relative reduction of knowledge. Based on this, a new calculation formula of attribute importance is proposed in combination with mutual information theory. This formula does not calculate the importance of data relative to attribute reduction, reduces the calculation time of attribute importance, and thus reduces the time of attribute reduction. The formula is described as follows. For the processing of missing value, large range interpolation method is used. Take out the 5 data before and after the missing value respectively. If the data before and after the missing value is empty or non-existent, directly rounds off the data. According to the 10 data, form a group and use large range difference formula to interpolate the data. The large range difference formula is shown in Formula 2. Data mining. Data mining is done by clustering and fast computing algorithm. In clustering algorithm, outliers are usually regarded as leaf nodes in clustering feature tree, and the density of leaf nodes is very low, usually set a fixed threshold. If the number of sample data objects of one leaf node is less than the set threshold, or the number of samples in this leaf node is the least compared with other leaf nodes, then it can be considered that it is very possible that the leaf node is an outlier. And then the leaf node is added to the outlier dataset if the set threshold changes so that the sample object that has been included in the abnormal data set does not meet the condition of being an abnormal point. It should be reclassified into the clustering feature tree. First, cluster the original data set and calculate the size of the local anomaly factor, and it is also related to the density of its surrounding neighbors. The local outlier indicates the abnormal degree of an object. If the larger the local outlier is, the greater the abnormal degree of the object is. Otherwise, the smaller. Because the local exception factor of each object of LOF algorithm is related to the environmental of the object in the dynamic incremental database environment, new data objects often affects the local exception factor of the same objects in the original dataset. So, it is necessary to call LOF algorithm to recalculate the local exception factor for all data objects. However, the new data object will only affect the local abnormal factors of some data objects, but not all data objects. Therefore, it is improved. If the data in the database is updated, only the affected data objects need to be recalculated, which greatly improves the speed of abnormal data mining. In order to improve the speed of abnormal data mining in environmental monitoring data, the LOF algorithm and the dbScan algorithm are combined to improve the algorithm. First of all, dbScan algorithm is used to cluster the original dataset. The dense data objects are subtracted from a large number of datasets, and the sparse data objects that are not clustered are retained to form abnormal clustering. On the basis of clustering, the data in the cluster is judged, and the abnormal data is added to the abnormal cluster. Finally, LOF algorithm is used to calculate the local abnormal factors for the data objects in the abnormal cluster. After clustering the new data objects, we can judge which data objects are dense and which are sparse, and add the sparse data objects to the new abnormal dataset. Then, on the basis of the above improved algorithm clustering, we calculate the average of the cluster centroid and the distance from all data objects to the centroid of the cluster, and then calculate the distance between each data object in the cluster and the cluster centroid. If the distance is less than the average value, the data object is considered normally. Otherwise, it is considered abnormal data object, and the abnormal data object is added to the new abnormal data set port. Because the main research object of LOF algorithm is the data object with sparse distribution in the dataset, so the data object with sparse distribution in the original dataset and the data object with sparse distribution in the new dataset need to use LOF algorithm to calculate the local abnormal factor. Because the sparse data objects in the original dataset, the data objects in have calculated the local exception factor with the LOF algorithm in advance. When the new data objects arrive, the data objects in the new exception dataset, and the exception dataset are affected by the data objects in the new exception dataset, resulting in the change of the local exception factor. Therefore, the data object N can be recalculated with the local exception factor and sorted according to the size of the local exception factor. So the former data object is the real exception data object. Experiment. In order to verify whether the abnormally data mining method in the monitoring data of animal husbandry farm has higher mining accuracy, the paper compares the proposed abnormally data mining method with the traditional abnormally data mining method. It can be seen from Table 2 that with the increase of new data object, the calculation time of the algorithm does not increase significantly. The results show that the algorithm is efficient and meets the calculation requirements. On this basis, in view of the 5 groups of animal husbandry environmental monitoring data with different amount of abnormal data, the mining accuracy of the paper's abnormal data mining method and traditional abnormal data mining method is compared. Analysis of experimental results. Compare and analyze the mining accuracy of the proposed abnormally data mining method and the traditional anomaly data mining method. The comparison results are shown in Figure 5. Concluding. In view of the low accuracy of the traditional methods of outlier data mining, a method of outlier data mining in the environmental monitoring data of animal husbandry is proposed. Through the comparative experiment compared with the traditional abnormal data mining methods, the experimental results show that the proposed abnormal data mining method has a higher mining accuracy, hoping that it can provide a certain reference value for the research of abnormal data mining in animal husbandry environmental monitoring data. Okay, this is our fund project. And finally, I'll give you a brief introduction to another of my papers. Embedded livestock and poultry breeding environment data acquisition method based on Internet of Things. The current method of collecting environmental data of livestock and poultry facility breeding cannot automatically screen out abnormal data. So an embedded method of collecting environmental data of livestock and poultry breeding based on Internet of Things was designed. First, design topology structure of the Internet of Things. Make different cluster head nodes can communicate with each other. Improve the communication ability of member nodes. Introduction the environmental perception technology, including the temperature, humidity, anomia, hydrogen sulfide and carbon dioxide, thermoelectric effect of rely on the thermal occupied temperature sensor acquisition. Harmful gas depends on the choice of gas molecular light absorption characteristics, absorb certain wavelength of light condition to obtain the corresponding information of harmful gas concentration. The final design of acquisition circuit data acquisition process completed based on Internet of Embedded Data Acquisition method of design of livestock and poultry breeding environment. The experimental results show that the design collection method can summarize abnormal data and separately list the occurrence time and corresponding item of abnormal data, which provides great convenience for controlling the breeding environment. Thank you.
Ladies and gentlemen, I'm honored to have the opportunity to introduce our research work here today. I'm Lin Jiwon. I come from Guizhou University, Guiyang, China. I will introduce our work from the following 4 sections. Section 1, Introduction. Section 2, System Model. Section 3, the scheme of CDAA. Section 4, Conclusion. The first section is Introduction. The authentication problem is one of the most significant challenges in the industrial Internet of Things control system application. How to manage and authenticate a trusted device from IoT systems is an important problem to pay more attention. In the conventional authentication, researchers, password-based digital signatures and anonymous authentication do not protect the user's privacy completely. We analyze 2 practical scenarios. First scenario, in a same administrative domain, while the supervisor entity A wants to command the subordinate entity B, it should provide a legal authoritative signature to show the legality of its command. Second scenario, in a different administrative domain, entity A wants to access subordinate entity B of entity C. It should provide a legal authoritative signature to illustrate the legality of its command. How can the entity A directly access the entity B in both above scenarios? In this section, we analyze detailed the relationship between various devices shown in Figure 1. In the Euro network layer, we can find that Alice can view the logistic, order goods, and e-commerce in the office, as well as Bob can view storage, workshop, and after-sale service in the office. If Alice supervisor L wants to monitor the workshop, which belongs to another supervisor's managed domain, he needs to go through the legal permission layer by layer and finally get Bob's authentication to permit it, even though he has the legality certification. The question is why Alice does not access the workshop directly since he has legality certification. In order to enhance the illustration of authentication service and application scenario in the IoT, we established the architecture graph with 3 components. The first component is cloud computation layer. Users upload their data to the cloud, and the cloud returns the computation result. 2. User network layer. User propose an authentication requisition and computes related digital signature and witness used to prove the legality of signature. 3. Application device layer. As the user of IoT technology, the device transfers the collecting data to another layer. 2.2 Graph Model. It can be clearly seen that all the nodes are valid digital signature. Node V1I hence can be authenticated by node VQS. The blue dotted line showed in figure 2. If node VKM wants to access the node VQH, we can see that node VKM and node VQH belong to different administrators, that is, in the different administrator domain. In view of the above situation, the paper focuses on studying the digital authentication across the domain between VKM node and node VQH. The dotted line in red and blue of figure 4 represent the established authentication relationship between non-adjusted nodes through the URL network layer. 2.3 Syntax Execute CDAA for the general graph E consists of 7 algorithms. For example, initialization, generation algorithm, age label algorithm, age value algorithm, accumulator update algorithm, accumulator verify algorithm, age delete accumulator algorithm, witness update algorithm. 2.4 Security of CDAA. The security requirements of the CDAA are defined through the following game between the challenger and attacker. The security proof consists of 4 phases. Phase 1, commitment. Phase 2 is training. Phase 3 is challenge. And phase 4 is verification. Definition 1. The CDAA is unforgeable and chosen message attacks if the following function is negligible for NAPPT adversary A. 2.5 Privacy. Let graphic D be composed of node IJK and 8 IJK. The meaning of privacy is the verifier not updating any other information about other nodes and age. Receive a witness for IJ. Definition 2. The CDAA is leakage-free, even if an adaptive chosen message attacker could know any undisclosed information of group. 3. Cross-domain dynamic accumulator authentication. 3.1 Concrete scheme. In this section, we give the 7 algorithms in detail. The first algorithm is parameter generation algorithm, and the second one is the age label algorithm. The third one is the age value algorithm, and the fourth one is the witness create algorithm. The fifth one is the accumulator verify algorithm, and the sixth one is the age delete accumulator or the age adding accumulator. The last one is the witness update algorithm. 3.2 Correctness. The correctness proof of CDEE will be given, and we assume that ECCX is an accumulator for SK, PK, for each X belongs to big X. The update witness is correct while the following equation holds. 3.3 Computational cost. Table 1 shows the computation complexity analysis on the maximum computation cost of one number during the execution between our protocol and literature 4. By the comparison, we can find that while adding a new edge VIK-VGS to the graph D, the computation cost of all the algorithms are less than the literature 4. 3.4 Experiment evaluation. Figure 3 shows the execution time cost of accumulation. The bilinear maps accumulator is much faster than the RSA accumulator about the total running time of the key generation, edge level algorithm, edge value algorithm, and accumulator update algorithm. The figure 4 shows the execution time on updating the witness between PPAG and CDAA. Depending on the number of elements from 500 up to 8,500. Nevertheless, it is noteworthy that the chosen user knows all meets the requirements of the PPAG scheme. The result shows that the CDAA has better performance than the PPAG. Figure 5 shows the running time of verification between the PPAG and the CDAA. The results clearly reflect that all the number of elements increase, the verification time of both protocols increase. Notable: when there is 8,500 elements, the verification time of PPAG is almost 1.5 times than the verification of CDAA. 3.5 Computation cost. We represent a scheme which has one concrete attribute. The concrete comparison with other schemes is shown in Table 3. 4. Conclusion. This paper abstracted the relationship of device as a node in a general graph and took the advantage of a dynamic accumulator based on bilinear pairing to achieve the authentication of equipment. Our authentication scheme not only relies the authentication of vertical nodes, but also satisfies the authentication transmission of horizontal nodes. The secret analysis shows that our protocol satisfies secure requests on the accumulator authentication in the Internet of Things. In our future work, we will further design more efficient CDAA scheme to facilitate the authentication speed. These are our references. Thank you for your attention.
I'm honored to have the chance to speak at this conference. The topic of my paper is blockchain-based vehicular collaborative computing. The outline of my talk is as follows. In the first part, I want to introduce the background of this research. The second part suggests the system model. The third part covers the proposed algorithm. And then we introduce the simulation results. The last part is take-home message. The background of this work is like this. With the rapid development of computing and communication technologies, vehicles become more intelligent. In this context, some new intelligent applications like AR, VR emerged. However, there is a need for a quicker response. Despite the continuous improvement of vehicular computing capacity, there is a contradiction between the supply and the demand of computing resources, and the contradiction is growing. To solve this problem, the vehicle needs to request the help of external computing resources. There are three options here: cloud computing, edge computing, and the vehicular collaborative computing. Different from cloud computing and edge computing, which use the computing resources of central servers, vehicular collaborative computing tries to make use of idle resources of other vehicles to complete the task and improve resource utilization. Vehicular collaborative computing has the following challenges: high mobility and fast-changing topology, incentives for vehicles to contribute resources, reliability of collaborative activities. In order to meet these challenges, we first regard collaborative computing as a process of resource transaction and use the reward to motivate vehicles to contribute resources. Then, on this basis, we propose a blockchain-based architecture to enhance the transaction reliability. And finally, we propose a corresponding collision formation algorithm to improve utility and task performance. To enhance the transaction reliability between vehicles, we propose a system architecture. It is a two-layer vehicular blockchain architecture that includes a vehicular layer and an edge layer. The vehicular layer contains vehicles along the road. Some vehicles form a collaborative computing collision to complete the task together. The computing collision also maintains a temporary blockchain network that stores transaction data of the collaborative computing process. The edge layer contains RSU and the base station. Since their location is fixed, a permanent blockchain network can be maintained, which stores the data from temporary blockchains permanently. Then, let's consider the collaborative computing scenario in vehicular networks. In this context, vehicles can be divided into two types: one requesting vehicle V0 and n assisting vehicles nearby. When a requesting vehicle has a task, it posts a task request to ask for help. The request contains three values. AV0 is the computing amount of the task. TV0 is the completion time limit, and the XV0 represents the minimum computing power to complete the task, which is equal to AV0 divided by TV0. RV0 is the reward payment for the collision if they complete the task. The computing power of vehicle VI is represented by XVI. Assume that due to the limitations of AV0 and TV0, a single vehicle in a set N usually cannot complete the whole task alone. Therefore, the vehicles form the collision S with greater total computing power, which is represented by XS. XS is the sum of XI. In order to complete the task in a shorter time, the task payment RV0 is defined as a function of XS. After that, the requesting vehicle will pick one or more computing collisions to complete the task. When a collision completes the task, the members will get paid and these transactions will be recorded in the blockchain. To balance both sides' interests, we employ the coalition formation game to model such a collaborative computing process and propose a distributed computing coalition formation algorithm. Here is a short introduction about the coalition formation game. To get the revenue, assisting vehicles form different coalitions. Besides the revenue, the coalition generates some overhead or cost. The difference between the revenue and the cost is pure profit or utility. Vehicles select one coalition to earn profit. The coalition selection strategy is the coalition formation game. In our scenario, the cost of the collision includes computing and communication costs. C1S represents the computing cost and measured by computing power Xi, computing time Ts, and the unit cost Pi. Unit cost is like the power consumption per unit time. Vehicles need to transfer messages directly or by using blockchain, which brings communication cost. The amount of the communication cost is related to the size of the coalition and the distance among the vehicles. It is represented by C2S and C3S respectively, and the utility of the coalition is represented by US, which is equal to the revenue minus the sum of various costs. Based on the utility definition, we define a basic operation switch, which means vehicle VI can leave coalition A and join coalition B if the computing power of the new coalition formed by B and VI exceeds A. Meanwhile, the utility of B is not decreasing. Switch operation encourages the emergence of coalitions with greater computing power, which is good for the requesting vehicle, and hopes to maintain the utility of the coalition, which is good for assisting vehicles. The next concept is partition. Partition is the set of all coalitions formed by the N assisting vehicles. The partition is represented by P. Convergence. The partition P reaches convergence if all the vehicles choose to stay the arranging collision. It also means the prerequisites for switch operation is no longer true. Based on these concepts, we design a computing collision formation algorithm that consists of two phases. During the first phase, the vehicles perform switch operations in a random way and update the collisions. And finally, partition P reaches convergence. No more switch operation can happen. The output of the first phase is an updated partition P. In the second phase, the requesting vehicle selects the appropriate collision or collisions from the partition. In most cases, the collision with maximum computing power is selected. However, sometimes no collision in the partition can provide computing power more than x0, which is the required minimum computing power. Then, the requesting vehicle will choose multiple collisions and divide the task. In our paper, we select the collisions with the greatest computing power once the sum computing power meets the requirement. In our conducted simulations, the requesting vehicle is placed at the center of the road with a length of 100 meters and a width of 10 meters, and the other vehicles are placed randomly on the road. The number of assisting vehicles varies from 5 to 15 in the experiment. The other simulation parameters are listed in the table on the right. We will compare our collision formation game-based algorithm, denoted as CF, with two baseline schemes. One scheme is maximum utility scheme, MU, which selects the collision with maximum utility by using the exhaustive method. Another one is nearest selection scheme, NS, which selects the nearest vehicles to the requesting vehicle, whose total computing power is more than the minimum computing power. The picture on the left is a snapshot of a network with 10 assisting vehicles. By using the collision formation game-based algorithm, the vehicles form 3 collisions in this example. The table on the right shows the utility and the computing power of the collisions. The picture on the left compares the utilities of the selected collisions generated by 3 different schemes. We can find that the utility obtained by scheme CF is very close to the one by scheme MU, which indicates that CF can guarantee the assisting vehicles getting well paid from the task. Moreover, we can also see that scheme NS performs much worse than CF and MU. This is because NS forms the collision in a greedy manner to get enough computing power, which includes join operation only and does not include leave operation. In the picture on the right, the computing power of the 3 schemes are compared. We can find that the computing power of CF and MU are close where the number n varies from 5 to 10, and then CF begins to perform better than MU. And we also have that NS performs better than CF and MU when the number n is 5 or 6. This is because NS tries to gather enough computing power without considering utility at first, and may form the larger coalition which is hard for CF and MU when the number n is relatively small. It shows that the proposed algorithm can significantly improve the vehicle's utilities as well as the task performance. This is take-home message. First, the computing task can be completed by using idle resources of a group of vehicles. Second, coalition formation gain is an efficient means to enable distributed collaborative computing in vehicular networks. Third, blockchain can be employed to enhance the reliability of computing resource transactions. That's all. Thank you for listening.
I'm so honored to be with you to communicate academic questions and ideas. The title of my academic presentation is Blockchain-Based Collaborative Decision-Making in Vehicular Networks. The outline is listed as follows. In our researches, we propose a blockchain-based collaborative decision-making model, which is divided into two parts, the architecture level and the algorithm level. This BCDM model can solve the following three problems. First of all, the BCDM model eases the data calculation and storage pressure of vehicular networks. Secondly, it guarantees the security of the whole vehicular network system. What's more, the model combines direct trust and indirect trust to determine the occurrence of traffic events and identify false messages. The BCDM model contains following three sub-models. At the network level, the BCDM model includes an innovative layered blockchain network architecture, which can protect the system's security while avoiding onboard memory and computing resources that are occupied by blockchain data. As illustrated in left figure, the LBNA is divided into two layers, namely the center layer and the edge layer. The edge layer includes multiple groups of temporary blockchain networks, and each group is composed of vehicles in the same traffic environment. Because the vehicle itself has inherent characteristics, such as high mobility, relatively small onboard memory, and relatively low onboard computing power, the TBN will not exist for a long time. Before the TBN disintegrates, the last miner node will upload the necessary data for the entire chain to the center layer. The center layer is a permanent blockchain network, which is composed of RSUs, base stations, and databases in a large geographical area. These nodes have stronger computing and data storage capabilities, which can process and save massive data from edge layer in order to query historical records or trace information sources when necessary. In addition, the PBN will perform statistics and analysis on the historical quality of messages broadcast by each vehicle, and thereby identify malicious vehicles. The LBNA can be abstracted into the architecture on the right. While driving, vehicles often face a variety of complex traffic events, such as road construction, road congestion, or different types of traffic accidents. These traffic events make up the collection event. In our researches, it is assumed that traffic events have been pre-classified, and each type of traffic event is divided into different levels. In addition, the BCDM model will set a corresponding prior probability for each level of a specific event based on empirical statistics on traffic big data. During the driving process, the surrounding environment will be detected by onboard sensors. Once a specific traffic event is observed, the event will be evaluated according to the preset event levels, and a cooperative awareness message will be generated based on this assessment result. All the cams received by a vehicle constitute a site cam. Our goal is to judge the actual traffic situation based on these cams. Each vehicle in the TBN will infer and judge the true situation of events based on two principles of direct confidence and indirect confidence. The BCDM model can calculate the comprehensive trust of each vehicle and perform aggregation processing to get the final discrimination result of the specific traffic event. Next, I will introduce the three algorithms we proposed in the researches. The BCDM algorithm has 4 steps. The step 1 is to calculate direct trust. The vehicle's direct trust is an assessment of the reliability of vehicles' broadcast cams. The closer the vehicle is to the event, the more reliable the information it detects. Therefore, we set up a distance trust and use its arithmetic mean to represent the direct trust. The vehicle's indirect trust is calculated based on its historical reputation. When a vehicle has joined the TBN, the historical reputation is the real-time accuracy of all cams it has broadcast. In order to ensure the reasonableness of the historical reputation evaluation of vehicles, we will focus on examining the performance of cams when vehicles join in the TBN this or the penultimate time. Therefore, the weighted aggregation method is used to calculate the indirect trust. based on the step 1 and the step 2, we can get the comprehensive trust corresponding to a certain broadcast vehicle. In step 4, we use Dempsey-Schaffer theory to fuse the comprehensive trust of multiple vehicles on the same event. The Dempsey-Schaffer theory is often described as an extension of the probability theory or a generalization of the Bayesian inference method. It has excellent performance in the processing of data fusion. Finally, the algorithm will output the final trust result corresponding to a specific traffic event. The other two algorithms are based on blockchain theory. We choose to adopt the proof-of-stake manner election method for the blockchain network architecture. Compared with proof-of-work, POS is more suitable for application in the field of vehicular networks. It can greatly shorten the time to reach consensus in each block and doesn't require energy consumption for mining. What's more, the BCDM model will identify and punish malicious vehicles based on the data stored in the blockchain. The specific execution rule is to calculate the proportion of false cams to the total cams broadcast by each vehicle in the current TBN. If the proportion of false cams exceeds the threshold 1, the corresponding vehicle will be warned by broadcast. If the proportion of false cams exceeds the threshold 2, the corresponding vehicle will be punished by banning broadcast cams. In order to evaluate the efficiency of the proposed BCDM model, we conduct 2 sets of simulations based on MATLAB. The configurations of K parameters are listed in the table below. In the simulation experiment, we classify all vehicles into 3 categories: trusted, untrusted, and malicious vehicles. Malicious vehicles are vehicles that intentionally broadcast false cams, whereas untrusted vehicles are vehicles that accidentally broadcast an error cam because they are far away from where the event occurred. In order to simulate a real traffic scene, a certain percentage of random vehicles will detect traffic events and broadcast them during each iteration. The number of the iterations is 150 in the simulation. In the event discrimination accuracy experiment, we compare our accuracy performance with the paper Blockchain-Based Decentralized Trust Management in Vehicular Networks. That paper calculated the credibility of the vehicle broadcast message through Bayesian inference to determine whether the event occurred. From the right figure, we can see that as the population of malicious vehicles gradually increase, the accuracy of our BCDM algorithm is always higher than the scheme in the control group, and when the population of malicious vehicles is less than 55%, the BCDM algorithm can keep the discrimination accuracy at 100%. We use precision and recall as evaluation parameters, which are widely used in the CDM scenario. Wrong broadcast vehicles means malicious vehicles and untrusted vehicles. In the figure on the right, it shows the impact of malicious vehicles on precision. When the population of malicious vehicles is 65% or less, the precision of BCDM exactly matches the baseline. The figure on the right shows the impact of malicious vehicles on recall with different populations of direct trust. In comprehensive trust, the more malicious vehicles in TBN leads to the smaller proportion of direct trust and the better recall performance. However, direct trust can measure the trustworthiness of CAM itself and play an indispensable role in the BCDM model when there are fewer malicious vehicles. Therefore, the proportion of direct trust in comprehensive trust cannot be too small in practical applications. Finally, take-home message. The blockchain-based collaborative decision-making model contains the center layer and the edge layer. The edge layer includes multiple groups of temporary blockchain networks, and the center layer is a permanent blockchain network. The BCDM model will discriminate events based on CAMs and score each vehicle's reputation. The BCDM model has better decision-making performance and also makes practical contributions to the innovation of cooperative vehicular network architecture. That's all. Thank you.
Hello everyone, my name is Li Jun from Jiangxi Institute of Applied Science and Technology. Is a full-time teacher. The topic of my thesis is Data Transmission Deployment and Reliability Analysis in Enterprise Informatization Construction. In the construction of enterprise informatization, the traditional reliability analysis method of data transmission deployment has the problem of high data packet loss rate, which affects the reliability analysis result. Therefore, data transmission deployment and reliability analysis in enterprise informatization construction are proposed. Firstly, the wireless transmission module is designed to ensure the safe and barrier-free transmission of data, and the CAN interface is designed to connect all links in the information construction with the wireless transmission module. On this basis, data is divided and deployed by data deployment algorithm. Path loss of data transmission channel is taken as the basis of reliability analysis, and reliability analysis is completed by calculating various losses. The experimental results show that, compared with the traditional method, the data transmission deployment and the reliability analysis method designed in the enterprise information construction has no packet loss, and the data is safe and reliable. This method is suitable for the application in the enterprise information construction. There are 5 parts in my PowerPoint. Introduction. Enterprise is the representative of the country's economic strength, which plays an important role in the process of national economic construction and development. The effective development of enterprises is an important guarantee for the country to realize modernization and strengthen the country. With the development of information technology, enterprise information construction is a common way to improve enterprise efficiency in the 21st century. Therefore, how to do well in large-scale enterprise information construction has become one of the focuses of scholars in recent years. Enterprise informatization construction refers to the establishment of enterprise information planning blueprint based on the planned objectives of the enterprise, combined with the practice of enterprise informatization and the mastery of the development trend of information technology, so as to guide the enterprise informatization process comprehensively and systematically. Coordinate the application of information technology, make full and effective use of information resources of enterprises, and meet the needs of business development of enterprises. It is a gradual derivation and definition process from the goal and business process of enterprise information construction to the framework of information system and implementation strategy of information system. It takes the realization of enterprise information construction goal as the ultimate goal of information and system implementation. In the past, there was data packet loss in the data transmission deployment of enterprise informatization construction, which led to the lack of a strong basis for reliability analysis. Therefore, the data transmission deployment and reliability analysis in the enterprise information construction are proposed. Because the path loss in data transmission is an important index to measure the reliability of enterprise information construction. The evaluation of path loss in data transmission has been widely concerned by researchers. Most of the research on path loss evaluation in data transmission is based on the premise that data is transmitted through disjoint path. However, in real life, data will inevitably be transmitted through paths containing the same link. Therefore, the reliability of path loss in data transmission is analyzed to judge whether enterprise information construction is reliable. Data transmission deployment in enterprise information construction. In the enterprise information construction, due to the bad working environment and strong interference, the data transmission module with strong anti-interference ability and error detection and correction ability is selected to ensure the accuracy of data transmission. After experimental comparison and test, String 35 industrial low-power wireless data transmission module meets the requirements. The channel center frequency of String 35 wireless data transmission module is 900 MHz, which has high anti-interference ability and low bit error rate. The modulation mode based on GFSK and efficient forward error correction channel coding technology are adopted to improve the ability of data anti-burst interference and random interference. The module can automatically filter out the false data generated in the air. The interface baud rate is 19,200 bps. flexible programming, no need to prepare redundant programs, as long as the data from the interface can be sent and received. Reliability analysis of enterprise information construction. The reliability of enterprise information construction is analyzed from the path loss of data transmission channel. Path loss is defined as difference between the effective transmit power and the received power, which represents the attenuation of the signal, and the unit is a positive value of dB. Path loss consists of three parts: transmission loss, shadow fading, reflection loss, and diffraction loss. In practical work, such as deploying a data transmission channel in order to ensure the reliability of the enterprise information process, the channel is generally calculated. One of the important contents is to calculate the transmission loss of the channel to measure the degree of path loss in the transmission process of data. With the increasing distance between the transmitting end and the receiving end, the intensity of electromagnetic wave will continue to decline. The path loss in free space refers to the attenuation degree of the transmitting electromagnetic wave when there is a completely unobstructed side distance path between the receiving end and the transmitting end. The so-called free space refers to an infinite space full of even and lossless medium, which is isotropic, with conductivity of 0 and average relative permittivity and relative permeability of 1. The hardware platform includes AT91 RM9200 development board, Siemens MC55 GPRS wireless communication module, and Linux host which is easy to develop and compile, while the method of building the software platform is embedded Linux as the experimental environment. The statistics of experimental results are based on Windows system and the third-party software. The experiment mainly includes the packet loss in the process of data transmission. Before data transmission, basic settings must be completed. The client or server structure mode is adopted in the communication. The ARM board is used as a client PC as the server, and the TCP protocol is used for data transmission. First, download the compiled program from the host computer to the development board and set the corresponding execution authority. Set the IP in the ping function to 211.129.11.102. The IP of analog front-end computer to 211.86.39.54 and the port number to 80801. The network topology between the experimental data centers is shown in Figure 4. After the unified simulation of the data deployment location, the unit data transmission cost of the link between data centers. In the above experimental environment and experimental settings, the experimental results of different methods are shown in Figure 5. Observing the results in Figure 5, it is shown that data transmission deployment and reliability analysis are carried out by using conventional methods 1 and 2, and packet loss rate is low, while data transmission, deployment, and reliability are carried out by using the designed method. No packet loss occurs, and the packet loss rate is 0%. Compared with different methods, the design of data transmission, deployment, and reliability analysis method is better than the conventional method. In the enterprise information construction, data transmission deployment is an important part. Its good or bad employment directly affects the completion of enterprise information and the subsequent development of the enterprise. It is of great significance for the development of the enterprise to use certain means to analyze the reliability of enterprise information construction and strictly control the quality of enterprise information construction. In view of the problem existing in the traditional methods, after the completion of the method design in this paper, a comparative experiment is designed to prove that the design method solves the problems existing in the traditional methods and provides some help for the enterprise information construction. In the future, the wireless network will deploy more than 10 times more wireless nodes than the existing stations within the coverage area of the macro station. The distance between stations will be kept within 10 meters and support 25,000 users in every 1 square kilometer. At the same time, the ratio of the number of active users and the number of stations may reach 1:1, that is, users and service nodes correspond 1 by 1. The densely deployed network shortens the distance between terminals and nodes, greatly improves the power and spectrum efficiency of the network, expands the network coverage, expands the system capacity, and enhances the flexibility of services in different access technologies and coverage levels. Although the super-dense, heterogeneous network architecture has a great development prospect in 5G, the reduction of the distance between nodes, the more dense network deployment will make the network topology more complex, which can be further studied in the future. Thank you.
Hello everyone, my name is Chen Xinyuan from Jiangxi Institute of Applied Science and Technology, is a full-time teacher. The topic of my thesis is Data Transmission Pattern Recognition Method of Communication Network with Terminal Constraint. In view of the problem of large recognition error and low accuracy of traditional pattern recognition methods, a new method of data transmission pattern recognition based on terminal band constraint is proposed. The transmission mode is analyzed. The coupling mechanism mutual inductance model is used to extract the characteristic parameters, and the Spark KNN fast pattern recognition algorithm is used to realize the communication network data transmission pattern recognition with terminal number band constraints. Design a control experiment compared with the traditional method analysis. The experimental results confirmed that the proposed method identification is more accurate. 1. Introduction. A large number of studies have shown that the support tree is the most basic and optimal topological structure of the communication network. The edge on the support tree represents the connection line between the communication devices. Generally, this connection can be represented by the amount of information in communication, but it can also be defined by the communication cost or time. Thus, the optimal communication line connection among the various alternative connections is equivalent to finding the minimum support tree topology of the communication network. Prim algorithm, classical algorithm, is an effective algorithm to solve these problems. However, in the actual communication network design, there are often some additional design requirements because each node represents different communication devices. The role in the network is different. Obviously, it represents the hub, the middle node of the multiplexer, because of the connection with multiple nodes. Both the sufficient hardware and software are more complex and much higher equipment cost than the terminal equipment of a single node. Therefore, before the design, the number of terminals is often clearly fixed. The design of the communication network topology can be attributed to the terminal node band constraint of the minimum tree problem. Is a difficult combination optimization problem. At present, there is no very effective algorithm to solve this problem, although when the problem is proposed, a heuristic algorithm is designed. Obviously, it is very meaningful to further study the effective algorithm to talk about the problem. As a new modern heuristic algorithm, genetic algorithm has been widely and successfully applied in many fields of science and technology. This paper will use the new technology of genetic algorithm to realize the pattern recognition of communication network data transmission. 2. Data transfer pattern recognition for terminal band constrained communication network. The frequency variation of the communication network data signal cannot be obtained by Fourier transforming the signal directly. This is mainly due to the time domain information of the signal is eliminated after the Fourier change maps the signal to the frequency domain. The signal spectrum reaction obtained by the transformation is the statistics of the energy of the signal at different frequencies without the time combination information of the signal. For disturbance signal, the information of the signal mainly exists in the combination of a certain energy of a signal and its time of occurrence. Therefore, a signal processing method is needed to show the signal frequency and time information in order to facilitate pattern recognition. 2.1 Transport mode analysis. Radio energy transmission technologies are classified according to the energy transmission mechanism and can be divided into the following 3 categories. First, electromagnetic radiation type of wireless power transmission technology. At present, this kind of technology usually uses laser energy transmission technology and microwave energy transmission technology to realize the long-distance transmission of small power. However, because of the strong transmission directionality of the technology, complex tracking and positioning systems are needed during operation, and there can be no obstacles in the transmission path. Obviously, the limitation of the technical is relatively large and the application is small. Second, electromagnetic induction wireless power transmission technology. This technology belongs to the electromagnetic field near-field coupled radio energy transmission technology, based on the law of electromagnetic induction. Through the original coil and secondary coil coupling electromagnetic field to achieve radio energy transmission. The electromagnetic induction wireless energy transmission technology can increase the transmission power and improve the transmission efficiency by adding high magnetic conductivity material to the air magnetic circuit. However, the effective transmission distance of this technology is limited, which is usually used in cases where the distance is less than 10 centimeters and the original and secondary coils are relatively fixed, and is generally suitable for charging and supplying power to small portable electronic devices or household appliances, etc. Third, magnetic resonance radio power transmission technology. Magnetic resonance wireless energy transmission technology also belongs to electromagnetic field near-field coupled radio energy transmission technology. It adds two resonant coils with high quality factor Q to the electromagnetic induction wireless power transmission technology. Through the resonant coils of these two high Q values, a higher intensity magnetic field can be generated in space, enabling the efficient transmission of electric energy at a further distance. The technology is characterized by no obvious directionality. The transmission distance is far more than the electromagnetic induction. The theory can achieve thousands of watts of power transmission at medium distance and can be transmitted through non-metallic materials. The impact on the human body and the surrounding environment is relatively small, more safe and reliable. 2.2 Feature parameter extraction. Feature extraction needed to select the appropriate network as the feature extraction network of the algorithm according to the actual needs. A feature extraction network common in faster RCNN algorithm is ZFnet, whose network structure is shown in the following figure. 3. Simulation experiment. In order to verify the validity of the communication network data transmission pattern recognition method, use traditional method 1 and traditional method 2 to compare with this method. A control experiment is proposed to obtain the test result. 3.1 Preparation process. Because the experiment needs to process a lot of data information, the requirements of the experimental platform are high, so the T330 model data processor is selected to complete the experiment. The specific parameters are as follows. 3.2 Interpretation of result. Specific control results are shown below. According to Figure 10, when the time passes 0.2 seconds, the error classification rate using traditional method 1 is 19%. The error classification rate using traditional method 2 is 16%, and the error classification rate using this method is 14.8%. It can be seen that the error classification rate using this method is the lowest, and its data transmission pattern recognition error is low. 4. Conclusion. In order to solve the problems of large error and low precision in data transmission pattern recognition of communication network, this paper possesses a method of data transmission pattern recognition based on the number of terminals with constraints. Using the mutual inductance model of the coupling mechanism to extract the characteristic parameters, and using Spark KNN fast pattern recognition calculation, the data transmission pattern recognition of the communication network with constraints on the number of terminals is realized. The recognition methods are high precision and small error, and can provide new ideas for research in related fields. Thank you very much.
Hello everyone, my name is Guangjing Pan. It is my great honor to speak here. Today I'm going to talk about OTDOA-based positioning in NB-IoT systems. We propose a deep learning way to estimate the position of the target. This is a joint work with my advisors. I come from Shanghai University in China. Our research group is named as GREAT. It means Group of Research and Education in AI and Telecommunication. This is a very young research team that has just been established for about 3 years. We welcome all of you to come to our school for academic exchanges. I will talk about our work from the following 4 aspects. First, I will introduce the background. Then I'll talk about the main work and the performance evaluation. And finally, I will give you the conclusion of our work. As we know, various types of smart terminals, such as self-driving cars, virtual reality, and wearable devices, and so on, they all have or will bring great changes to our daily lives and works. It is said that more than 40% IoT connections will be related to localization information by 2020. In addition, the requirement of localization accuracy becomes more challenging recently. For example, the shared bicycles, it may require positioning accuracy of 10 meters or even meters. Therefore, the positioning research is very important. The positioning technologies include LTE-based positioning, Wi-Fi-based positioning, Bluetooth-based positioning, UWB-based positioning, and so on. The LTE-based positioning has great potential because of its wide deployment and easy access, and NB-IoT-based positioning and LTE-based positioning methods are very similar. It has 3 main positioning methods defined in 3GPP, including GNSS, OTDOA, and ECID. However, the GNSS has poor performance in DOS, and ECID, which is based on cell identity, cannot meet the requirements of the positioning accuracy. So, OTDOA is very significant, and becomes the baseline technology in 5G. In NB-IoT system, OTDOA is also a very important technology. So, what is OTDOA? Look at the left figure. If we can get the time difference between the target and the two base stations, we can also obtain the distance difference between the target and the two base stations. And then we can get a hyperbolic. If we can draw more than 3 hyperbolics from the different base stations, and the position of the intersection point can be regarded as the UE's position. The right figure shows the positioning process. Base station regularly transmit position reference signal, and if UE can receive the reference signal, and it can calculate the time of flight. If UE can receive more than 3 base stations reference signal, we can calculate the reference signal time difference, and then we can calculate the position of the UE. Usually, the TOA estimated by phase or time domain clause creation, and the position can be calculated by GN algorithm. And we propose to use DNN to do position estimation. Then, let's talk about the mean work. First, I will introduce the problem analysis. This is a cellular network topology, and the UE can be positioned with the help of 1 serving base stations and more than 3 neighboring base stations. Just like this figure. The user equipment are around the intermediate base station and can be positioned with the help of these 7 base stations. We donate P and P sub I to be the position of the UE and the I base station. And the measured ISTD reference signal time difference can be calculated including 3 parts, which are the actual distance difference, measurement error, and the error caused by non-line of sight. And the position can be estimated by minimizing the overall square errors with the respect of to the observed ISTD results. And the H sub IP represents the distance difference between the target and the 2 base stations. Therefore, the position estimation problem is non-convex. Solving this optimization problem requires thousands of iterations, so the computational complexity is very high. Meanwhile, traditional algorithm cannot perform well. Look at the first figure. Non-line of sight is mainly caused by obstacles. In the non-line of sight scenario, TOA estimation will bring great errors, and even if only one base station's TOA measurement is in non-line of sight, the positioning estimation error will improve. This table indicates the result of our simulation test. We define the TOA in the non-line of sight scenario when the measurement error is greater than 0 TS. We can find that in some fading channels, such as EBA channel, a considerable of TOA can be regarded as the non-line of sight. Therefore, non-line of sight is one of the main causes of positioning error. In addition, we use 1.92 MHz sampling rate in our experiments. Low sampling rate will bring greater measurement error, and it is second changing of positioning. Researchers have shown that DNN can theoretically fit any function. The input of the DNN includes the delta D, which means normalized distance difference, X and Y, which represents the base station's position. We also use loss status S as input. It represents the measured time of arrival is line of sight or not. Some non-line of sight identification technologies has already performed well. We assume that the recognition result of non-line of sight is a priori information. And the D cell indicates the intercept distance. We set the output of the neural network is the UE space position, and we use MSE to be the loss function. Therefore, it is the regression problem. As for network structure, we use ReLU and linear to be the activation. Because we only use 5 fully connected layers, the computational complexity is very low, and the output shape of each layer are 18, 32, 16, 8, and 2 respectively. Then let's talk about the model generalization. In order to satisfy the different intercept distance to help the network be more robustness, we then analyze the input of the neural network. The base station position are constant in our experiment, so we just analyze the distance difference. And the first formula is the range of the distance difference. After sampling, the set of distance difference value can be represented as the second formula. And when the intercept distance is different, the CDF of normalized distance difference is shown in this figure. It is like sampling the input space of the neural network. Moreover, the large distance model can carry out a more fine-grained sampling. More fine-grained sampling of input means that the DNN can fit a more precise function after training. Therefore, it can generalize the model. Then, let's talk about the performance evaluation. In experiments, we use cross-correlation-based peak detection method to do TOA estimation, and then we calculate the ISTD according to the estimated TOA. And finally, we use the proposed scheme to do OTDOA-based positioning. We first tested the positioning accuracy of proposed algorithm when the number of base stations is different. Under the AWGN channel, all time of flight is line of sight. As shown in this figure, the more base stations involved in positioning, the higher the positioning accuracy will be. The proposed DN-based algorithm performs better than the GN algorithm. When we use 6 base stations to do a positioning, the positioning accuracy can be improved by about 40%. In these experiments, we tested the proposed model generalization method. As shown in the first figure, when the intercept distance of the training datasets is the same as the test datasets, DN performs better than the GN algorithm. It can achieve about 25% accuracy improvement. However, when the intercept distance of the training dataset is different from the test datasets, the performance of the DN algorithm is very poor. And in the right figure, we train the neural network by 10,000 meters dataset and test it by 500 and 750 meters data. When the intercept distance is 10,000 meters, the positioning accuracy of DN is improved by about 15%. The proposed model generalization method can effectively improve the robustness of the neural network. In this experiment, we test our algorithm on the channel with a rich non-line of sight scenario. In this figure, we can find that the positioning accuracy can be greatly improved by about 67% and 50% if compared with GN algorithm and DN algorithm without loss status input respectively. This figure indicates that the proposed DN algorithm with loss status can effectively improve the positioning accuracy under the underlying non-line sight scenario. Finally, I will give the conclusion. First, we propose the DN-based positioning estimation scheme. Experiments show that when more base stations are involved in positioning, the positioning accuracy will be improved. Second, we proposed a module generation method, which trains the DN by the large intersect distance data sets to generalize the networks, and the generalization method can effectively improve the robustness of the localization algorithm. Finally, experiments show the proposed algorithm can improve position accuracy by about 15% in line of sight scenario and 67% in non-line of sight scenario, compared with the GN algorithm. That's all. Thank you.
Hello everyone, my name is Yubin Yan. The topic is Design of Distance Learning Process Monitoring System based on the 5th-generation communication network. The first, introduction. The 5th-generation mobile network is the same as the 2nd-generation, 3rd-generation, and 4th-generation mobile networks. The 5th-generation network is a digital cellular network. In this kind of network, the service areas covered by suppliers are divided into many small geographic areas called cellular. Analog signals representing sound and image are digitalized in mobile phones, converted by analog to digital converters and transmitted as bit streams. The main advantage of the 5th-generation network is that the data transmission rate is much higher than the previous cellular network. The 5th-generation's performance objectives are high data rate, reduced latency, energy saving, cost reduction, increased system capacity, and large-scale device connectivity. The first phase of the 5th-generation specification in Release 15 was to accommodate early commercial deployments. The monitoring system of distance learning process is designed by the 5th-generation communication network. The second, system design analysis. In distance learning, if the whole process of teaching is controlled by students, only a few learners with rich knowledge and experience can achieve good learning results. For most learners, self-control of learning pace, the number and difficulty of exercise often lead to disappointing results. So if the initiative of control is transferred from computer to learners, the interaction control will be unbalanced, which will eventually lead to the disappearance of real interaction. Therefore, learning monitoring mechanisms should be introduced in the design of network courses to seek a balance between learners, and computers, and give full play to the teaching interaction function of network resources to maximize learning. Psychological research shows that learning process self-control can be divided into two categories: monitoring component and control component. The former is the conscious evolution of learning state being experienced, while the latter is the domination and domination of their own learning process. Learning control is based on monitoring consciously, choosing learning methods, and actively adjusting learning process. In distance learning, the monitoring and control of learning process interact, and both are in dynamic process. Designed by us introduces the monitoring, feedback, evolution, and interaction mechanism designed by human, and had the functions of recording learners' learning situation, timely feedback, learning effect, and a perfect communication mechanism. The system involves the following core issues. First, establish a perfect learning behavior database. Track the learning process of learners and collect the data related to learning behavior in this process. Whether the data collection is complete, correct, and effective affects the effectiveness of monitoring and evolution to a great extent. Therefore, behavior data collection must ensure the comprehensiveness and accuracy of data collection. The second is to use a stable technical route to scientifically collect, sort, extract, process, and analyze the data in a learning behavior database, and provide a visual operation interface to realize the real-time statistical analysis of students' online learning behavior. The third is to find out the relationship between learning behavior and learning effect according to the collected historical data of learning behavior and learning achievements that students have achieved, and to carry out formative assessment on learners to achieve personalized learning support services. In the design process of learning behavior monitoring system, monitoring the learning behavior of learners is a core, so we should make clear which learning behaviors of students should be monitored, whether the behaviors are effective, whether they have an impact on the learning results of students, and the results of these learning behaviors should be quantifiable and measurable, and consider how to collect these learning behaviors, what technical route be adopted, and whether the acquired behaviors are real and effective. After obtaining this behavior data, statistical analysis should be carried out through in-depth analysis and monitoring of online learning behavior data. Find out the internal relationship between online learning behavior and learning effective, and realize the formative assessment of distant learners. This fundamentally solves the problem that teachers evaluate students by subjective experience in a network teaching environment, so as to truly evaluate students objectively, fairly, and fairly. This system starts from the monitoring of learning behavior to monitor learning behavior, but monitoring and evolution are inseparable. So, monitoring and evolution work together to promote learners' learning. The third, system function testing. In order to verify the performance of the above system, a control experiment is proposed to simulate the running process of the designed system to gather test results. a long-distance learning process monitoring system and conventional monitoring system under the 5th generation communication network are respectively connected with the experimental acquisition device, which are the experimental group and the control group. After each experimental monitoring operation, the equipment is allowed to stand for 2 minutes to ensure the reliability of the test results. 7 connection ports of the offshore access network are selected for 4 experiments, and the following data results are obtained. The first, hardware design of remote learning process monitoring system. With the support of the above hardware structure, the software part of the remote learning process monitoring system is designed by using the 5th generation communication network. In order to ensure the security of the system and the consistency of the data storage layer is used to monitor the storage of the data, and the related data of the fault point is transferred to the processing layer. The monitoring results are ducted with the data of other parts through the ducting layer, as follows. With the support of the above system architecture, the 5th generation communication network is applied to the monitoring system. Processing the monitoring signal through each hidden layer, transmitted to the output layer, will not reach the expected value of the output value of the reverse transmission. After output value is ineffective or close to the expected value, the output of the monitoring signal is realized. The derivative value of the area of the output layer and the median area with respect to the weight is different, and the calculation process of the derivative value of the area of the output layer with respect to the weight is as follows. Through the above calculation, the area between the expected value and the output value can be obtained, and the relationship between the learning step and a convergence rate can be found. So far, the processing optimization of monitoring signal based on the 5th generation communication network is complete, and the system function model is designed on this base. The system had the following function modules. Course learning brings the learning course content according to the chapter directory of the course. The system sets record points based on sections. After each section, the learner selects complete learning to record the learning time, learning paths, and other information. Class notes. This module is similar to the learning notes in traditional classroom learning. Learners can sort out and record the key points and difficulties in the learning process at any time. Learning resource information related to knowledge points or understanding of a knowledge point, etc. The system stores the learning note information in the database one by one, and each record is associated with a corresponding chapter, which is convenient for the learners to consult later. Course interaction. Provide a public discussion area for all learners to discuss topics related to course content, express problems or opinions, such as different understanding of a difficult knowledge point or the application of learning methods and learning strategies of the course. Online exam. After learning a certain chapter, learners can take an online test to test their learning effect. The online test module supports the online test of learners. After submitting the test paper, the system can automatically score, give the test results, and record the results of each test. The specific situation of its function module is as follows. After logging in as a teacher, there are two functional modules, information management and user management. The management modules of information management are as follows. Chapter management. This module realizes the organization, editing, and modification of online course content by teachers. The content of online courses is pre-selected by teachers. After logging in the system, online editing is carried out based on chapters or selections to add, delete, or modify the text and picture content of courses. Course introduction. It is used to describe relevant information of the online course, such as the introduction of course content, relevant teaching materials, teachers and learning methods. Class notes. Teacher can view learners' learning notes. Learners can find and display the information recorded in the Learning Notes module here. Input the student number of the learner to be viewed. Then the information of the learner's learning notes can be displayed in the form of a directory, with the title and time of each learning note written by the learner at the directory order. Any specific learning note content can be viewed. By checking the learning notes, the teacher can get a general understanding of the learner's understanding of the course content and some questions in the learning process, so as to give appropriate guidance and help. To some extent, the content and time record of learning notes reflect the learner's emotion, attitude, method, and other information of learning the course, which is also reference for teachers to master the learner's learning situation. Course interaction. Teachers can check the opinions expressed by learners here. By looking at the topics discussed between learners, teachers can understand the overall mastery of the course content and find out the problems, such as which questions are common problems which need to be guided as a whole, which questions are the problem of individual learners, which need to be guided individually, etc. Similarly, this module provides a reference for teachers to understand the learner's feelings, attitudes, methods, and other information of learning course. Online exam. This module supports teachers to organize online examination questions, check the examination situation of learners, etc. The test results of learners after learning a chapter are the important base for the teachers to master the learning effect of learners. Teachers can edit the test questions of each chapter online, check the test situation of learners, adjust the difficulty of the test questions in time according to the test results, so as to obtain better learning effect. Thank you.
Design of early warning system for reservoir flood level based on probability analysis. Reporter Zhang Wenbin. The whole paper can be divided into 5 parts: introduction, hardware composition, software design, system test experiment, concluding remarks. The first part, introduction. In recent years, large floods have occurred in many river basins in China, which have caused great losses to the national economy and people's life and property. How to use the latest science and technology to control the loss brought by flood to the minimum is of great practical significance. The key to flood control is to grasp the dynamic states of flood accurately and in real time. Zhang Yangke puts forward the dynamic control method of reservoir operation water level in the dynamic flood prediction period. Firstly, considering that the reserved flood control capacity for the downstream reservoir has the space of overlapping use, the operation water level in the flood period is optimized. Secondly, the model is established by using the prediction and the pre-discharged method to calculate the upper limit value of the dynamic control area of the operation water level in the flood period. Finally, the dynamic change in the flood prediction period is mainly considered. Solve the dynamic control domain based on risk analysis. However, the accuracy of this method for water level early warning is low in the case of severe weather. In view of the problems of the above system, this paper proposes and designs a reservoir flood level early warning system based on probability analysis. The second part, hardware composition. The first point, TC401. The system adopts the inductive digital water sensor as the water level data acquisition equipment. TC401 capacitive digital water level sensor is a kind of inductive elements, which uses neural network circuit and mechanic method to locate accurately. The water level signal is processed by digital coding. The design idea of neural network circuit is adopted, and the position inductive element is precisely determined by the method of shorthand charging of electrode plate. It has high reliability and anti-interference performance. It is the same kind of sensor in the market at present, and its technical content is also at the leading level. It is a new concept of water level sensor. The second point, DX130. DX130 adopts the design principle of hydrostatistics with the range of 200 meters, the output voltage range of two-wire system of 0 to 5 voltage, and the runtime stability of 4 degree and 0 position of 0.1% Fs per year. When the sensor is put into a certain depth of the measured liquid, the pressure formula for the sensor's liquid surface is as follows. The third point, water level signal conditioning circuit. Because the pressure sensor works in a low range, in order to improve the measurement accuracy, it is necessary to amplify the output voltage signal of the pressure sensor before analog to digital conversion. AD620 is a low-cost, high-precision instrument amplifier. It only needs an external resistance to set the gain. The gain range is 1 to 10,000, and the power consumption is low. The maximum working current is only 1.3. The system sets the gain G equal to 5. The 6-pin output of AD620 is directly connected with the ADC of the controller. The signal conditioning circuit is shown in Figure 1. The output voltage signal of the pressure sensor is connected to the controller through AD620 amplifier for ADC conversion, which improves the accuracy of water level measurement and meets the needs of the system. The third part, software design. The first point, database design. Under the unified data format and specification, the database is divided into basic information database and geographic information database according to the data storage model. Oracle 10G is used as database management platform. The basic information database is divided into flat database and algorithm database from the content. Flat database mainly stores data of reservoir, including 1. Historic hydrologic, socio-economic and flood loss data, etc. 2. Real-time rainfall and water regime data, including rainfall data of meteorologic station, rainfall forecast data, and real-time water level and flow data of hydrologic station. 3. Model boundary, parameters, etc. Those data can be automatically or manually modified to store new data. The design of database mainly serves for the probability analysis of flood. The observation series of annual flood frequency is calculated by probability analysis method, and the expression is as follows. For different statistic intervals, if there are different series, different analysis conclusions can be obtained. For different flood peak standards, if there are different flood frequency series, different flood frequency analysis conclusion can be obtained. The analysis steps are as follows. Step 1. According to a certain peak discharge value Qm, construct the annual flood frequency series. Step 2. According to 10 times, 1 time per year, the number of years of K floods is a series. Step 3. According to Formula 4, according to corresponding values of elements and of sequence, construct statistic and carry out the goodness of fit test at a given significance level. Step 4. If series conforms to Poisson distribution, calculate the probability of floods per year according to Formula 5, and then get the number, range, and the probability of possible floods per year. The second point, water level flow information setting. The water level and flow information setting module defines the maximum, minimum, and relative change rate of water level and flow, compares the water level information monitored by the sensor with the warning light, and determines whether the water level of reservoir is in a safe condition through the control chart, so as to determine whether to alarm. Among them, RS485 communication is mainly used to complete information collection and communication. The third point, water level warning. Water level early warning control indicators include water level limit control and water level change rate, as shown in Figure 2. The water level limit control chart is an effective tool for analyzing and judging the process fluctuation, which can monitor the water level data in real time. Generally, in the early stage of my design, the upper and lower water level control limits are specified, and the historic data are continuously revised. Once the water level exceeds the limit of the control chart, the alarm indicates that the water level exceeds the safety state. The monitoring of the relative change rate of water level is based on the historic data to calculate the maximum change rate of water level in the mine, and take as the reference to calculate the relative change rate of water level in unit time. The fourth part, system test experiment. In order to verify the performance of this system, a comparative experiment with the traditional one is designed. Through comparison, the hypothesis of the experiment is verified. The experimental environment is shown in Table 1. The first point, experimental comparative analysis. The experimental in this section will judge the advantage and the disadvantages of the two systems by comparing the stability of the two systems. The experimental method is comparative experiment. The experiment verification process is completed under the control of other variables except the experimental variation. The second point, experimental result. Two systems are used to test the water level change of 7 rivers. 7 monitoring points are set up respectively. The server of the monitoring center is always in operation state, waiting for TCP or IP connection and communication of the water level terminal. After the water level terminal is connected with the server of the monitoring center, the green communication indicators flashes. See Table 2 and Table 3 for water level monitoring data. From the contents of Table 2 and Table 3, it can be seen that under the operation of the early warning system in this paper, the water level of the 7 monitored river is within the preset safety range. That is, there is no drought or flood, nor rapid change, but the water level fluctuates slightly, and in the 7 monitoring points, the output voltage of the conditioning circuit and the water level height show a basic linear relationship. Compared with the traditional early warning system, its early warning results are more accurately, and the output voltage is more stable. In order to further verify the early warning accuracy of this system, the early warning accuracy of this system and the traditional system is compared and analyzed. And the comparison results are shown in Figure 3. According to Figure 3, the accuracy of this system is within 45% to 80%, up to 80%, while the accuracy of traditional system is within 25%, up to 25%, indicating that the accuracy of this system is higher than that of traditional system. The fifth part, concluding remarks. In this paper, a reservoir flood level early warning system based on probability analysis is designed through the contrast experiment with the traditional reservoir flood early warning system. It is proved that the system designed in this paper can ensure a higher early warning accuracy and has better stability. Abstract. Aiming at the problem of low sensitivity in the traditional measurement method of enterprise information asymmetry degree, a probabilistic analysis based on measurement method of enterprise information asymmetry degree is designed. By analyzing the causes and the countermeasures of asymmetric information of enterprises, the proxy variables are determined. The coherence of proxy variables is calculated by probability analysis, and the cost of adverse selection of enterprises is decomposed by covariation decomposition method, which is combined with the coherence of proxy variables to calculate the degree of asymmetric information of enterprises. The experimental results show that compared with the traditional measurement method, the method based on probability analysis is more sensitive and suitable for practical projects. That's all my presentation. Thank you.
Hello everyone, my name is Liu Xiaolin from Jiangxi Institute of Applied Science and Technology. As a full-time teacher, the topic of my thesis is Design of Education Management System based on Wireless Self-Organizing Network. In view of the current imperfect construction of education management system in most colleges and universities, the design of education management system based on wireless self-organizing network architecture is proposed. On the basis of the organizing hardware structure, human-computer interaction design is added. S3C2440 processing chip and EPCS16SI16N storage chip are selected to ensure the normal operation of the system. Data transmission bandwidth is reasonably allocated, and the wireless self-organizing network is used to optimize the logging interface to realize the design of education management system based on the wireless self-organized network architecture. The test results show that the original system cannot meet the needs of users for knowledge computation and text management, and the design system improves this defect, and its performance is obviously better than the original system. Introduction. The traditional wireless cellular communication network needs the support of fixed network equipment, such as base station for data forwarding and user service control. However, wireless and Hawk network does not need the support of fixed equipment. Each node, i.e. the user terminal, organizes its own network. When communicating, other user nodes forward the data. This kind of network breaks through the geographic limitations of the traditional wireless cellular network and can be deployed more quickly, conveniently, and efficiently. It is suitable for more urgent communication needs, such as the battlefield individual communication system. In reference, aiming at the problem of resources optimization in self-organized, heterogeneous network, considering the energy efficiency and the stability of network connections, a scheme of educational resources allocation is proposed. The channel is included into the available channel spectrum pool, and the stability of network connection is guaranteed by the education user selection machine basis of more potential energy. In order to improve the energy efficiency of the network, the power is allocated to the education users. In the selection process, the users are ranked according to the most potential energy value, and the users with lower potential energy value are preferred to provide service. The results show that the proposed scheme can save the data transmission power loss of education platform, ensure the stability of network connection, and optimizing the energy efficiency. Reference, design, and build a wireless self-organizing network education management test platform system by developing the underlying network card drive and routing algorithm. Protector module ordinary PC becomes an independent self-organizing network terminal. At the same time, through monitoring statistics of data transmission between multiple education terminals to obtain the measured performance indicators of the network. At present, the platform has implemented the test support for a variety of routing algorithm protectors. Transport mode analysis. Radio energy transmission technologies are classified according to the energy transmission machine and can be divided into the following three categories. First, electromagnetic radiation type of wireless power transmission technology. At present, this kind of technology usually uses laser energy transmission technology and microwave energy transmission technology to realize the long-distance transmission of small power. However, because of the strong transmission directionality of the technology, complex stacking and positioning systems are needed during operation, and there can be no obstacles in the transmission path. Obviously, the limitation of the technique is relatively large and application is small. Second, electromagnetic induction wireless power transmission technology. Hardware design or education management system based on wireless self-organizing network architecture. Design of human-computer interface. Through the human-computer interface, the communication between users and the system can be realized, and different operations can be performed. In the education management, the form of touch screen is used to select the input of the selected information according to the coordinate position of touch screen or press touch screen. Use touch human-computer interaction function in education management system makes management more convenient and visible. The individual LCD LQ104 VLDG52 is used to realize the display function, which has advantages of high resolutions and high data transmission speed. Its LCD driver modular memory uses programmable CPLD chip to realize the function of data bus and address bus in data exchange between LCD and driver module, so as to ensure high speed and reliable data transmission. In the driver module, the RAM chip is used to realize the data buffer function in the process of data transmission, so as to prevent the data loss of education management data in the process of transmission. Data processing chip selection. The S3C2440 processor produced by Samsung company based on ARM920T process core has 5-level pipeline and hardware structure and its main frequency research 400 MHz. It is a 32-bit microcontroller with high-cost performance for communication field and system control, which has the following characteristics. The standard work frequency is 400 MHz and the operation rate reaches 415 MPS. Built-in memory management unit and instruction data cache space. On-chip oscillator with 2 PLLs. The chip contains two 16-bit TIMI converters with 3 channels, 170 external common LO and 24 external input sources. External bus interface (EBI) supports SDRAM, NOR flash, and NAND flash. Integrated LCD controller support 16:4K color TFT and a DMA channel dedicated to memory refresh. 4 universal synchronous different step serial chain series USART serial pairing interface SPI. Set host supports 1.1 Multimedia. Pro Technical supports 10 or 100 M Ethernet interface according to their own needs. Users can choose the hardware device suitable for the characteristic of the core plate and the button plate for welding. The physical figure for core board is shown in Figure 3. circuit design. Due to the power supply for some processing devices, many devices are sensitive to mutation and raise aging and other variables, so the burn rate should be as small as possible. The load mutation should be as stable as possible. The heating should be as small as possible. The value should be as small as possible, and the protection function should be complete. As shown in Figure 4, 3.3V voltage is used, while 5V voltage is generally provided. Here, a power adapter is used to convert 220V alternating current into 12V DC voltage. 12V voltage is converted into 5V voltage through IM2596S 5V chip, and then 5V voltage is connected to IM10851 3.3 chip to reduce voltage to 3.3V. Software design or education management system based on wireless self-organizing network architecture. Distribution or data transmission bandwidths. In the application process or education management system, there are many people online at the same time. In order to ensure the normal operation of the system, determine the priority of the transmission rate, and allocate the network bandwidth resources to the appropriate users. Design of logic interface based on wireless self-organizing network architecture. The functions of wireless and hawk network management included performance management, fault designers, service discovery, and category discovery. If we adopt the network management model based on policy and agent, the above network management functions are driven by policy. Performance connection can be active or passive, such as event resemblance, on-demand request, etc. The performance analyzer is responsible for processing the basic performance data obtained by the performance collector, and the performance monitoring agent monitors the network nodes through the performance database and the performance event schedule. The fault agent schedule is responsible for generating, releasing the destroying the fault detection agent and fault diagnosis agent. Service discovery memory includes service registration and service query. Topology discovery memory includes topology report, topology collection, topology teaming. Example, it is applied to the application design of logic interface as follows. The education management subsystems will need to include all links and processes of teaching activities, and its management scope also include management organization, administration part, teaching management, personnel and teachers, students or other teaching resources, and courseware library. Example, a good education management system can create a good learning environment and a presentable and intelligent learning atmosphere for students. So a good education management subsystem should include the following functions. 1. Student registration. Provide student registration status to facilitate the management of students in the later stage, and ensures access rights of students and access rights of students to teaching resources and courseware library. 2. Student status management. This function is memory for the management of personal information, grades, courses, selections, examination, graduation, and other aspects of students to ensure the integrity and timelines of student status. 3. Course management. Its memory includes the establishment and adjustment of major setting, discipline and training plan, and at the same time, it is necessary to ensure the access of visitors within the allowed range, including the courses selection of students. Example: management of teaching managers and teachers. To ensure the management of information about teaching manager and teachers, qualification of teaching manager and teachers, assessment and teach of teaching manager and teachers. 5. Payment function includes the complete realization of the functions of examination, inquiry, and statistic of students' tuition fees and exam fees. 6. Administration document management function. It is convenient for teaching units to realize documents related to teaching, including country adjustments, course adjustments, examination information, and other functions. So it is also necessary to ensure that this information can be modified and encoded. 7. System setting and maintenance function. Memory realize the maintenance of the security and stability of the whole system, as well as the backup of relevant data and important data information, the integrity and consistency of data and important data. User authorization and authentication is an important part of the system, which plays a key role in the security of the whole system. 13. We set the browsing mode as a mode, and any user with authority can log into the system. The user needs to enter the username and password, and the user authorization and authentication module will review and authenticate the user's qualification to check and determine whether the user is a legal user. If the authentication is passed, the user group or the user should be found according to the username to determine the permission of the user and operation that can be performed, and then return to the corresponding page to display the accessing permission of the user in order to ensure the realization of the system security requirements. The password and user authority values are transmitted in an encrypted way. For management system function test, in order to evaluate the effectiveness of the education management system based on widely self-organizing network architecture, design experiments test the best function of each module of the system, whether it can achieve the design requirements smoothly, and compare the results with the original system. Complete the experiment testing process. In order to meet the needs of the experiment, the hardware environment of the test needs to use Intel HD 4000 or above graphics card, Intel-Core i3 2.5 GHz or above processor, use more than 4 GB memory, and the hard disk space is at least 20 GB or above. The software environment should at least meet the requirement of Windows 7 or 8 or 10, 64-bit or Mac OS X 0, and the browser version above IE 6.3 should be used. Analysis of test results. The designed system management test results obtained by Pingdong Tours simulation are compared with the management test results of the original system, as shown in the following figure, in order to ensure the preciseness or reliability of the test. Several simulations have been completed during the test through the above testers. It can be found that the original system can meet users' needs in service management, teaching material management, scorecard management, online classroom management, course selection management, video playback management, and system authority management, but in knowledge competition management and test if the test results of these two items are blank. It indicated that the original system has problems in these two items and cannot meet the current user needs. The design management system makes up for this defect and improves the requirement of knowledge competition management and test management. It can be seen that the designed application management system based on wireless self-organized network architecture can efficiently improve some deficiency of the original system and make the application management work more convenient and efficient. Conclusion. In view of problems of low efficiency and imperfect interaction in the construction of educational administration management system in most universities, this paper provides an account of educational administration management system based on wireless self-organized network structure. Based on the original hardware structure, human-computer interaction design is added, reasonable allocating of data transmission bandwidth, and use of wireless self-organized network to optimize the login interface. Realize the design of the educational administration management system based on wireless self-organized network architecture. It has been proved that application of wireless self-organized network in the education administration management system of colleges and universities can optimize the performance of the system and contribute to the educational administration management of colleges and universities. That's all. Thank you.
Hello everyone, I'm Yan Huibai, come from School of Mathematics and Computer Science of Chifeng University in China. Today my topic is about design of encryption and decryption system of heterogeneous database based on data mining. First, let's give me the introduction. Database system is the most extensive and important carrier of data in network area. Data security derives from database system security and becomes one of the basic supporting technologies in the future based on cloud computing. At present, all kinds of data stealing supported by groups or countries are more and more frequent. At the same time, data stealing behavior from internal personnel is also one of the main threats. Such unauthorized access to user access often leads to data information disclosure, user identity disclosure, and authorized card number loss, which may cause a lot of economic losses, but may cause sensitive information or contains serious consequences or disclose of confidential information. The security of database system is related to whether the data involved in the database system is acquired by authorized user. Although the process of database intrusion is quite different, the consequences are the same, all of which are to obtain the information to database state in the unauthorized state, which lead to serious consequences. At the same time, it also results from the abuse of the rights granted to users, the rights granted by misoperation, and the malicious intrusion or not granting the right to steal, tamper, and delete data. In order to ensure the information security of database, Heterogeneous database is designed on the basis of traditional database. Heterogeneous database is a collection of related databases which can realize the data sharing and transparent access while improving the autonomy of database system and realizing data sharing. Each database system still has its own application characteristics, integrity control, and security control. Through the process of encryption and decrypting the internal data of database, the information security of the database is granted. In the process of using the original heterogeneous database encryption and decryption system, the problem of high error rate of data information often occurs. Therefore, this paper uses data mining technology to optimize the original system. The second part is about hardware design of heterogeneous database encryption and decryption system based on data mining. In view of the problems in the use of original system, the hardware design of the system only needs to complete the data acquisition and store process. In order to improve the data process ability of database encryption and decryption system, the hardware part of this paper is introduced into the original system hardware in order to ensure the normal operation of the system designed in the application paper. The new hardware architecture is set as follows. According to the above hardware architecture, complete the hardware design. In view of the problems in the use of the original system, the information collector of four-core processor is selected as the main part of the hardware design. The specific design process of the equipment is as follows. The first one, data acquisition equipment. In this design, high-precision data acquisition chip is used to complete the collection of data information in the database. The internal chip of data acquisition equipment is CWDS 6952-6952. The chip is introduced by T1 company and has the characteristics of multifunctional, multi-time-delay application. The collection has 8 parallel processors, 5 data multiplexing interfaces, and 3 multi-form data interfaces, which is convenient for collection, compression, and transportation. The data collection is automatically connected with the hardware network of the system. After data acquisition and synthesis, it is transmitted to the hardware data terminal of system, stored in the terminal, and recorded in the hard disk. When data acquisition equipment collects data information, SCLK is used as clock to record all data signals. The internal VPO configuration mode of the collector is route mode, and the input data as the basic of data encryption. In this design, the data collector is connected with PCI and HPI. The bus interface is Ethernet interface. The data path is connected with B3 and B19 by PCI bus, and the data transceiver can receive and transmit 10 to 100 m physical layer data. In order to realize the simultaneous processing and encryption of various database data, AP695 chip is added in system. The uplink rate is 3.5 Mbit per second, and the downlink rate is 6.7 million bits per second. In order to ensure the stable operation of the above chips in the system hardware, the optimization of the computer using the chips is carried out. The authorized host parameters are set as follows. This is the table about computer parameter setting after optimization. The optimized host is connected to other hardware devices as the hardware foundation of the system. The second part is data storage device. In order to improve the storage efficiency of memory, a flash memory with large storage range and low manufacturing cost is selected in this paper. An intelligent chip is added to the memory, which greatly increases the storage capacity and reduces the occupied area. The memory design results are shown in the picture below. There are 6 buses outside the memory. Each bus is connected to an FPGA interface, and different interfaces connected different signals. Bus 1 connects signals in I/O mode, which link bit width of 52, and inputs and outputs in a two-way manner to realize two-way data transmission. The remark method is I/O. The bus 2 connects signals in the out mode with a link bit width of 18.4. It outputs data in an unidirectional manner and controls the data in and out of the database. The bus 3 connects data in BSC mode with a link bit width of 16 and outputs partial data information in an unidirectional manner. Bus 4 is connected to the database by class. The link bit width is 6, and the data is input in one way to realize signal selection. The data input method of different types of database is different. Bus 5 is connected to the database in the BUSY mode with a link bit width of 18.1, and a variety of data input methods are used for input. The bus 6 connects signals in the ADD mode. The link bit width is 27, and the address signal is output in an unidirectional manner. The 3 part is the system data transmission equipment. Serial support is the abbreviation of serial interface. In the process of data transmission, serial bit by bit transmission is adopted. The 9-pin COM port on the computer is the serious communication interface. According to the different communication modes, it can be divided into synchronous serious communication and asynchronous serious communication. In serious communication, the time interval between each bit in a signal frame is fixed, while the time interval between adjacent frames is not. The following 4 bits constitute a frame of asynchronous serious communication: start bit, date bit, check bit, and stop bit. The maximum byte rate of asynchronous serious communication is 115, 100, and 200 bits. In the original series port selection, although the date rate of the selected date series port is relatively fast, its bit error rate is relatively high compared with other data transmission methods, and the transmission line is simple. Therefore, in this design, multi-serial port is used to realize the two-way communication of the system. In this design, RS-232 9-pin serial port transmission line, commonly used in embedded equipment, is used to realize data transmission. The serial port is simple in structure, convenient in use, and effectively improves the security and integrity of data transmission. The specific data transmission lines and equipment settings are as follows. In the figure above, the 3011L high positioning and orientation GPS compass of Magellan Navigation and Positioning Company of the United States selected by the system in this paper is shown. It uses the series port for data transmission, has two RS-232 CBD9 interfaces, and supports the transmission baud rate of blah, 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 blah. The above design hardware is used in the original system hardware framework to complete the hardware design processing. In the subsequent software model design, the hardware framework will be the basis of the function realization of the software model. The first part is about the software design of a heterogeneous database encryption and decryption system based on data mining. In view of the problem that the error rate of the original system is too high in the process of database encryption and decryption, the encryption dictionary model and data information process model are added to the system function model to ensure the data integrated in the process of data encryption and decryption, and avoid the generation of error rate. The optimized software models are as shown on the right. According to the above framework, data mining technology is used to optimize the shortcomings of the original system, and the hardware designed in this paper is used to achieve the performance of the optimized model to ensure the realization of the encryption and decryption function of the system. 1. Site database encryption dictionary. In this design, heterogeneous database is used to design encryption and decryption system. Heterogeneous database is a collection system of multi-structured databases. When encrypting this kind of database, it is necessary to set the corresponding database user authority table to control the users who can encrypt and decrypt the database. The user authority table is established and maintained by the central authority of the database, which specifies the safe operation authority of each user class to each data class in detail. Table 2 is the user permission table of 4 user classes to 3 data classes, in which the field UCID is the user class ID. D is the user class's access right to the ith data class. 3 is full control. 2 is read and write. 1 is read only. 0 is no access. E is the number of the key exports and the ith state, and the system exports this kind of data according to the user's class key, and the key of a certain kind of data remark records some information about the user's permission. The data in Table 2 shows that user class 1 is a super user and has full control over all 3 types of data. User class 2 has permissions on all 3 types of data respectively: full control, read and write, and read only. User class 3 has only read permissions on all 3 types of data. User class 4 can read the third type of data and has no permission to access other data, as shown in Table 2. Those above mentioned user encryption and decryption permission setting, the design process of heterogeneous database encryption dictionary is completed. The encryption dictionary is also a table, which stores the type, size, encryption, and other information of each field in the data table. Through the dictionary, you can send the identity of the security data class to which the user access field belongs, and then you can send the number of key experts to export the access data class in the user permission table according to the identity. Use this encryption dictionary for effective control. 2. Heterogeneous database information processing based on data mining. Through the above processing, set the database encryption and decryption permission process. In this design, the encryption and decryption of heterogeneous database will be set. The data in heterogeneous database is too complex. In order to reduce the operation difficulty of database encryption and decryption process, data mining technology is used to pre-processing the internal data of database. The specific pre-treatment process is as follows. In this design, we use the classified data mining method in data mining technology to complete the data pre-processing process in heterogeneous database. Firstly, the internal data of the database is formed into training site to select the classification features. According to the selected classification features, the training dataset is changed to form a classifier of heterogeneous database. Then, the classifier is used to classify the sample data of the classification database to be carried out. And finally, the classification mining is completed. The whole process is divided into two stages: building the classification data mining model and using the classification data mining model to predict the target dataset. Use the data after classification mining using Gaussian filtering and other methods to complete the processing process. The specific data pre-processing process can be summarized as follows: data collection, data classification mining, data cleaning, data filtering, and data composition. Through the above process, the generation of error rate in data processing is reduced, and the integrity of encrypted database content is ensured. 3. Building data encryption and decryption model. The database content after pre-processing is transformed into plain text, which is input into the encryption and decryption model. In the encryption model, there are three algorithms include the encryption model, which will work with other models. The SQS statement rewriting model will extract the plain text value involved in the database operation statement and pass it to the encryption and decryption model as input. The encryption and the decryption model will determine the encryption model to be used according to the corresponding column, record location, and operation in the current statement of plain text value in the database. If the working key needs to be generated in this process, the key management module will be called. If necessary, get the existed key, then call the metadata management module to read the key from the database. In the process of data pre-processing, data mining technology is used to complete the classification of data. Therefore, homomorphic encryption algorithm is used in this encryption model to complete the encryption and decryption data of database. Set the whole homomorphic encryption process to A. The no homomorphic encryption process consists of key generation, data encryption, decryption, and data evaluation. Set generation key to key, encryption process set to B, decryption process set to C. The evaluation process is D. Then the formulation can be expressed as follows. Suppose the public key MK and the private key NK jointly generated the corresponding data security parameters. Set to O. Use MK for encrypting plain text. NK used to decrypt crypttext. Set plain text K north in, where N is a positive number. Then Kn is the size of integer. Homomorphic encryption expressed as A. Then the formula can be expressed as follows. At the same time, the data decryption process is set after the data is encrypted. set date decryption process to C. Decrypt the cipher text U through the private key, which can be expressed by the formula as follows. Finally, the evaluation of the decryption results completes the calculation process of homogeneous encryption. Suppose T is the evaluation function, and the cipher text is set to R. The evaluation algorithm evaluates the cipher text E by evaluating the key Y evaluation function T. Through the above formula to complete the encryption and decryption process of database, to ensure the security of heterogeneous database state. Through the hardware part and software model part of the design of heterogeneous database encryption and decryption system based on data mining is completed. The fourth part is experimental demonstration and analysis. Combined with the above hard work design results the software module design. The design of heterogeneous database encryption and decryption system based on data mining is completed. In order to ensure the effectiveness of the design, the performance of differences between the original encryption and decryption system and the encryption and decryption system designed in this paper are compared by using the test link of the construction system, one system test platform. The hardware facilities of encryption and decryption system test of heterogeneous database based on data mining include server and other computer equipment. A system server which is specifically configured as CentOS version 6.5 64-bit operating system, high configuration processor, 16G memory, 40 hard disk. Other computer equipment borrows computers from the existing network platform of a unit. The system server configs the running environment and the database environment required by the system, installs MySQL database, and opens the database security audit function. The development environment and the language are Java and MySQL 5.6, and the development tool is Edo. Using the above platform, the system test is completed, and the performance difference between the original system and the designed system is obtained. In order to ensure the validity of the system test results, set system test samples to provide databases for system test. Specific system test samples are shown in the table below. This is the table of test sample dates. Using the above test sample dates, using the original system and the designed system to process the above date to obtain the system test results. 2. Analyze the experimental results. Through the above design, the system test process is completed, and the specific system test results are as follows. According to the above test results, the error rate of the designed system is significantly lower than the original system. Therefore, the data processing and encryption or decryption process of the system can effectively improve the data integrity in the data processing process and ensure the security and integrity of the database data content. The data processing process of the original system is relatively simple, and it is easy to create a situation of data missing. which does not meet the requirements of data security. In conclusion, the encryption and decryption performance of the design system in this paper is better than the original encryption and decryption system. Applying the design system in this paper to display life can effectively improve the internal security of the database. The final part is the concluding remarks. Because the traditional heterogeneous database encryption and decryption system has a high error rate in the process of encryption and decryption. This paper designs a heterogeneous database encryption and decryption system based on data mining. Through the data acquisition equipment, data storage equipment, and system data transmission equipment design system hardware, use data mining methods to process the data in the form of homomorphic encryption, complete the database encryption and decryption system software design. The experimental results show that the error rate of this system is low, and the encryption and decryption performance is better than the original encryption and decryption system. We should popularize the design system in this paper and improve the security of heterogeneous database in daily life. In this design, the description of the data processing part is relatively simple. In future applications, if there are data processing problems, they should be corrected in time to ensure the effectiveness of the data. The abstract of this paper is, in view of the problem that the error rate is too high in the use of the original heterogeneous database encryption and decryption system, the original encryption and decryption system is optimized by data mining calculation, and the heterogeneous database encryption and decryption system based on data mining is designed through the data acquisition equipment, data storage equipment, and system data transmission equipment to complete the hardware design of the system. According to the database user rights to design the database encryption dictionary, using data mining technology to complete the data preprocessing, using the form of homomorphic encryption to complete the encryption and decryption process of the database. At this point, the implementation of heterogeneous database encryption and decryption system designed based on data mining. In the system test link comparing with the traditional database encryption and decryption system, by comparing the bit error rate, it is verified that the design system can effectively reduce the bit error rate and improve the database security.
Hello, ladies and gentlemen. My name is Zhu Chen. I'd like to present my paper here, Design of Medical Database Information Query System based on Android. I'd like to present my paper from 5 points. 1. Introduction. 2. Hardware design. 3. Software design. 4. Experiment. 5. Concluding remarks. Firstly, I'd like to make a brief abstract. We designed an Android-based aesthetic medicine database information query system bringing single-chip microcomputer is selected as the processing core, and the hardware part is designed by analyzing the controller, development board, and the circuit connection part. The software part designs the web architecture, uses the app program to interact with the user, calculates the redundant weight value of the system data according to the size of the weight value, uses the SOAP serialization envelope object to describe and completes the implementation of the query system on Android. The experimental results show that, compared with the traditional query system, the query time of the ethnic medicine database information query system based on Android is the shortest. Introduction. 1. Ethnic medicine is an important part of the treasure house of traditional medicine. Ethnic medicine refers to the medicine used by ethnic minorities in China. 2. There are many kinds of ethnic medicines, but the integration of them is difficult. 3. The Chinese government attaches great importance to the inheritance and development of ethnic medicine. 4. With the development of mobile internet, it is easy to realize the ethnic medicine information query system. 2. Hardware design. 2.1. Controller and development board. Bringing single-chip computer is selected as the processing core of the controller, which receives and processes the index data related to the query system. 2.1. Controller and development board. As shown in Figure 1 above, Group P0 port is connected to the circuit driving the LCD display. Group P1 port is used to store the input ethnic medicine data. Group P2 port controls the LCD display driving signal of the query system. Group P3 port is used to query the change of system information, and the specific allocation of I/O port is shown in Table 1. Development board ARM processor is selected as the processor of development board, and its 32-bit reduced instruction set processor architecture is used to be compatible with multiple 8-bit and 16-bit devices. The chip uses S3C2440 microprocessor, which is a 1632-bit RISC embedded microprocessor integrated with ARM 920T core. It supports 400 MHz main frequency, up to 522 MHz. Using LCD display, it collects the Ethernet RG45 interface. 3. Software design. 3.1. Design web architecture. The presentation layer in the web architecture is divided into web management end and Android client. The web management end is developed by ASP.NET 4.5 using IE browser to realize the interface with users. Android client is developed by Android technology using app program to interact with users. The design business logic layer is responsible for key business processing and data transmission. The operation and logical judgment of the database are processed in this layer. The processing of ethnic medicine information and Open Web Service interface of the system are processed in this layer. The data access layer is responsible for database access, meaning providing data for the business logic layer. 3.1 System Function Module. According to the requirements of the system software is divided into two parts. One is web server, including system management module, role management module, user information management module, ethnic medicine information management module, web service interface management module, and other major functional modules. The other part is Android client, including user registration module, personal information management module, query module by Chinese name of ethnic medicine, query module by ethnic medicine in ethnic language, and other sub-query modules, as shown in Figure 4. 1. System Management Module. The main function of this module is to manage the entire ethnic medicine information system. 2. Role Management Module. This module mainly sets roles for users, which represent permissions. Different roles have different permissions with different functions. 3. User Information Management. This module mainly manages each user's personal information. 4. Ethnic Medicine Information Management Module. This module is the data core module of the entire system, mainly including information processing work, such as the entry of ethnic medicine information, review, and correction. 5. Web Service Interface Management Module. This module is the external interface module of this system, used to provide external services. 6. User Registration Module. This module is used for users' personal registration. 7. Personal Information Management Module. This module is used for the management of users' personal information, including password modification and other information. 8. Query Module. This module is used to query ethnic medicine information using various conditions by users. 3.2 Calculates system data redundancy weight value. Here we have 5 formulas. In Formula 1, U is the number of horizontal and vertical lines in the matrix, and VIG is the degree coefficient, which is generally taken as 1 to 10. Therefore, for Formula 1, the degree of redundancy influence can be expressed as Formula 2. In Formula 2, normalize each column of data in judgment matrix C to get matrix C, add each row of C, to get vector C, and use some product method to get the maximum eigenvalue of vector and get Formula 3. In Formula 3, alpha max is the maximum eigenvalue, and R is the coefficient of the sum product method. Using the random consistency ratio WG to judge the consistency of the largest characteristic root, the following results are obtained in Formula 4. In Formula 4, WG is the consistency index, and RG is the average random consistency index. Therefore, the final weight value of each information can be calculated according to the consistency index. In Formula 5, M is the order of judgment matrix. The Formula 3 and 5 are combined to synthesize the random consistency table to get, well, matrix C means WG is less than 0.1. The normalized eigenvector can be used as a weight vector, and the final result of Formula 2 is the weight value of the weight value index of the final information. Repeat the above calculation process. The final calculates all the weight values in the information base. Then, according to the size of the weight value, the database with large import weight value is arranged. Experiments 4.1 Experimental preparation. The tools used in the development process include 1. .NET framework 2. C# program language 3. JavaScript program 4. Android Studio. .2 Analysis of the experimental results. Here we can see 3 diagrams. A. Experimental results of a traditional query system 1. B. Experimental results of a traditional query system 2. C. Experimental results of information query system of ethnic medicine database based on Android. Now, I'd like to make a conclusion. This project develops an ethnic medicine data information query system based on Android platform by using a variety of computer technologies. After the system is completed, it will be deployed in the mobile intelligent terminal, which is convenient for users to carry around. It not only increases the way of ethnic medicine knowledge dissemination, but also improves the efficiency of knowledge dissemination. This system provides convenient and quick learning tools for medical learners at home and abroad, provides good help for researchers to acquire professional knowledge of ethnic medicine, and provides powerful help for the dissemination, research, and sustainable development of ethnic medicine. In the process of medical database information query, the problem of medical database information security is not considered, which leads to the decline of the data quality. In the future, we will focus on the research of medical database information encryption technology to ensure the information security of medical database. This is my presentation, and thank you all.
Design of multi-agent-based decision system for building spatial planning. Abstract. In view of the low efficiency of traditional system planning, a multi-agent-based decision-making system for building space planning is proposed. The spatial characteristics of traditional villages in southeastern Chongqing are analyzed, and the overall structure is designed. BS 3-layer architecture is adopted, map object functional components are selected, and web browsers are set up to facilitate information retrieval. According to the actual situation, the web server is divided into application hierarchy or scale, server structure, and hardware type. Design the spatial decision-making information system by using various data and information, and process the business and basic information of the enterprise according to the information processing system of public participation. Two kinds of distributed database systems are designed to accommodate different databases for different purposes and improve the performance of the whole system. Under the natural environment, agricultural production and living conditions, design the spatial planning decision plan. According to the experimental results, the maximum planning efficiency of the system can reach 97%, providing a guarantee for building safety construction. Keywords: multi-agent, architectural space planning, decision-making, public participation. Introduction. In practice, many business models have been formed by experts in the field of architectural spatial planning and decision-making, which urgently needs a platform for unified organization, management, and sharing. At the same time, a large number of planning and implementation evaluation tools have been accumulated in the process of building spatial planning and decision-making information construction, which adopt different technology development systems and depend on different operational support environments. In order to enable relevant users of planning business to operate and use directly on the interrogated and unified decision-making and management platform of architectural space planning, it is necessary to establish a unified environment supporting the operation of architectural space planning and business tools. Build up a group of architectural space planning and decision-making tools and make them play a greater application value. Architectural spatial planning decision-making system is a complex system whose spatial evolution is characterized by a large number of dynamic and adaptive micro-behavior subjects, enterprises, residents, farmers, and various organizations, etc., as well as the non-linear interaction between the behavior subjects and the environment, producing discontinuous architectural spatial decision-making behaviors. Because of its static characteristics, the traditional decision-making system, architectural spatial planning, cannot reflect the interaction process of many spatial time accumulation and spatial dimension in urban planning decision-making. The more difficult the spatial decision-making behavior of urban planning participants is to be effectively expressed, the more difficult it is to deal with the planning results. And there are certain restrictions on the acceptable level, oriented to the needs of urban planning and relevant theories of multi-agent and intelligent science and technology. Build something that can clearly express the city planning to participate in decision-making behavior, subject space, dominant feature space for urban planning decision system. And based on the build system, carried out the architectural space planning decision system and analysis of applied research auxiliary to recognize and solve encountered in the process of architectural planning related unstructured problems, so as to enhance the scientific nature and rationality of architectural space planning decision-making in order to promote the sustainable development of city decision-making to provide advanced technical method and reference. The overall architecture. The southeastern area of Chongqing is located in the Basin Age Mountains, where the two mountains of Dalou Mountain and Wuli Mountain meet in the southeast of Sichuan Basin. 4 provinces of Chongqing, Hubei, Hunan, and Guizhou are merged, including Qianjiang Development Zone and 4 minority autonomous counties, including Shizhou, Pengshui, Youyang, and Xiushan, covering an area of about 16,900 square kilometers, accounting for 20.5% of the total area of the city. There are 28 ethnic minorities including Miao, Tujia, Meng, Hui, Qiegui, Dong, Zang, Yi, Hani, Zhuang, Man, and Yao. At the end of 2007, the registered population of Southeast Chongqing was 3,549,400, of which 86.96% were agricultural. Architectural space planning decision system based on the planning space database, the spatial planning oriented visual modeling, spatial planning tool group building, multi-dimensional comprehensive decision support model, and on the basis participatory planning decision support technology, computer technology, geographic information system technology, the remote sensing technology, communication technology, network technology, space planning, and the theory of system science and comprehensive decision method is applied in the spatial planning and management of the interrogated system, implements the effective interrogation of spatial planning tool and space planning decision-making model library building, service, and management for the decision of spatial planning provides a strong support. It also provides a set of reliable and efficient analysis tools and decision analysis means for spatial planning. The overall system framework is divided into 5 layers from bottom to top: basic layer, architectural layer, core data layer, operation support layer, and application layer, as shown in Figure 1. Basic layer, including basic supporting environment, hardware infrastructure, software infrastructure, and network infrastructure. By establishing the building space maintenance database, the functions of storage, management, analysis, and processing of various building maintenance information can be realized. It is used for the management and planning of building space planning and maintenance to provide basic data support. Architectural layer, including standard system and exchanging system, using scientific methods to realize quantitative analysis and calculation of building space status, providing data support for land sustainability evaluation and space utilization planning. Core data layer, including data metadata database, basic database, professional database, and management database, which provides scientific basis for the sustainability evaluation of small space buildings. Through this system, the appropriate grade of land in each block of buildings can be determined objectively and accurately, providing technical support for further governance work. Operation support layer, including model library and toolbox. It can realize the optimization of building utilization in small space, formulate the optimal utilization mode of building in small space, and provide spatial information support for decision makers in order to obtain the best decision-keeping scheme. Application layer, including planning results management, planning decision analysis, participatory decision support, and shared services. This layer mainly has a good user experience interface, which can realize system functions through simple operation. System hardware architecture. Based on the regional characteristics of southeastern Chongqing, this paper studies the rural settlement landscape and considers the following 3 feasibility points for the establishment of the research object. First, the urbanization level in southeastern Chongqing is very low, and the rural population accounts for about 90% of the total population, which lays a necessary material foundation for the study of rural settlement landscape. Second, the southeast of Chongqing is a typical mountainous region, which is a typical karst landform. It has special topographic and geomorphic characteristics, abundant natural and cultural resources, complex engineering construction, unique landscape and other characteristics, and high landscape sensitivity, which is an important condition for the study. Thirdly, the minority population in the southeast of Chongqing accounts for about 70% of the total population, among which Tujia and Miao are the main minority in the southeast of Chongqing. The rural settlement landscape in the southeast of Chongqing has obvious regional characteristics and ethnic characteristics. This provides necessary conditions for the study of rural settlement landscape based on the regional characteristics of southeast Chongqing. The hardware architecture of the system adopts a 3-tier architecture based on BS, as shown in Figure 2. The browser side is developed with multi-agent technology. At its main module is the public participation function module developed based on Java applet, PPGeoTool module, including the geography operation submodule and information feedback submodule. The submodule of geography operations realize the basic geographic operations of client public, including attribute query, location query, spatial analysis, map browsing, map editing, display output, etc. The information feedback submodule is used to realize the information interaction between the public and the system, including the inquiry of the information related to the planning project, the input, and preservation of the information related to the public participation in decision-making and the public resume. On the server side, map object functional components provided by ESRI are used to develop corresponding functional modules in VB language, including submodules of public participation information processing system and submodules of spatial decision-making information system. The submodule of public participation information processing system is used to realize the functions of statistical analysis, spatial analysis, model analysis, information database building based on data model, and information display output. The submodel of spatial decision information system is used to realize the spatial analysis function of traditional geographic information system and the auxiliary decision function of decision support system. On the basis of traditional geographic information database, public participation information database, and role database, the spatial analysis and decision-making of the system must introduce new analysis models and methods into the 10,000 square data of urban planning projects. Browser. A web browser is an application that retrieves and displays information about the World Wide Web. These information resources can be web pages, pictures, videos, or other content. They are marked by the uniform resource identifier, hyperlinks in the information resources to facilitate the user to browse relevant information. The browser is accessed through a client project known as a web browser because it allows users to roam based on hypertext links without having a purposeful queries. The browser is software that displays the contents of HTML files on a web server or file system and lets users interact with those files. Web browsers primarily interact with and retrieve web pages from web servers over the HTTP protocol, which are specified by URLs, usually in HTML format, and specified by MIME in the HTTP protocol. Web server. Network server is the core part of computer lane. Its efficiency directly affects the whole network operating system. Web servers have run the main function of the network operating system, control and coordination of all the work, the computer in the network, the maximum to meet the requirements of customers and make a response and handling storage and management in the network sharing resources, to monitor and control network activity, to actual network management, resource allocation system, to understand and adjust the system running state and shut down or start some resources, etc. The web server structure is shown in Figure 3.
Hello everyone, my name is Tang Li. The topic is Design of Online Education Resource Gathering System based on multi-level SDN architecture. The first part, Introduction. In the process of global education information, streaming medium technology has been widely used in the field of education. Modern distance education system based on network provides abundant information resource, friendly interaction, performance, and excellent openness. The transmission of multimedia files on the network has become an important technical problem in modern distance education system. The small size of streaming medium, less resource consumption, short waiting time, multiple medium types, low purchase cost, and various compression rates provides effective solutions for modern distance education system. With the development of online education, the scale of online education data has become larger and larger, and the real-time requirement of online education data processing is higher and higher. The traditional online education resource gathering system has a poor real-time performance in resource gathering. Educational Resource Gathering System (SDN) architecture is a new software-based network architecture. Layer and forwarding layer as well as centralized network state control to achieve transparent multi-level control network strategy of the underlying infrastructure. The programmability of the network provides automatic management and unified control functions for the network and effectively solves the current problems, the problems of poor flexibility, limited expansion of resource, and diversification of server types in networking. The system designed in this paper completes the design of online educational resource gathering system based on multi-layer SDN architecture from hardware and software aspects. The second, Online Education Resource Gathering System Framework. The system designed this time is mainly divided into 3 layers: the system layer, the application layer, and the data layer. It also includes an administrator login interface, teaching material management interface, and member management interface. The main function of the administrator login interface is to enter the user name and password. Judgment can modify, add, and delete the content of the system. Teaching material management interface, which mainly manages the content of tutoring materials. All materials can be displayed in full and can also be displayed by type. Member management interface, administrators can delete, modify, and lock users and can retrieve passwords for users who have forgotten their passwords. The third, hardware design of online education resource gathering system. 3.1 Controller design. The controller hardware can be divided into 2 parts. One is the USB control chip and the other is the JTAG main control chip. The controller uses the USB control chip to implement the USB protocol to communicate with the PC. At the same time, by operating the JTAG main control chip, the data output on the JTAG bus conforms to the IEEE 1149.1 standard, so as to achieve the purpose of controlling the JTAG bus by a PC. The EZ USB FX2 chip CY7C68017 produced by the company is a USB interface control chip, and the CY7C68013 chip includes an enhanced 8051 processing device, a several port engine, a USB 2.0 transceiver, 8.5 KB on-chip RAM 4 KB FIFO memory, and a universal programmable interface. Its chip can be connected with any or depth. It also supports all current universal bus standards. The USB interface chip of this system is used as an intermediary for data transmission, and it can be completed simultaneously with a portable computer. The exchange of control information and the exclusion of the control process. Transmission mode among the 4 transmission modes defined by the USB protocol. Batch transmission and isochronous transmission are faster. However, batch transmission has error checking, which can ensure data transmission correctness in this solution because of the high requirements for the accuracy of the data. The batch transmission method is used. The 8051 running code is downloaded from the PC terminal. This way, the system software modification and function upgrade are more flexible, and external connection is also eliminated, making the circuit more concealed and reliable. 3.2 Expansion board design. The W5100 network expansion board is used to provide communication functions for the innovative education network ecosystem. The expansion board integrates a 10% Ethernet controller to meet the system design requirements. This chip supports hardware TCP or IP protocol, embedded 10 base 100 base TX Ethernet physical layer, and supports auto answer. ISO-link 4 independent ports, internal 16 KB memory as TX or RX cache. Working the voltage is 3.3 V and the I/O port can withstand 5 V voltage. At the same time, it contains a variety of indicator lines, where L represents the programming inductor, link represents the network has been linked. This indicator is flashing when sending the receiving innovative education network data. RX will flash when the network is receiving data. TX light will flash when the network detects a collision. 3.3 Processor Design. ADSP21161N is a powerful 32-bit floating-point DSP chip recently launched by ADI of the United States. It uses a super-Harvard structure, has multiple internal bases, high-speed computing units, large capacity memory, and flexible end-device internal interface. The core operating frequency can reach 100 MHz, and the external bus operating frequency can reach 50 MHz. Since it includes two sets of processing units inside, each set uses a three-target pipeline structure for processing, so the processing speed can reach 600 Mbps to achieve the DSP. The function of low operation quantity and high processing capacity can reach power consumption. The on-chip SDRAM controller can directly manage SDRAM, and multiple DSPs can coordinate and use SDRAM well, so that an integrated processing system, two sets of two-way high-speed link data transmission. Each link port is supported by an independent DNA controller and send-receive data FIFO, which can perform high-speed data transmission up to 100 MB per s, greatly improving parallel processing compatibilities can be used to form a loosely coupled distributed parallel system. In addition, there are communication ports such as SPI interface, programmable I/O2 pins, and sinocultures serial ports. 4.1 Construction of online education resource database. Construct online education resource scheduling database to reduce the time for online education resource gathering. The distance education system includes 8 entity classes: student entity class, teacher entity class, system administrator entity class, core subject entity class, role entity class, text questions. The entity class and problem entity class are as follows. First, the student entity class attributes student member, username, password, real name, class, mailbox, landline, address, mobile phone, and so on. 4.2 Relevant dimensional factor extraction of resource information flow. The traditional method uses the auto collection matching method of resource information for resource gathering. when the interference in the data transmission channel is large and the prior date of the resource information flow is lacking. The balance of resource gathering is not good, and the accuracy of registration is not good. In order to overcome the shortcomings of the traditional method, Gao designed an online education resource gathering system based on a multi-level SDN architecture. The FITO expresses the collection dimension characteristics of the resource information flow and firstly gives the function of information resource gathering. As the time deny increases, the focus performance of the open network large database resource gathering process improves. It can be seen that by extracting the accessed dimension feature of the resource information flow, the open network large database resource gathering problem can be transformed into a multivariate unknown parametric channel adaptive equationative problem. As the time deny increases, the focus performance of the open network large database resource gathering process improves. It can be seen that by extracting the associated dimension features of the resource information flow, the open network large database resource gathering problem can be network large database resource gathering problem can be transformed into a multivariate unknown. 4.3 Online education resource gathering. According to the result of the feature extraction of the above resource information flow, resource load balancing control and channel adaptive equalization design are used to implement the open network large database resource gathering. 5. External comparison. In order to verify the executiveness of the multi-level SDN architecture based on online education resource gathering system designed this time, an external comparison was performed to ensure the rigor of the experiment. The traditional system was compared with the designed system, and the online education of the two systems was compared resource gathering time. 5.1 External platform construction. Set up a simulation platform based on Mininet. Mininet is a lightweight software-defined network test platform that can simulate a complete network host, link, and switch on the same computer. The simulation platform supports custom, complex technologies and can be on the same computer. A complete network host, link, and switch are simulated on the plane. Use the above experimental platform for experiments. During the experiment, an online education platform was selected as the explanation object, and 7 experiments were performed, and the gathering time of online education resource was compared with the 7 experimental process. 5.2 Analysis of external results. Based on the analysis of the above external comparison results, it can be seen that the online education resource gathering time of the system designed this time is shorter, and the overall scattering time is less than that of the traditional scattering system. The traditional online education resource gathering system has a longer scattering time, which in the second experiment, the scattering time was longer than that of the system designed this time. Therefore, the above experiments can prove that the system designed this time can include the scattering time of online education resource and improve the real-time performance of online education resource gathering system. 6-point conclusion. An online education resource gathering system based on a multi-level SDN architecture is designed to solve the problem of long time for online education resource gathering in traditional systems. It proves that the designed online education resource gathering system improves the information registration ability of resource gathering. The overhead is small, the technology indicators are superior, and have high application value. There are still some imperfections in this design. If you design the parallel scattering algorithm of the teaching resource access gathering system, then combine linear programming and numerical values, analyzing the theory, the effect will be better. That's all. Thank you.
Hello, my name is Zhang. I come from State University. My topic is designing and testing of a semi-physical, quick video streaming simulation platform. I'll introduce from the following aspects: background, key mechanism, simulation platform, improved algorithm, algorithm validation. Video exchanging and browsing via social networking websites and mobile apps is becoming a regular application in recent years, aiming at improving the quality of experience of users. The next generation protocols such as HTTP2, QUIC, and HTTP3 have been proposed. However, HTTP often incur huge connection establishment delay with complex multi-connection management overhead. In 2012, Google presented QUIC, a new type of multiplex and circuit transmission protocol based on UDP. QUIC has several new significant features, including multiplexing and flow control that equivalent to HTTP2, encryption equivalent to transport layer security, and connection semantic reliability and congestion control equivalent to TCP. The key mechanisms of QUIC are connection processing, data processing, congestion control, and flow control, which I'll discuss in detail. The first is connection process. The client determines whether the all configuration parameters for the server are already exist locally. If yes, client says client hello to the server. Begin handshake. If the server receives client hello, it will calculate the initial key and replies to the server hello message, which is encrypted and with the initial key. The client receives server hello. Try decrypting it with the initial key. The client and the server drive the session key based on the initial key and switch to using the session key to communicate. If there's no configuration parameters of the server, the client sends the inchoate client hello named CHLO message to the server. The server receives CHLO message, replies ID message containing part of the configuration parameters of the server. The client receives RCID, stores server configuration parameters. Back here. Do it again. This is data processing. After receiving the package, the client selects a different process based on the different frames. If the package contains more than one frame, it will do this again. When the retransmission timer of ACK frame and the loss mode is timed out, the loss detection will be carried out. If the packet is lost and the lost packet number meets certain conditions, the congestion window will be reduced. In addition, upon receiving an ACK frame, if a packet with the latest reply is found, the congestion window will be increased. The stream frame contains the data content and the offsets of the stream and the length information. When the stream frame is received, the receiver puts the data into the cake, determines whether it is continuous with the caked data based on its offset and length information, and if so, updates better consumed. Then sending the window updates frame when the available window is less than half of the max receive window. Our semi-physical quick platform consists of three major models: Dash, Quick, and N-ary. Dash uses HTTP protocols to download and distribute content. The Dash protocol divides the media content into multiple smaller media segments for transmission. This is our general structure of the simulation system. The server is used to generate the video stream and carry out the video code. The Dash client receives, decodes, and plays the streaming video. The video stream data output by the Dash server are delivered by Quick. After being multiplexed and sorted by the Quick server, the video stream data are assembled into UDP frames, and then enter into the N-ary simulation network. The simulated network will incur delay, jitter, and loss to the UDP frames, to simulating the affections of a raw network on the quick transportation. Afterwards, the data enter into the quick client, where they are error corrected, resorted, confirmed, and required to be retransmitted. The resulting stream is passed to the Dash client, where the video is decoded and played. This is simulation system specific implementation. The Dash Quick communication scheme is based on adaptive streaming media and changes the selected media block from TCP transmission to quick transmission. A quick client is created in the Dash client, and the Dash client interacts with the Dash server through the quick server client interactions that providing a transportation link. The connection between QUIC platform and the NS3 platform is implemented based on the datagram socket communication technology. As NS3 has difficulties to deliver the raw stream data packets due to its capacity, the data packets are treated in a modified way. When the QUIC client sends a packet, it first transmits the packet size information to the NS3 client through the socket process communication mechanism. Then the actual data packet is transmitted to the receiving buffer or the QUIC server via local transmission. The NS3 client first puts the packet size information into the cake, and the simulator gateway node will generate a dummy data packet with the same size and header, and sends it through the simulated network. When the dummy packet is received by the NS3 receiving node, the NS3 servers handle read functions sends the correctly received packet number and the corresponding transmission delay to the QUIC server via the socket. The lost packet in NS3 will incur a raw packet loss in QUIC. The QUIC server puts the received NS3 message into the NS3 message receiving buffer. Each time the QUIC server receives a local transmission packet from the QUIC client, if the packet is not lost after a certain delay according to the delay information, the packet is forwarded upward. When the packet processing is completed, the NS3 information buffer will be traversed again until NS3 message cake is empty. The QUIC server enters a state waiting to receive the actual data packet transmitted locally by the QUIC client. We do some verification tests after the system is built. In the first verification, the connectivity of the simulation platform is tested without packet loss. In this case, we have tested that QUIC, NS3, and the dash are connected as we expected. The smoothly displayed video showing our treatment of the simulated packet streams is correct. The second verification is showing the effects or losses introduced by the NS3 network on the video playback qualities. As shown in the table, the playback of dash was tested with different packet loss rates, with different QoE performances. We proposed an improved algorithm for QUIC, large delay ACK discarding, named LDAD. When the network suffers from the congestion or a sudden interference, the drop in rate can prevent the network from further congestion. But for the sudden interference, which is almost instantaneous, so the drip is unnecessary. By discarding ACKs with large delay, the unnecessary drop of the rate caused by burst interferences can be avoided. The packets will be judged by several modules. For the downlink packet received by the current base station, it will judge whether it's a QUIC packet according to the port number. Then it enters the downlink packet and uplink ACK mapping module if it's a QUIC packet, where it's joined with the current packet to the mapping table according to the judgment mechanism of module. Then it enters the sender state estimation module to update the parameters, and finally goes into the timer module to perform necessary timer updates after updating the parameters. For an uplink packet, the process is approximately the same. The base station determines the type of the received uplink packet. If it's a quick packet, the ACK-only packet determination module is activated, and the ACK-only packet estimation algorithm in the module determines whether the current packet is an ACK-only packet. If it's a quick ACK-only packet, then it enters the ACK interception module, where the instantaneous RTT of the current ACK is calculated according to the mapping table. The mapping result will determine forwarding the ACK-only packet directly or not. The subsequent process is the same as the downlink process. The abnormal ACK-only cake model is to store the ACK-only packet correctly intercepted. This is our simulation scene. We can see the simulation result. The blue line in the figure are the changes of the average throughput of the quick server with the BLER with the algorithm is used or not respectively. From the figure, we see that the throughput decreases with the increase of the BLER in both cases. The reason is that as the probability of packet loss at the physical layer increases, the number of retransmissions of the underlying data packet increases, and the end-to-end instant delay jitter increases and the time delay fluctuates more frequently. As can be seen from the figure, compared with the original case where the algorithm is not used, almost all the algorithms used in the current test scenario can bring gains, especially with the BLER is 0.05, 0.1, and 0.15. The red line indicates the variation of the quick server throughput with the physical layer packet loss rate when the algorithm is not used or not. Similar to the test in the LTE scenario, the quick server throughput and the two cases both decreases with the increase of the packet loss rate at the physical layer. The transmission performance is basically the same with the packet loss rate at the physical layer is small. However, as the packet loss rate increases, the performance gain after the use of the LDAD becomes obvious, especially in the case of a packet loss rate of 0.15. The black solid line indicates the results of using algorithm with 20% estimation error in LTE. It can be seen that using the algorithm can bring a large gain, no matter there is an estimation error or not. In a word, our proposed algorithm can bring significant gains in poor wireless environment. Thank you.
Hello, I'm Tian Yiwang, research engineer at Institute of High Performance Computing (ISTAR). Today I will talk about our work, deep N-ary error correcting output codes. Ensemble learning is a process where multiple models are strategically generated and combined to solve a particular computational intelligence problem. An ensemble-based system is obtained by combining diverse models such as classifiers to improve the classification performance of the model and reduce the likelihood of an unfortunate selection of a poor one. In many ensemble methods, data-independent ensemble methods like error correcting output codes attract increasing attention due to its easiness of implementation and parallelization. In multi-class classification problem, the task is to decide one label from k larger than 2 possible choices. Error correcting output code is a meta-method which combines many binary classifiers and is designed for solving this problem under the ensemble learning formulation. The ECOC encoding approach aims to construct the ECOC matrix with shape NC multiplied by NL, which elements randomly choose from -1 and 1, where the classes corresponding to 1 and -1 are considered as positive and negative classes, respectively. By doing so, each class in multi-class classification problem is assigned by a set of binary units. Thus, it can be easily decomposed to the binary classification problem. In the framework of ECOC, the code length also indicates how many binary classifiers are required, where each classifier is learned to predict the corresponding binary labels. N-ary ECOC is an extension of traditional ECOC approach, which performs to decompose the original classes into n meta class rather than binary class, where 3 smaller than n and smaller than nc. Both theoretically and empirically findings demonstrate that N-ary ECOC is superior over the traditional ECOC, where N-ary ECOC is able to achieve larger row separation and lower column correlation. Moreover, N-ary ECOC is more general, as traditional ECOC can be treated as a special issue of N-ary ECOC. Recently, deep learning methods significantly advanced the multi-class classification performance through learning features in an end-to-end fashion. Fortunately, integrating ECOCs, especially N-ary ECOC, with deep neural networks is not straightforward and yet fully explored in the literature due to the high expense of training based learners. In this work, we focus on addressing an ensemble of deep neural networks in a framework of ECOC. Compared to other ensemble techniques, such as boosting, ECOC is easy to parallel due to the independence of base learners. To integrate the ECOC framework with deep learning methods, we mainly investigate the following 3 questions. Number 1, do we necessarily independently train all the deep-based learners from scratch or for other situations? Number 2, whether the N-ary ECOC framework still has an advantage over other data-independent ensemble approaches with deep neural network. Number 3, any new suggestion on the choice of the meta class number n and number of base learner NL? To answer the first question, we are going to propose 3 different parameter sharing architecture. For example, no partial and full parameter shares. Here we show an example of deep learning model with 4 convolution blocks and 1 classifier. For the no parameter sharing strategy, we train NL-based learner independently, which means that the feature encode layers of each base learners are trained by the inputs directly and do not interact with other learners. The partial parameter sharing strategy contains shared and task-specific layers. The first 3 feature encoder layers are shared by all the base learners, while the top encoder layer is task-specific, which is only optimized by the corresponding meta class objectives. The full parameter sharing strategy simply set all the feature encode layers to be shared by all the base learners except the public classifiers. Obviously, the node parameter sharing strategy contains most parameters NN, then the partial sharing strategy NP and the fully sharing strategy NF is least. Say NN is larger than NP and larger than NF. For the remaining two questions, we investigate through the experiments. To study the proposed question for deep N-ary ECOC, we conduct the experiments on 4 image classifications and 2 text classification benchmark datasets. The 4 image datasets are widely used image classification datasets in the computer vision community, while the TREC is a question and answering dataset which involves classifying question sentences into 6 question types. Say whether question is about person, location, numerical information, etc. The SST is a sentiment analysis sentence data with 5 classes and that range from 0, most negative, and to 5, most positive. The statistics of these data sets are described in the table. To train the image classification datasets, we adopt the CNN-based models. For managed dataset, we choose a LaNet and train from scratch. For Flower 102 dataset, we select the AlexNet due to the difficulty for the AlexNet model to learn consequential and representative features from the small training dataset for Flower 102 directly. The AlexNet is not trained from scratch but obtained by fine-tuning and pre-trained AlexNet model, which is trained on the IOS VLC dataset. For the CFAR 10 and 100 datasets, we build a model with 8 convolutional layers and 2 full connected layers named as CFAR CNNs. As shown in the figure, where the 8 convolution layers are divided into 4 groups, they share the same structure with different numbers of filters and kernel bits. To train the text classification datasets, we construct a 3-layered bidirectional LSTM model with character level CNN and self-attention mechanism for both TRES and SST. The character level CNN learned the character features to represent a word from the character sequences of such word, which can help to enrich the meaning of the word features, especially for rare and out-of-vocabulary words. The word-level bidirectional LSTM performs to learn contextual representation for each word. The self-attention mechanism encodes the learned contextual affluent word-level feature consequence of bidirectional LSTM into a single vector by considering the importance of each word-level feature. To study the best choice of meta class number N and number of base learner NL for different tasks, we test different meta classes and number of base learners, and the statistical information is shown in the table. Here we present the ensemble accuracies of different methods on the benchmark datasets. We can observe that compared to single model, the improvement ratio of N-ary COC is inverse relation with single model performance. That is, the improvement of N-ary COC scheme is more prominent if the performance of the single model is lower. Second, the N-ary ECOC scheme outperforms ECOC and NRI ensemble methods on most image and text datasets, except for the TREC text dataset. Specifically, N-ary ECOC always performs better than NRI. Here we evaluate the effect of meta class number N. From the results, we can observe that For dataset with smaller number of NC, we observe that performance of ensemble models with different N are relatively stable. The highest ensemble accuracies of minutes are CFAR 10 and SST achieved when N is equal to 3, N is equal to 4, and N is equal to 5 respectively. And the best performance of TREC is obtained at N equal to 3 if we do not consider the ECOC. After that, the performance of each dataset is gradually decreased with small fluctuations with an increasing number of meta-class N. The performance of ensemble models with different N fluctuates significantly on the datasets with a larger value of NC. The ensemble accuracy improves gradually with the increase of meta-class N and reaches a summit. Then mildly decreases are obtained after the optimal performance. Here we evaluate an effect of base learner number NL. In the experiments, we fix a meta-class number N. From the result, we observe that smaller number of base learners are required of a dataset with small NC than that of large NC to reach optimal ensemble accuracies generally. For example, MINIST and TREC only need 50 base learners to get the optimum, while SST obtains best accuracies with 6 base learners and CFAR 10 requires 80. A special issue that Flower 102 holds a large NC 102 classes, but only requires 60 base learners to achieve the optimal ensemble accuracies. It is because the pre-trained ALEX9 is utilized, which already encodes a variety of abstractly and typically well-learned features. Here we study the effect of 3 different parameter sharing strategies in the framework of ECOC, N-ary ECOC, and NB-IoT, where ECOC is equivalent to N-ary ECOC with N is equal to 2, and NB-IoT is equivalent to N-ary ECOC with N equal to NC. For the SST dataset, we observe that when the number of meta-class N is small, both partial and no-share models improve significantly with the increase of NL. The partial share generally outperforms the number and the full share except when NL is less. When the number of meta-class N is large, the performance of the 3 strategies are stable, and the improvement of no-share is most significant with the increase of NL. From the CFAR 100, we can observe that ECOC model with no-share strategy fails to achieve satisfactory performance, while partial and full share strategies with ECOC improve significantly with the increase of NL. For the N-ary ECOC with small number of meta-class, we observe that partial share strategy outperforms no and full share. For the NRI model, no-share strategy is comparable to partial share when NL is small. It always performs best when NL increases, meanwhile the performance of full share is the worst. In general, through the experiments, we can conclude that for the dataset with a small number of classes, the performance of no-share model is better than or equal to that of the partial share model. Thus, no-share strategy is just to be chosen. For the dataset with a small number of classes, when the number of meta-class N is large, these 3 strategies perform stable. For the datasets with a large number of classes, when the number of meta-class is small, the performance of partial share model is the best. For the dataset with large number of classes, when the number of the meta-class is large, no-share strategy model outperforms partial and full share models in the most cases. Thus, no-share strategy should be preferred in such a case. If the number of metaclasses is large and the performance difference between three sharing strategies is marginal, then full share could be suggested due to its parameter efficiency. Thank you.